Hey everybody. Today I decided I'm going to teach you everything you need to know to get started working with JavaScript. Throughout this course, we'll be working on a few projects you could add to your portfolio, which include, but are not limited to, a digital clock, a stopwatch, a functioning calculator, a game of rock, paper, scissors, an image slider, and our final project will be a weather app that fetches data from an API. If that sounds good to you, I encourage you to sit back, relax, and enjoy the show. Hey, if you don't mind, please give this video a like, post a random comment down below, and subscribe if you'd like to be a fellow bro. It doesn't cost you anything. Thank you. JavaScript is a programming language used to create dynamic and interactive web pages. JavaScript runs on a web browser such as Google Chrome, Safari, Edge, whatever you use to browse the internet basically. By using JavaScript, we can respond to user actions and transform user input whenever somebody interacts with our site. In this example, I have a calculator written with HTML. It's not very pretty, and it doesn't function. We have the framework that we need at least though. By applying CSS, we can add color and style to this calculator, but unfortunately it still doesn't function. By including JavaScript code, this calculator can perform actions, and is well, useful. So in this video, I'm going to show you everything you need to know to get started working with JavaScript. I would recommend knowing HTML and CSS before starting the series. I do have a full free course on my channel if you're interested in learning those, or if you need a refresher. If you don't know either, you could probably still get by watching this video. I'll walk you through both as we go along throughout the series. Now, before we do begin, you will need a text editor. One text editor that I recommend is VS Code, which you can download from code.visualstudio.com. For a step-by-step instruction of how to install it, feel free to check out the HTML and CSS series. With that out of the way, let's dive right in. So what we'll need to do is create a new project folder. In VS Code, you can go to the left toolbar, go to Explore. We will open a folder. I'll place this folder on my desktop just for convenience. I will create a new folder, which I will name Website to contain my website files. Let's select this folder. And we are now within our website folder. We'll need 3 files, an HTML file, CSS file, and JavaScript file. We'll begin with the HTML file. We can close out of this welcome window. I will name my HTML file index.html. In a website, the index.html file is typically used as the homepage. We have our HTML file. Next comes the CSS file. Mine will be named style.css. The CSS style sheet is in charge of the overall appearance of the web page. This can include fonts, colors, positioning, stuff like that. Then lastly, we have the JavaScript file, which I will name index.js. The JavaScript file is in charge of the interactivity of a web page. So altogether, we have structure, style, and actions. So rearrange these tabs however you like. I switch back and forth between the JavaScript and HTML file quite often, so I tend to put them right next to each other, but do whatever's most convenient for you. So to generate the necessary text to create a web page in your HTML file, in VS Code, you can type !, then hit tab. So here you can change the title of your web page if you want. I'll change my title to be My Website. And that's all we'll need for now. Now we'll need to link the style sheet to the HTML file. Now we are going to create a link tag. We can link an external style sheet to our HTML file. Within the link tag, there is a relationship attribute, shortened to REL. The relationship will be style sheet. We are linking a style sheet. Then the next attribute we need is the href attribute. Where is the CSS file located? Well, it's right next to each other. We only need the file name. So we are linking the CSS style sheet. Now our CSS style sheet is linked to our HTML file. Now we need to link the JavaScript file to our HTML file. We can do that by adding a pair of script tags. We will set the source attribute to be the name of the JavaScript file, index.js. Alright, everything should now be linked together. The last thing we'll need is the live server extension in VS Code. Go to Extensions. We will search for Live Server. It should be this one. We are going to install this extension. So whenever we save any changes to our files, the web page should refresh automatically. So now let's test this. You can go to File, Save, or use the shortcut. I'm just going to save everything. I'm going to right-click on our HTML file, then open with Live Server. And here's our web page, but it currently doesn't have anything. Let me just minimize this. I will readjust this window. Throughout this course, I'll have VS Code alongside a web browser. With our HTML file, we can add elements, such as an H1 element. These are typically used as headers. I'm going to say, hello, then save, and that should update automatically. Or you can press the refresh button, but since we have Live Server installed, we shouldn't need to. Then paragraphs are typically used for a paragraph of text. In VS Code, to generate a random paragraph of text, you can type lorem, then hit tab. Now we should have a random paragraph. I believe it's Latin. At least it looks like it. To change the style of our web page, we can go to our style sheet. To change the style of the body of our document, we will select body. I'll change the font family to something else. Font family. How about Verdana? There, we now have a different font. To increase the font size, you can set the font size property to be either in pixels or EM. Personally, I'm a fan of using EM. 2EM means 200%, where 3EM is 300%, but that's a little too big. Let's stick with 2EM. All right, and that is everything we need to get started. Oh, important note, you do want your script element at the bottom of the body of your document. Just in case there's an error with your JavaScript file, you do want all of the HTML elements to at least render first, before running any JavaScript code. All right, so let's delete our H1 elements and our paragraph element. We no longer need them for now. Be sure to save everything. We'll work with some basic output. I'm going to zoom in a little bit. To output some text, you can type console.log, add a set of parentheses, then a semicolon at the end. Within the set of parentheses, to output some text, you can either use double quotes, single quotes, or backticks. Personally, I'm a fan of using these backticks. This is known as a template literal. They're helpful with inserting variables, which we will discuss in the next lesson. Using either double quotes or single quotes or backticks, we can output some text. Let's say the word hello. Be sure to save. I'm holding Control S on Windows. There's no apparent output. We have to go to DevTools. So right-click on your web page, go to Inspect, then Console. And here's our basic output. Hello. For an additional line of output, we can console.log again. Let's print a different message. I like pizza. Let's save. And here's my second line of text. I like pizza. And I'm just going to move these windows a little bit. That's better. Throughout much of the series, we will be working with this window. Again, you have to right-click on your web page, go to Inspect, then go to Console. Now within our web page, to create an alert box, you can type window.alert. Add a set of parentheses, semicolon to the end. We'll use a template literal. We'll need a set of backticks. This is an alert. This should create a pop-up window. This is an alert. Let's create another. Let's copy what we have, paste it. I like pizza. Let's save. This is an alert, okay? I like pizza. Not sure why we need to tell a user that, but we can. Now we have comments. To create a comment, you type 2 forward slashes. Comments aren't used for output. They're used as notes for yourself or for other developers. This is a comment. So when I run this program, then if we were to go to our dev tools, we don't see this comment at all. They're not displayed as output. They're either used for notes for yourself or for other people. For a multi-line comment, you can type a /**. Anything that comes after will be a comment. This is a comment. You can see that the text is green. That means it's a comment. Again, we should not be able to see these comments. They're hidden. I'm going to turn this JavaScript code into comments just for the next part, because these window alerts are kind of annoying, to be honest. All right, now what we're going to do is populate our web page with some text. Within our HTML file, I will create an h1 element. H1s are usually used for headers or titles. There will be no text content yet, but I will set an ID. I will give this h1 element a unique ID of my h1. Feel free to pick a different ID, something you'll remember. I will also create a paragraph element. I will set the ID to equal my p, meaning my paragraph. So remember, there is no text content currently. Using JavaScript, we will add some text content. First, we need to select these elements by their ID, my h1 and my p. Let's do that here. We will type document, meaning the document of our web page, dot get element by ID. Do pay attention to the capitalization. What ID are we getting? Let's start with my h1. So copy the ID, paste it within the set of parentheses. Be sure you're including quotes as well. Follow this with dot text content. We will set this equal to, how about the word hello? Let me zoom out a little. Again, this can be backticks, single quotes, or double quotes. All right, let's type the word hello. Now when I save and refresh the page, that h1 element should display the word hello. Now this time, let's get our paragraph element with the ID of my p, my paragraph. Document.get element by ID. The ID that we're getting is my p. We'll change the text content equal to, what can we say? I like pizza. There we go. Hello, I like pizza. All right, everybody, so that's the basics of JavaScript. When working with basic output, you can use console.log, which we will be using a lot. To create an alert, you can use window.alert. To change the text content of an HTML element, you first have to select that element, then change the text content, then set it equal to some text of your choosing. All right, everybody, so that is the very basics of JavaScript, and in the next topic, we will cover variables. All right, well, it's time that we discuss variables. Do you remember from middle school or elementary school when you learned algebra? You had to solve for what the value of x was. X was some representation of a value. Well, that's kind of what a variable is in programming. It's a container that stores a value. The variable behaves as if it were the value it contains. There's two steps to creating a variable: declaration and assignment. To use a variable, we have to first declare it. We'll use the let keyword, then a unique variable name, like x, then a semicolon. So what we've done is declaration. Each variable name needs to be unique. If I were to declare another variable named x, we would run into an error, a syntax error. Identifier x has already been declared, so your variable names need to be unique. I can declare two variables, x and y, and they both have different names. That is fine, but they can't have the same name. The next step to creating a variable is to assign it a value. Once you declare your variable, you don't need to declare it again. So I'm going to assign x to equal some number like 100. We can use this variable x, and it will behave as if it was the value 100. Let me demonstrate. So if I was to console.log x, well then it's going to display 100. If I were to change this value to 123, well, x is now 123. You can do both declaration and assignment together. That would look something like this. Let x equal 123. This is both declaration and assignment. If you're creating a program and you know what your values should be, you can assign them a value right away. Sometimes you may want to accept some user input, so then you might do assignment later in 2 steps. It's really up to how you write your program. There's a few different data types in JavaScript. The first is number, like 123. Let's create a descriptive name for our variable like age. We will store a user's age. According to my analytics in YouTube, the average age of my viewers is 25. So let's say that my age is 25. Then if I was to console.log my age variable, it would behave as if it were the number 25. Let's create a few more variables. Another example of a number could be price. Let price equal $10.99. Maybe it's $10.99 or some other unit of currency of your choosing. Then we will console.log price, $10.99. What about a GPA, a grade point average? My grade point average is a solid 2.1. It's not great, but C's get degrees. Console.log GPA 2.1. Using a template literal, we can insert a variable using a placeholder. Within console.log, I will use backticks. Let's write a sentence. You are, then to insert a variable, use $, curly braces. Place your variable name within the curly braces. Then we can continue our sentence. You are variable age, years old. Let's create another sentence using console.log. The price is $, curly braces, price. The price is $10.99. I'm going to insert a $, before our price, and that looks better. Feel free to choose some other unit of currency. Okay, let's add a sentence to display our GPA. Console.log. Your GPA is : space. We're inserting a variable. We need $, curly braces. We're displaying our GPA. Your GPA is 2.1. Now, if you need to display the data type of a variable, you can use console.log, then precede the variable with the type of keyword. What is the type of age? Age is a number type. Price is also a number type. Same thing with GPA. They're all numbers. Let's go over a different data type. Let's go over strings. A string is a series of characters. Let's say we have a user's first name. To create a string, you can either use double quotes or single quotes. Personally, I like double quotes. Then you can type in some characters like first name. Let's say my first name is Bro. Feel free to pick your own first name. I will display the type of my first name variable, and it says it's a string, a series of characters. Then I will display my name. Console.log, first name, and it is Bro, or whatever your first name is, whatever you put here. Let's include our variable within a template literal. Your name is, add a placeholder, first name. Your name is Bro. What are some other examples of a string? Maybe somebody's favorite food. Favorite food. My favorite food is pizza. Type in your favorite food. Console.log. You like, add our placeholder, favorite food. You like pizza. Maybe if I like something else, like sushi, well, you like sushi. Okay, another example of a string could be an email. Let email equals, then type in your email. I'm just going to make one up. bro@gmail.com. Console.log. Your email is email. Your email is bro@gmail.com. Let me make the G lowercase. Now, an important thing with strings is that strings can contain numbers. After bro, I'll add 1, 2, 3. So a string is a series of characters. They can include numbers, but we can't use these numbers for any sort of math. Strings have a different behavior from numbers. Numbers we can use in arithmetic expressions. Strings, not so much. All right, let's turn these lines into comments. Then I will discuss booleans. Okay, booleans are either true or false. Typically, they're used as flags in your program. Let online equal true. Booleans are either true or false. Is somebody online or are they offline? This is either true or false. I will display the type of my variable online. Console.log type of online. So online is a Boolean variable. Let's display our variable within a template literal. Type in whatever your first name is. Bro is online. Then I will insert a placeholder, add my Boolean variable of online. Bro is online. That is true. If I were to change this to false, bro is online is false. Booleans are typically used as a sort of flag. So another example could be for sale. Is something for sale or not? Let's say that we are selling, I don't know, cars. Is this car for sale? I could set this to be true or false. Let's console.log. Is this car for sale? Then I will add my Boolean variable for sale. Is this car for sale? That is true. Another example, let's say that somebody is enrolled in school, like in college courses. We could say let is student. Is somebody a student? Are they enrolled? This can be true or false. Console.log enrolled :space is student. Is the student enrolled in classes? That is true. So those are Booleans. They're either true or false. Typically, we don't use them as direct output like you see here. We usually use them with if statements to check something. Like, if somebody is online, do this. If not, do something else. Is a car for sale? If that's true, then display the car. If it's not, then hide it. We'll have more practice with Booleans when we reach if statements. Alright, now what we're going to do is we will close out of DevTools. We'll display some variables within our web page. So let's delete everything we have. I'll create 3 variables. Let full name equals, type in your full name. Feel free to add a space between your first name and last name. Let age, type in your age. And let student equals, if you're a student, type true. If you're not in school, type false. I am not in school anymore, so I will type false. We will go to our HTML file, then add some HTML elements. I will add 3 paragraph elements. So that's 1, 2, 3. I will give my first paragraph an ID of P1. Then let's do the same with the other 2 paragraphs. Let's rename the second as P2 and the third as P3. So to change the text content of an HTML element, we're going to type document, meaning the document of our web page. Then we will get our element by its ID. Get element by ID. Then within a set of parentheses, within a set of quotes, we will select the ID that we need. Let's start with P1, then add dot text content to change the text content. Then we will set this equal to a variable or a template literal. Let's begin with a variable. So full name. Our P1 element should display your full name. Let's do this with P2. I'm going to zoom out a little bit. P2 dot text content equals age. It says that I'm 25. And then P3. Let's display student, or better yet, is student. Let's change that. Is student. False. I am not a student, but you might be though. That might be true. Then let's display our variables along with some text using a template literal. Let's copy our full name. Your name is, add a placeholder, place our variable name. Your name is brocode, or whatever your name is. Let's cut our age variable. You are variable age, years old. You are 25 years old. And then let's cut is student. Add a template literal. Let's say enrolled. Are you enrolled in school? Add a placeholder. Paste our variable. Enrolled. That is false. I am not in school anymore. Alright everybody, so those are variables. It's a container that stores a value. The variable behaves as if it were the value it contains. There's a couple different basic data types. You have strings, which is a series of text, numbers, and booleans. There's more advanced data types, but we'll cover that later. And well, those are variables in JavaScript. Yeah, what's going on everybody? So today I need to explain arithmetic operators, because, well, programming can sometimes involve a lot of math. Operands are values, variables, etc. In this equation, 11, x, and 5 are all operands. Operators, they can include, but are not limited to, addition, subtraction, multiplication, and division. In this equation, the addition sign would be the operator. So there's a few things you should know regarding arithmetic operators in JavaScript. So let's begin. Let's pretend that in this scenario we are a teacher. We have a group of students. Let students equals, what's a good class size? Maybe 30 students. Then I will console.log my students variable. And it should be 30. Let's say that a new student joins the class, and I need to change this variable. To increase students by 1, I can say students equals, this will reassign my variable, equals the current value of students plus 1. Now we have 31 students. Now for subtraction, that is the minus sign. To subtract a student, we can reassign our variable students equals students minus 1. Now we have 29. Then we have multiplication, which is represented by an asterisk. We will double the number of students we have. Students equals students, asterisk 2 to multiply by 2. We have 60 students. Division is a /. We will split our class of students into 2. Students divided by 2. We now have 15. Alright, then we have exponents. Exponents is represented by double asterisks. What is students to the power of 2? 900 students. That is a very large class. Maybe it's a lecture or something in a college. So students to the power of 3, that would be, students to the power of 3 would be 27,000. Double asterisks is the exponent operator. Here's another helpful one. It is the modulus operator. It gives you the remainder of any division. So let's say we are going to divide our class into 2. So modulus, which is represented as a %, 2. Well, 30 divides by 2 evenly, so the remainder is 0. If we had a class of 31 students, well, there's one remainder, one student. Students modulus 3 would divide my class of 31 students into 3. We would still have one student remaining. Since we're reassigning students, we would be replacing 31 students with the value of 1. If you're using the modulus operator, I would recommend creating a separate variable entirely. Let extra students equal our students modulus 3. We have one extra student. Just one. Okay, that is the modulus operator. There is a shortcut for writing these expressions because it can be kind of tedious to write the variable name twice. So let's set students back to 30. I will console.log students. We'll use what is known as augmented assignment operators. To increase students by a number, if we're reassigning it, we can say students plus equals 1, or some other number. Students is now 31. If I were to change 1 to be 2, it's now 32 and 33. Let's do the same thing with subtraction. Students minus equals 1. We now have 29 students. Multiplication, students times equals 2. That would give us 60 students. Students divided by equals 2. We have 15 students. All right, then exponents. Students to the power of equals 2. 900 students. Then modulus. Students modulus equals 2. We have no remaining students. 30 divides by 2 evenly. So another place where modulus could be helpful is if you're determining if a number is even or odd. 30 is an even number. Divided by 2, the remainder is 0. 31 is odd. The remainder is 1. There's also the increment and decrement operator. There's a couple different ways to add 1 to a variable, but you should be aware of all of them. To increase a variable by only 1, you can take the name of the variable, then add plus plus. Plus plus is the increment operator. 30 incremented by 1 is 31. Then there is the decrement operator, which is minus minus. 30 decremented by 1 is 29. All right, then lastly, we're going to cover operator precedence. This is pretty important. Given a very complex equation such as this example, in which order do you solve each part of this equation? So with operator precedence, beginning with the left, working our way to the right, you would solve anything with parentheses, then exponents, multiplication and division, and modulo, otherwise known as modulus, then lastly addition and subtraction. Let's go through this step by step. Let's see what the result variable is. I will console.log result. So the result is 23. So if we were to walk through this step by step, let's solve anything with parentheses, starting from the left and then working our way to the right. There are no parentheses, we can skip this step. Next is exponents. There is one exponent here. So we would solve 4 to the power of 2, which is 16. Then we will solve multiplication and division and modulus. That's addition, we skip that. We have multiplication, 2 times 3 is 6. There is no more multiplication, division, or modulus. Then lastly, addition and subtraction. 1 plus 6 is 7. 7 plus 16 is our result of 23. All right, I'll give you a few more exercises. How about this equation? The result is going to be 6. So there's no parentheses, no exponents. We do have a modulus operator here, so we solve that first. 12 modulus 5 gives us a remainder of 2. We have some division, we would solve that next. 8 divided by 2 is 4, then addition and subtraction. The result is 6. All right, here's a challenge round. The result is going to be 0.0468. We solve anything with parentheses first. 2 plus 5, that is 7. Then exponents, 2 to the power of 7. I might need a calculator. 2 times 2, 3, 4, 5, 6, 7. That's 128. Then we have 6 divided by 128. Then we have 6 divided by 128, which is 0.046875. And that is our result. All right, everybody, so that is everything you need to know about arithmetic operators. You have operands, which are values and variables in arithmetic expression, and operators. There's also augmented assignment operators, which is a shortcut to writing these equations if you're going to reassign a variable. Then you have increment and decrement operators to increase a variable by 1 or decrease it by 1. Then with operator precedence, if you're solving a complex equation, you solve each part of the equation following this order. And well, that is everything you need to know regarding arithmetic operators in JavaScript. Yeah, what's going on, people? So today I'm going to show you how we can accept some user input in JavaScript. Generally, there's 2 good ways of doing this. The easy way is to create a window prompt. The professional way is to create an HTML text box of some sort, and you'll likely need a button to submit the user input. Let's begin with the easy way. We'll create a window prompt. The first thing we should do is declare all of the variables we're going to use. Let's create a variable named username. We'll declare it, but not yet assign it. Then when we assign it, we can set username equal to, then to create a window prompt, we can type window.prompt parentheses. Then within the parentheses, our window prompt can contain some text. Let's ask, what's your username? Okay, let's run this and see what happens. What's your username? I will type in my username, press OK. We have this variable username. It will have a value, but we should do something with it. Let's console .log our username. Let's try that again. What's your username? I'll type in my username. Feel free to type in yours. Let's check our DevTools. And here's my username. So that's the easy way to accept user input. With this window prompt, you could assign declaration and assignment together if you want to. You know, that would also work. Now we will accept user input the professional way by creating an HTML text box. We will navigate to our HTML file. Okay, let's create an H1 element that says welcome. We'll need a text box. We'll use a self-closing input tag. I will set the ID of this text box to be my text. I'll create a label for this text box too, because if we're a user, we don't know what we're supposed to type in here. I will create a label. The text within the label will be username. Then a submit button. Button. The text will be submit. I'll put this on a new line. I'll add a break tag. Maybe 2. Make it look nice. For the ID of the button, I'll set the ID to be my submit. Let's see if this works. This is a little advanced. When we click on this button, we're going to execute a function, but we need to select this button. We will access the document of our web page, get element by ID. The ID that we're getting is the ID of the button, my submit. So within quotes, type the name of the ID. Follow this with .onClick equals. Here we'll write everything we're going to do after clicking the button. We need a function. Function parentheses curly braces. Everything between this set of curly braces is everything we'll do when we click on the button. So first we need a username variable outside of the function. When we click on the button, get the text from this text box. We will reassign our username, then set this equal to the text from the text box. We'll use document.getElementById. The ID that we're getting this time is my text. We need the value of the text box, so follow this with .value. All right, then to test this, let's console.log the username. All right, let's type in our username, press submit, then check DevTools. Yeah, there it is. Okay, let's replace console.log. We'll change the text content of our H1 element. I will give this H1 element a unique ID. Let's say my H1. We need to select my H1 element. Document.getElementById. The ID was my H1. We are changing the text content equal to, let's use a template literal. Hello, username. All right, let's try this again. Type in your username, press submit, and that should change the H1 element. Hello, whatever your name is. All right, everybody, so those are 2 different ways to accept user input. You can use a window prompt, or you can use an HTML text box. And that is how to accept user input in JavaScript. All right, so yeah, type conversion. Type conversion is the process of changing the data type of a value to another data type. For example, we can convert strings to numbers, numbers to booleans, booleans to strings, numbers to strings, booleans to numbers. I think you get the idea. Why might we want to do this? Well, when we accept user input, the data type of that input is a string. If we need to use it for any sort of math, we need to convert it to a number. Here's an example. Let's say we have variable age. I will create a window prompt, window.prompt. We will ask a user, how old are you? I'm going to add 1 to our age plus equals 1, then console.log age. How old are you? Let's say I'm 25, press OK. Let's inspect our page, go to console. It shows that age is 251. When we accept user input, it's a string data type, a series of characters. By adding 1, we appended 1 to the end of our string. We're not increasing our age by 1. We're doing string concatenation. We are going to convert our user input into a number. And this is how. So after accepting our user input, and before making any changes to it, let's reassign age equal to, and this is a function, the number function. It will convert another data type, such as a string or boolean, into a number. Then we'll place our age variable within that function. So now this should work. How old are you? Let's say I'm 25, press OK. 26. So that's the reason you may want to type convert, because different data types behave differently. Along with my age variable, I'm going to display the type of age. What's the data type? How old are you? 25, press OK. 26, and it shows that the data type of age is number. If we removed this type conversion, and then run this again, it shows that our age is 251, and it's a string, which is not exactly what we would like. That's a reason why type conversion is important. Let me give you another example. Let's create 3 variables. Let x, let y, and let z. I'll show you what happens when we convert different values into different data types. Let's say x is the word pizza. Same thing with y and z. I will typecast x as a number. Then we need to place x within the number function. I kind of want to see what happens when we try and convert pizza into a number. It's probably not going to go well. Let's convert y into a string. Then z will be a boolean. Let's console.log x as well as the type of x. Let's do the same thing with y and z. All right, what's going to happen? If you attempt to convert alphabetical characters into a number, that variable will be NaN, which means not a number. The data type is still number, though, as you can see. The word pizza is already a string, so converting it into a string really doesn't do anything. That's why for this line, the value is still pizza, and the data type is still a string. If you convert a string into a boolean, booleans again are either true or false. Converting the word pizza into a boolean returns true, and the data type is boolean. So basically, as long as there's some value here, and you convert it into a boolean, it will always be true. Let's replace pizza with 0. What will happen? We can convert 0 into a number. It doesn't contain any alphabetical characters. X contains 0, it's a number. Y is 0, but it's treated as a string. Z contains true, and it's a boolean. What about empty strings? Just a set of quotes. Typecasting an empty string as a number is still 0. We have an empty string for y. Then with our boolean, it's false. Why might you want to typecast a string as a boolean? That's one way in which you can check to see if user input is empty. Like, did somebody type something in? If a user skipped user input, it's most likely going to be an empty string. Then you can check to see, like, if this is false, then the user didn't type in anything, and you can let them know. What about a variable that's declared but not assigned a value? Converting an undefined variable to a number results in not a number. Our string is undefined, and our Boolean variable returns false. So that's the basics of type conversion. It's the process of changing the data type of a value to another. It's pretty important when you accept user input, because when you accept user input, it's a string data type. At times, you may want to convert it to a number if you need to include that number with any sort of arithmetic expressions, or a Boolean if you're checking to see if that user input was completed. We'll have more practice with this in the future. And well, that is type conversion in JavaScript. Why, hello. So today I need to explain const. Const, short for constants, are variables that can't be changed once you assign them. In this example, we're going to create a program to calculate the circumference of a circle, given a radius. Let's define our variables. First, we have pi. We'll begin with using let, then I'll show you the benefit of using const. So let pi equals, I'll use the first few digits of pi, 3.14159. Then we have let radius, which we will assign later. We'll ask for user input. Then let circumference. I think I spelled that right. I can never spell circumference. All right. Now we need to ask the user what the radius is. I will just use a window prompt. Radius equals window.prompt. Enter the radius of a circle. Then once we have our radius, when we accept user input, it's a string data type. We need to convert our radius into a number by using the number function. Then once we have our radius, we can calculate the circumference by setting circumference equal to, and here's the formula, 2 times pi times our radius that the user enters in. Then once we have our circumference, let's console.log our circumference. Let's see if this works. Enter the radius of a circle. I'll enter 10, press OK. The circumference is 62.8. So why might you want to use a const in this program? You may accidentally, or somebody else may maliciously, change the value of a variable so that the program doesn't behave as intended. For example, somewhere within my program, I will set pi to be a new number. Pi equals 420.69. Let's run this program again. Enter the radius of a circle. I'll enter 10, press OK, and my circumference is 8,413. I may not realize that this is the incorrect answer. Just for an extra security measure, I can turn any variables that shouldn't change to be a constant. Replace let with const. And it is good practice if you have any constants to make all of the letters in the variable name uppercase. So pi is now capital P-I. Hey, this is Bro from the future. There's one thing I needed to clarify that I forgot to mention. Capitalizing your constants is usually only done with primitive data types, such as numbers and booleans. Reference data types, such as strings, don't normally follow this convention. You'll see this in the next few upcoming videos. Pi is a constant and we're assigning a number, that's why I'm making it all uppercase. But if this was a string, normally we wouldn't. That is all. Let's try and change that variable again. Pi equals 420.69. So we have an uncaught type error. Assignment to constant variable. So JavaScript won't let us reassign constants once they are assigned once. We can't make any changes to it. Once you declare a constant, you can't change the value, and that's pretty helpful in a lot of circumstances. It's an extra security measure. What we'll do this time is within our web page, we will accept some user input via a text box. We'll rewrite the same program. Let's create an h1 element. I will set the ID of the h1 element to be my h1. And the text will be enter the radius of a circle. I'll create a text box. Input. I'll set the type equal to text. The ID equal to my text. I'll create a label for this input text box. Let's say radius. I'll add a button. The button will say submit. The ID will be my submit. Then I'll add 2 breaks right after the text box to make it look nice. Let's get rid of console.log. When we click on the submit button, we will execute a function. We need to select the button. Let's take our document, get element by ID, The ID is my submit. Follow this with dot on click equals a function, parentheses, curly braces. When we click on the button, we'll execute any code within the curly braces. We can eliminate our window prompt. We need to get the value from the text box. Again, we can use document.getElementById, but the ID is going to be my text, the text from the text box. Dot value. Get the value from the text box, and we will assign that to radius. Then we will typecast our input as a number. Then we will calculate the circumference. But since pi is a constant, make sure that the letters are uppercase pi. Once we have our circumference, let's change an h3 element. So let's add that as well. h3, the ID will be my h3. There will be no text content. Then again, we will get element by ID. The ID will be my h3. Change the text content of this element to equal our circumference. Okay, let's try this. The radius is 10. Press submit. And here is our circumference. Maybe this will be in centimeters. So let me change that. I'll use string concatenation and just add plus centimeters. So 10, submit, 62.83 centimeters. If I attempt to change the value of pi, maybe I'll do that here. Pi equals 420.69. Rerun the program, 10, submit. There doesn't appear to be a result. So if we go to DevTools, go to console, we have that uncaught type error, assignment to constant variable. So again, we can't change the value of a constant. There are more graceful ways of handling this. We'll learn about that when we get to exception handling. However, this is what we wanted. We do not want to be able to change the value of a constant. All right, everybody, so those are constants. It's just a variable that can't be changed once you assign it a value. And well, those are constants in JavaScript. Hey, what's going on, everybody? So in today's video, we're going to create a counter program using JavaScript, HTML, and CSS. So sit back, relax, and enjoy the show. All right, let's begin, everybody. So what we're going to do is start with our index.html file. We'll add any necessary elements. Then we will style those elements with our CSS file. Then lastly, we will add functionality via JavaScript. So let's begin with our HTML file. Within the body of our document, I will create a label to store the count. So I will create a label with an ID of count label. The text will be 0. It's a little small, but that's okay. We'll increase the font size with CSS. I'll add a break afterwards with a break tag. We'll need 3 buttons: decrease, reset, and increase. So we have button 1. Let's copy this button, paste it 2 additional times. The ID for the first button will be decrease, btn for button. The text will be decrease. Then for the second button, the ID will be reset button. The text will be reset. Then increase. ID, increase, button. The text will be increase. What I'm also going to do is place our buttons within a div section. Let's cut our buttons. Then place the buttons within the div. I will give the div a unique ID of button container. We'll center align our button container so it's in the middle of the window. Okay, that is everything we need with our HTML file. Let's move to our CSS file. Let's style the count label. It's a little small right now. I will select the ID count label. I will display the label as a block level element. I will text align center so it's in the center of our screen. Let's increase the font size. I tend to like to use the EM unit of measurement. The text will be 10 times the size. Then let's change the font family. Pick a font of your choosing. For this example, I'll use Helvetica. Let's center the button container. That should surround all 3 buttons, as you can see here. The ID was button container text align center. Okay, the buttons should be in the middle. One thing I forgot to do, let's actually add a class to our buttons too. Class equals buttons. There. All right, we will select the buttons class. I'll add some padding. Padding, 10 pixels and 20 pixels. Let's increase the font size. Font size, 1.5 EM. That translates to 150%. Let's pick a font color. I'll just pick white. Then a background color for the buttons. Background dash color. I'll use HSL values. How's that? Not feeling it. That's pretty good. Let's round the corners with border radius, 5 pixels. I'll change the cursor into a pointer when we hover over a button. Cursor, pointer. Then we'll add a transition animation. Transition, background, dash color after 0.25 seconds. Then we'll apply the hover pseudo class when we hover over one of the buttons. Take our buttons class, use the hover pseudo class. We will change the background color after a quarter of a second, then change the background color to something slightly darker. Yeah, that looks good. There should be a delay when you hover over one of the buttons. Our HTML file is done, same with our CSS. Now we need to add functionality, because, well, these buttons don't do anything. I will individually assign all of these buttons so that each is stored within a constant. So const decrease button equals, then we need to select each button by accessing our document dot get element by ID. What's the ID we're selecting? We will begin with our decrease button. All right. Then we need our reset button. Reset button. The ID is reset button. Then increase button. Increase button. The ID is increase button. We need our count label. Okay, then we will set const count label equals, then we need to get the ID of our count label. So document.getElement by ID count label. Then we will use let count equal 0. We'll be reassigning count. We'll be incrementing and decrementing count. With our HTML elements, we do not plan on reassigning them, so we can set them as constants. Now we need a few functions, 3 functions. One for each of these buttons: decrease, reset, increase. Let's begin with increase. So we are taking our increase button that we assigned with the onClick attribute of this button, set this equal to a function. What's it gonna do? When we want to increase this value of our count label, let's increment count by 1, count plus plus. Then we will set the text content of our label, count label dot text content equals whatever the count currently is. Let's see if this works. It looks like I misspelled onClick. Alright, let's see if this works. Yep, every time we press the button, our count label increases by 1. Okay, let's work on decrease. Really, we can just copy this function. Paste it. Let's change increase to decrease. Count minus minus. Save everything. And we should be able to increase and decrease. Then the reset button. Let's copy one of these functions. Change decrease button to reset button. When we want to reset, we will set count back to 0. Then update our count label with the current count, which should be 0. We can increase, we can decrease, and we can reset. Then increase and decrease again. Alright everybody, so that is a counter program with JavaScript, HTML, and CSS. Hey, what's going on everybody? So today I'm going to explain math. Math is a built-in JavaScript object that provides a collection of math-related properties and methods. For example, if you ever need the value of pi, you would type math with a capital M dot pi. Then let's console.log this. Console.log math.pi. Pi is 3.14 and the rest of the digits. If you need E is known as Euler's number. It's used for the base of natural logarithms. We won't really be using E in this series, but if you ever need it, it's there. Math does give you access to a lot of useful math-related methods. Let's create a few variables. Let x equal 3.21. Let y equal 2. And let z will be undefined. If you need to round a number, let's say z equals, you can type math.round method. Place whatever value or variable you would like to round within the round method. Let's round x, store the result within z, then display z. Console.log z. So 3.21 rounded is 3 even. There's also floor. Floor will always round down. Let's change 3.21 to 3.99. Let's copy this line. Paste it, change round to floor. Floor always rounds down, so 3.99 rounded down is again 3. To always round up, you can use ceil, as in ceiling, the opposite of floor. CEIL. Let's change 3.99 to 3.21. 3.21 rounded up is 4. Then there's truncate. Trunc, short for truncate, will eliminate any decimal portion. 3.21 truncated is 3. Another way to raise a base to a given power is to use the POW method, POW. Let's raise 3 to the power of 2. So x to the power of y, which would be 9. Y to the power of x would be 8. There's a square root function, sqrt. Let's find the square root of, how about 81? The square root of 81 is 9. If you ever need to find the natural logarithm of a number, you can use the log function. Math console.log. Let's set x to be 10. The natural logarithm of 10 is 2.3. If you need to do anything with trigonometry, there's sine, cosine, and tangent functions. Let's begin with sine, S-I-N. Within this function, you will place radians. I'll set x to be 45. So z is going to be 0.85. So that's sine. Let's do cosine, which is cos, 0.52. Then tangent, tan. And that is 1.61. Let's change x to be negative 3.21 again. To find the absolute value of a number, you can use the absolute value function, math.abs. It's basically going to give you the same number, but it's going to be positive. The absolute value of negative 3.21 is 3.21. Basically, we're eliminating the negative sign. To find the sign of a number, you can use the sign function, sign. So the sign of negative 3.21 is negative 1. If this were a positive number, it would be 1. If it's 0, then the sign is 0. Here's a pretty helpful method. We can find the maximum or minimum value from a set of values or variables. Let's set z to be 1, y will stay as 2, and x will be 3. I will create a new variable named max. It will store the maximum value from these 3 variables. Math.max, comma separate each of the variables, x, y, z. Then display the maximum within our console.log method. The maximum value from these 3 variables is 3. Then there's min. For the minimum, let min.min. So the minimum of these 3 variables is 1. Alright everybody, so that's math. It's a built-in JavaScript object that provides a collection of properties, which was pi and e, and methods such as round, truncate, power, methods related to trigonometry, and max and min methods. They're pretty helpful if you ever need them. And well, that is what math is in JavaScript. Hey, what's going on everybody? So in today's video, we're going to create a random number generator. But first, I need to explain how to create a random number in JavaScript. Let's store our random number within a variable which we will name random num. To create a random number in JavaScript, we can use the random method of math. Math.random method. This will generate a random number between 0 and 1. But it looks like we forgot to output our random number, so let's do that with console.log. Console.log random num. This will generate a random number between 0 and 1. It will give us a number with a long decimal portion, most likely. Let's say we would like to roll a 6-sided dice. I need a random number between 1 and 6, not including the decimal portion. So the first step is that we will multiply math.random times 6. What this will do is give us a random number between 0 and 6 exclusive. Now I don't want the decimal portion, I would like a whole integer. We'll enclose this equation with the floor method of math. Math.floor, then we will enclose our equation. So now we have, oops, it looks like I misspelled math. It should be capital, there. So far, our random number is going to be between 0 and 5. So there's 0. And there's 5. But I need 1 through 6. Well, we can increase the minimum by adding +1, or whatever you want the minimum to be. So now, that should give us a random number between 1 and 6. There's 6. And there's 1. For a random number between 1 and 100, I can set the maximum to be 100, math.random times 100 plus 1. So now the number is going to be between 1 and 100. If you're looking for a random number between a certain range, let's say 50 and 100, well, we're going to change our equation. Just to make this easier to read, I'm going to set 2 constants. Const min, what's the minimum? Let's say 50. And the max, const max, will be 100. let's replace 100 with our maximum and 1 with our minimum. There's one additional change we need to make. For example, our random number is 139. We're multiplying math.random times 100, our maximum, then adding an additional 50 to it. So one change we're going to make is that we will subtract our minimum from our maximum. Then I will surround this portion of our equation with a set of parentheses just to force operator precedence. Now the random number should be between 50 and 100. So depending on the range of numbers you're looking for, you can change the minimum and the maximum. Alright, now with that out of the way, let's create our random number generator. Let's go to our HTML file. I will create a button. The ID will be my button. The text on the button will be roll. We will roll a 6-sided dice. Within our CSS style sheet, I will set the text of the body of our document. The font family I will set to be Verdana, because I like that font. To center align everything, to make this easy, I will set text aligned center. Alright, we're getting somewhere. Let's work on the button. I will select the ID of my button. I will change the font size of the button to be 3EM, meaning 300%. I'll add a little bit of padding within our button, 5 pixels by 25 pixels, and I will set the border radius to be 5 pixels, just to smooth the corners. We're also going to need a label, so let's go back to our HTML file. I will add a label with an ID of my label. Within our CSS style sheet, I will select the ID of my label, then change the font size to be 3EM. So be sure to save your CSS file, save your HTML file, then within our JavaScript file, we will need to get our button and the label. We'll store those within some constants. Const my button equals document.get element by ID. The ID of the element we're getting is my button. Then we will need to get my label. My label, the ID is my label. Let's set a minimum. Const min equals, I'll set that to be 1 as if we're rolling a 6-sided dice. Const max equals 6. Then let random num. We'll declare our random number variable, but not assign it quite yet. Okay, when we click on the button, we'll execute a function. We will take my button with the onClick attribute. I will set this equal to a function. What's the function going to do? It's going to roll a random number. Random num equals math.random times our maximum. We'll enclose this equation with math.floor to round it. Math.floor, then add our minimum. Then we will change the text content of my label to display it. My label.text content equals our random num. When we click on the button, it should roll a random number. What are we missing? Not a number. Oh, okay, it looks like I made a mistake. I forgot to add a set of parentheses after random. There we go. I'm going to put the number on a new line. So within our HTML file, I'm just going to add a break tag. There we go. Let's save everything, roll again. So I rolled a 6, 3, 1, 2, 5, 3. Let's say we would like to roll 3 dice, not just 1. We'll make a few changes. I will replace my label with label 1 for the ID. Then I'm going to add a break after. Okay, let's copy our label, paste it 2 times. We'll need labels 2 and 3. I'll also give these labels a class of my labels. We can apply CSS styling to an entire class to make it easy. Alright, within our CSS style sheet, let's replace the ID of my label with the class of my labels. Be sure to save all of your files. Then within our JavaScript file, let's replace my label with label1. The ID is label1. Copy this line of code. Then we need labels 2 and 3. Label 2, label 3. Let's rename random num as random num1. Copy it, paste it 2 times. Then we need random number 2, random number 3. Within our function for our button, change random num to be random num1. Copy this line, paste it 2 times. Then we need random number 2, random number 3. We'll change the text content of my label to be label1 equals random num1. Copy this line, paste it 2 times, change 1 to be 2. Then for the third line, change 1 to be 3. What we'll do now is generate 3 random numbers between 1 and 6, as if we're rolling 3 dice. 232, 361, 225. All right, everybody, that's how to create a random number generator in JavaScript. Hey, so what's going on, everybody? Today I gotta explain if statements. So in JavaScript, if a condition of our choosing is true, we can execute some code. If it's not true, we can do something else. That's how to put it simply. For example, let's say we have a user's age. Let age equals 25. To write an if statement, we can type if, a set of parentheses, then a set of curly braces. Within the set of parentheses, we can check a condition. Let's check to see if our age variable is greater than or equal to 18. If this condition is true, we can execute whatever code is within the set of curly braces. If this condition is true, let's console.log a message. You are old enough to enter this site. My age is 25. This condition is true. We will execute this code within the curly braces. You are old enough to enter this site. What if my age was 13? Well, if this condition is true, we don't do this. We don't execute it. We skip over it. If you would rather take a different course of action, if you would rather do something else, you can write an else clause. If this is not true, we will do whatever's within the else clause. Let's display a different message. You must be 18 plus to enter this site. My age is 13. We will end up displaying, you must be 18 plus to enter this site. Basically speaking, if this condition is true, do this. Else, if not, do this instead. It's kind of like a fork in the road. Which path are we going to take? Here's another example. Let's say we have variable time. Time will be in hours, in military time. If our time is 9, as in 9 a.m., let's write an if statement. If time is less than 12, as in noon, then console.log good morning. Else if it's after 12, that means it's at least the afternoon. Console.log good afternoon. The time is 9, as in 9 a.m. Good morning. What if our time was 14, like 1400 in military time? Well, then we will display good afternoon. Conditions also work very well with Boolean variables. Let's create a Boolean variable is student. If you're a student, say true. If not, then false. Now with a Boolean variable, if you need to check the value with an if statement, you can just place the Boolean variable within the condition itself. The condition either evaluates to be true or false. If is student is true, then console.log you are a student. Else console.log You are not a student. Is student equals false, we will execute the else clause. You are not a student. If this were true, we'll execute the if clause. You are a student. You can even create nested if statements. This time we will have two variables. Let age equals some age, and let has license, as in a driver's license. That's how to spell license. Has license will either be true or false. So in the United States, you need to be at least 16 years old to have your license. We'll check that first. If age is greater than or equal to 16, let's console.log. You are old enough to drive. Else, console.log. You must be 16 plus to have a license. If I changed my age to 15, well, I'm not old enough to have a license, at least in the United States. It might vary depending on your country. Let me know in the comments section how old you have to be to get a driver's license. I'm kind of curious. You can use another if statement within an if statement. After we check to see if somebody is old enough to have a license, let's check to see if they do have a license or not. So I will add another if statement within our if statement. Pay attention to the indentation. If has license, since we're checking a Boolean variable, that is going to be the condition itself. It evaluates to be true or false. If has license, console.log, you have your license. Else, again, pay attention to the indentation. Console.log, you do not have your license yet. My age is 15. I don't have a license. This is the result. You must be 16 plus to have your license. Since this condition is false, we skip over everything within curly braces entirely. If I set my age to be 18, you are old enough to drive, but I don't have a license. That's set to false. You do not have your license yet. So we execute this condition. So we enter anything within this set of curly braces. We display this message, then check this if statement. My condition is false, then we will execute the else clause. If I set has license to be true, well then, you are old enough to drive, you have your license. Alright, now I need to discuss else if statements. We will keep our age variable. We have our if statement. If age is greater than or equal to 18, then we will console.log. You are old enough to enter this site. Else, console.log. You must be 18 plus to enter this site. My age is 18, I can enter this site. If my age was 12, I can't enter this site. If there's any other conditions you want to check before reaching your else statement, you can add an else if clause. Then you can check another condition. Let's check to see if somebody's age is less than 0. Your age can't be below 0. Let's let the user know. Console.log, your age can't be below 0. I will set my age to be -1. That's not possible. Your age can't be below 0. Since this condition is false, we skip over this clause, then move on to the next condition. Else if this condition is true, execute this clause, which it was. Then it's not necessary to go to the else statement because we already executed one of these clauses. You can add as many else if statements as you would like. Let's add another. Else if Let's check to see if somebody is over 100 years old. Age is greater than or equal to 100. Console.log. You are too old to enter this site. Okay, now pay attention to this. It's really important. My age will be 101. You are old enough to enter this site. So why didn't we execute this clause? Our age is greater than or equal to 100. The order of our clauses does matter. We start at the top and work our way down and check all the conditions on the way down. So with our first statement, this if statement, age is greater than or equal to 18. 101 is greater than or equal to 18. We will execute this clause and skip over everything else that comes after. Even though this response is more appropriate for what we're looking for, we still skip over it, even though this is true, because we executed this one first. So I would recommend that we move this clause to the beginning and change it to an if statement. First, let's check to see if age is greater than or equal to 100. Else if age is greater than or equal to 18. So this should work as intended. Our age is 101. You are too old to enter the site. Let's add another else if clause. So to check to see if two values are equal, you got to use the comparison operator, which is two equal signs. Let me give you a demonstration. Else if, let's check to see if somebody's age is directly equal to 0. So be sure you're using two equal signs for a comparison, not one. One equal sign is the assignment operator. You want two equal signs to see if two values are equal. If somebody's age is exactly 0, we'll display a custom message. You can't enter. You were just born. If somebody's age is 0, they're a baby or an infant. So let's set our age to be 0. You can't enter. You were just born. This condition is false. We skip this clause. This condition was true. We execute this clause and skip everything else that comes after. Using all this code, let's work on an exercise. We're going to create a text box and a button so somebody can submit their age. Then depending on what they enter, we will display a message. So within our HTML file, we'll create a few things. Let's create a label. The text on the label will be enter your age. Let's add a break after, then a text box. The label will be input, the type will be text, the ID will be my text. I'll add a break. We'll create a submit button. Button type equals submit. The ID will be my submit. The text on the button will be submit. I will also create a paragraph element. The ID, let's say, is result element to display a result. All right, that is everything we'll need. So we can't see the paragraph element quite yet. The text content of the result element will be one of these lines of text. So let's go back to our index file. We'll create our elements. I will set them to be constants. Const my text equals document.get element by ID. The ID is going to be my text, and const my submit, that's the submit button, document.get element by ID. The ID is going to be my submit. Then lastly, result element. Const result element equals document.get element by ID. The ID is result element. Let's scoot these if statements down. When I click on the button, we will execute a function. The button is named mySubmit. MySubmit.onClick attribute equals a function. When we click on the button, what are we going to do? Let's take all of our if, else if, and else clauses, cut them, then paste them within the function for the button. When we click on the button, then we will check our age. Let's set this variable to be undefined. Then we will get our age from the text box. Age equals my text dot value, get the value from the text box, and assign it to age. But remember, when we get text from a text box, it's a string data type. We need to typecast it to a number. So we will set age to equal, then use the number function to convert it to a number. Then we can check our age. We'll replace console.log with the text content of the result element. Result element dot text content equals our message. I'll use a template literal, so I'll use backticks. Let's copy our text, paste it within the template literal. Then I will delete the console.log message. So we'll just follow this pattern. Result element dot text content equals our message. All right, let's see if this works. So we will type in our age. Let's say I'm 25, press submit. And we have one problem. Let's see what's going on. Oops, okay, so I forgot to add a set of parentheses after the function. Let's add that. Let's say I'm 25, press submit. You are old enough to enter this site. Let's say I'm 12. You must be 18 plus to enter the site. What if I'm 101? You are too old to enter the site. What if I'm 0? You can't enter, you were just born. I'm -1. Your age can't be below 0. Alright everybody, so that is everything you need to know to get started working with if statements in JavaScript. Hey, so today I'm going to explain the checked property in JavaScript. The checked property determines the checked state of an HTML checkbox or a radio button element. By examining this property, we can determine if a checkbox is checked or a radio button is selected. In this program, if I were to not select any of these buttons, we have a different result. Within our HTML file, we will create an input element. The type is going to equal checkbox. Then for the ID, I will set this equal to my checkbox. And here's our checkbox. We should probably add a label so that people know what this is for. So the label, I will set the for attribute to be my checkbox. What's the label gonna say? Let's say subscribe, like a subscribe button. Utilizing the for attribute, if the for attribute is the same as the ID, when we click on the label, it should still select the checkbox. All right, let's add a break. Then we will create some radio buttons. We will again need an input element. The type this time will not be a checkbox, it will be radio. For the ID, this will be a Visa button. I'm going to abbreviate button to BTN, so pay attention to that. Then I will create a label for this radio button. We will set the for attribute to be the same as the ID. Then the text will be Visa. I'm going to add a break. Okay, let's copy this radio button, paste it 2 times. We'll change the second Visa to be MasterCard. Let's change the ID first. MasterCard. Let's copy the ID, paste it within the for attribute of the second label. Then change the text. MasterCard. Then the third ID will be PayPal button. Then change the for attribute and the text. PayPal. So with radio buttons, they should all be within the same group. Currently they're not, so I can select all of them if I would like. We should only be able to select one from any group. we will group these radio buttons by their name attribute. They should all have the same name. The name, let's say, is card. So let's copy this attribute and paste it within the other input elements. Now we should only be able to select one, and that appears to work. Lastly, let's create a submit button. We are creating a button. The text will be submit. The type is submit. And for the ID will be my submit. I will create a paragraph element. We'll populate it with some text, depending if subscribe is checked or not. Same thing goes with our radio buttons. I will create 2 paragraphs after our button. The ID on the first paragraph. Let's name sub result. There will be no text content to begin with. We'll change the text content of our sub result paragraph with some text that states if the user is subscribed or not. We'll create another paragraph for the radio buttons. Again, there's going to be no text content. I'll set the ID of this paragraph to be payment result. Now, before we move to our JavaScript file, I'm just going to edit the CSS on the button to make it a little bit bigger so you guys can read it. So the ID of that button was mySubmit. We are selecting an ID, mySubmit. I will set the font size to be 1EM. And that's probably good enough. Maybe I'll add one more break after the subscribe button and the PayPal radio button, just so that it's not as cramped. That's decent enough. Okay, so be sure to save your CSS file, your HTML file. Then we are now within our JavaScript file. What we're going to do now is get these elements by their ID and store them within constants so they're easier to work with. Okay, let's start with our checkbox. So the checkbox had an ID of myCheckbox. Const myCheckbox. Be sure to pay attention to the capitalization. Feel free to change that if you would like, just be sure it's consistent with what you have currently with your HTML elements. We are accessing the document of our web page. Get element by ID. The ID is going to be myCheckbox. And that's it. So let's get the other elements. We have myCheckbox. Then we have our Visa button. Const Visa button. Get element by ID. Visa button. Then let's repeat this with our MasterCard button. Again, pay attention to the capitalization. It's pretty important. Then we have our PayPal button. We need our submit button next. mySubmit. Then our paragraph elements. Sub result. Then payment result. All right, here are all the constants that we'll need. So when we click on the submit button, we will execute a function. So we are taking mySubmit, that's the name of the button, dot onClick. I keep on spelling onlick. OnClick equals a function, parentheses, curly braces. When we click on the button, what are we going to do? We recently learned about if statements. We will first check the checked property of the subscribe button. We'll place it within an if statement. So to create an if statement, it's if, parentheses, curly braces. We are examining my checkbox, that's the subscribe button, dot checked property. This will evaluate to be true or false. If this is true, we will execute this code. If not, we do something else. If somebody is subscribed, let's change the text content of our sub-result paragraph. So sub-result, we are accessing the text content to equal, maybe I'll use a template literal. You are subscribed. Else, the user is not subscribed. Let's copy this line, paste it. You are not subscribed. Let's test this. If I click on the checkbox, then press the submit button, it states that I am subscribed. You are subscribed. If I were to refresh the page, I don't click the subscribe button, press submit, you are not subscribed. All right, we know that that works. Let's move on to the radio buttons. First, we will check to see if somebody selected Visa. We are accessing the Visa radio button. If Visa button dot checked, if this is true, we are changing the text of the payment result paragraph. Payment result dot text content equals you are paying with Visa. Let's see if that works. I'll select Visa, press submit. You are paying with Visa. All right, let's add else if. The next radio button is MasterCard button. If this is checked, MasterCard button dot checked, then we will change the text content of the payment result to be you are paying with MasterCard. You are paying with MasterCard. Let's add another else if statement. Else if, this time we are examining the PayPal button. PayPal button dot checked. If this is true, change the text content of the payment result to be you are paying with PayPal. You are paying with PayPal. Else, if none of these radio buttons are checked, we will change the text content of the payment result to be you must select a payment type. I will press submit without selecting a payment type. You must select a payment type. All right, everybody, so that is the checked property. By examining the checked property of an HTML checkbox or a radio button element, we can determine if those elements are checked or not. And well, that is the checked property in JavaScript. Hey, welcome back. So today I'm going to explain the ternary operator in JavaScript. You write a condition, then add a little question mark, kind of like you're asking a question. How is this useful? Well, it's a shortcut to if and else statements. It helps to assign a variable based on a condition. You write a condition, then use the ternary operator as if you're asking a question. You can write some code if that condition is true. What would you like to do? Then add a colon, then some code if that condition is false. Here's an example. Let's say we have a user's age. Age equals 21. I would like to check to see if somebody's age is greater than or equal to 18. Age greater than equal to 18. Then I will use the ternary operator, kind of like I'm asking a question. Is age greater than or equal to 18? If this condition is true, we can write some code. I'll create a string. You're an adult. Then what if the condition is false? I'll add a colon. Then I will execute this code if the condition is false. You're a minor. This is helpful if you need to assign a variable based on a condition. So I'll create a new variable, let message equals, then we write our condition. So if age is greater than or equal to 18, if that's true, we will assign this string to this variable, this message. If it's false, instead we will assign this one. It's an alternative to writing something like this. So with programming, we try not to repeat ourselves if we don't have to. Here we're assigning message to be either this string or this one. Our ternary operator is more condensed, and I feel like it's easier to read than that if-else statement. It's a shortcut if you choose to use it. I tend to use it a lot. Then just to test it, let's console.log our message, just to be sure that it works fine. Console.log our message. Our age is 21, you're an adult. If my age was 12, you're a minor. Let's go over a few more exercises. This time we will have let time. Time will be between 1 and 24, like a 24-hour clock. I will set time to be 16. 16 I think would be 4 p.m. We will assign a greeting equals, then we'll write a condition. Is time less than 12? Then ternary operator, like we're asking a question. If the time is less than 12, it's the morning. Good morning. We'll use a colon, then write some code if it's false. If it's not the morning, it's at least the afternoon. Good afternoon. Then let's console.log our greeting. Good afternoon, because it's 4 p.m. What if it was 9? Good morning. All right, I have a few more examples. What if somebody's a student? Let is student. This will be true or false if you're a student. Let message equals. Now with a Boolean variable, you can just write the Boolean variable itself. Is student question mark? Are you a student? If so, you are a student. If not, you are not a student. Then let's console.log our message. We are a student. You are a student. Let's set this to be false. You are not a student. It's very easy to read with Boolean variables. You write the Boolean variable, then add a question mark. Here's a challenge round. We will have a purchase amount as if somebody's buying something. If somebody's purchase amount is over $100, they get a 10% discount. So let purchase amount equal, let's say $125, or some other unit of currency of your choosing. Let discount equals, then the condition is, we're checking if purchase amount is greater than or equal to $100. Question mark. Is somebody's purchase amount greater than $100? If so, they will get a 10% discount. Colon. If that's false, they get no discount, 0. So then let's display the total. Console.log. I'll use a template literal. Your total is, I need a $sign for our unit of currency. Then I need a placeholder, so I need another $sign. The purchase amount minus the purchase amount multiplied by, let me scoot over a little, the discount divided by 100. So the total, since we get a discount, is $112.50. If our purchase amount was $99, well, we don't get that discount. Your total is $99. All right, everybody, so that's the ternary operator. It's a shortcut to an if-else statement. It helps to assign a variable based on a condition. You write a condition, add a question mark as if you're asking a question, do this code if that condition is true, else do this code if that condition is false. I'll be using the ternary operator a lot just because I feel like it's helpful. And well, that is the ternary operator in JavaScript. Hey, what's going on, everybody? So today I'm going to explain switches. A switch can be an efficient replacement to using many else-if statements. Here's an example of a program I wrote without using a switch. We have a day. Day will normally be the number 1 through 7. If day equals 1, we'll console.log it is Monday, which you can see here. If day was 2, well then it's Tuesday. All the way up to 7, which is Sunday. I do have an else statement that states our day variable is not a day. For example, if I set day to be, I don't know, like a string of pizza, well then pizza is not a day, but it really should be. If you find yourself using a lot of else-if statements, I would instead recommend creating a switch. Here's how to create one. We'll keep our day variable. I'll set that to be 1. To create a switch, we will type switch, parentheses, curly braces. Within the parentheses of the switch, we will place a variable or a value. What are we examining? Let's examine our day variable. We examine a value against matching cases. To create a case, type case, then a value or a condition. We will see if day equals 1. So day, case 1. Are these two values equal? If they are, then we can do something. We can execute some code. So add a colon, then any code underneath this case will be executed if there's a match between our value or variable day and this value. So let's console.log it is Monday. Then be sure to add a break. I'll demonstrate why you need break later. So day is 1. It is Monday. Let's add another case for case 2, in case day equals 2. So let's copy and paste what we have. Case 2, it is Tuesday. Let's change day to be 2. It is Tuesday. All right, let's do this all the way up to case 7. All right, we have cases 1 through 7. If I change day to be 7, well then, it is Sunday. You can also add a default case, in case there are no matches. Now what if we set day to be pizza, which doesn't make sense? Well, there are no matching cases. Once we review all of the cases and there's no matches, we exit the switch. You also have the capability to add a default case, in case there are no matches. What's the default behavior of the switch if there's no matching cases? Let's console.log. I should probably use a template literal for this if we're inserting a variable. Our day variable is not a day. So now we should execute this default case. Pizza is not a day. All right, now the reason that we have these break statements is to break out of the switch once we have a matching case. I'll demonstrate what happens if we remove these. All right, let's set day to be 2, as in Tuesday. It is Tuesday, it is Wednesday, it is Thursday, it is Friday, it is Saturday, it is Sunday. 2 is not a day. So the reason that we have these breaks is to break out of the switch. If we don't have them, once we have a matching case, we will execute the code found within that space, then cascade down and execute any code that follows after, including code within different cases. So that's why you want these break statements after each case, to break out of the switch. Let's go over a more complex example. Let's say we have a test score variable between 0 and 100. My score will be 92%. I will also create a letter grade variable, which we will declare but not assign. I'm going to examine our test score. So another way in which you can write a switch is something like this. I'm going to examine the value of true against matching cases which contain a condition. So case, then I'll write a condition. Is test score greater than or equal to 90, as in 90%? This condition will evaluate to be true or false. If true is equal to true, we will do some code. If this is false, we skip over it. If our test score is greater than or equal to 90, let's assign our letter grade variable to equal an A. Then be sure to break. Then I'm going to test this with console.log. We will display our letter grade. We have an A. Let's do this for anything greater than 80. The user will receive a B. Test score greater than or equal to 80. Letter grade will equal B. Let's change our test score to be 85. The user receives a B. Let's follow this pattern. 70 will be a C. Yep, C. 60 will be a D. 60 is D. Then for the default case, I will set letter grade to be F. Letter grade equals F. If I set my test score to be 33%, so with the test score of 33, the letter grade is F. Alright everybody, so that's a switch. If you find you're using a lot of else if statements, I would recommend using a switch instead. It's not bad if you have a few, but if you have many, I would use a switch instead. And well everybody, those are switches in JavaScript. Hey, it's me again. So today I'm going to explain string methods in JavaScript. String methods allow you to manipulate and work with text, also known as strings. In this example, I have a username. Username equals a string of text. Why don't you go ahead and create a username variable and set it equal to either your username, if you have one, or your full name. Strings have different built-in methods where we can manipulate this text one way or another. Here's a few examples. Suppose I would like to get the first character of the string. I can use the char@at method. Type a string or a variable containing a string, then follow this with dot. By adding a dot, we are accessing any properties or methods that the string has. Follow this with char@, then list an index. The first character is 0. The second character would be 1. So get the character at index 0. That should be a B. However, if I were to run this, let's go to our DevTools. Nothing appears to happen because it's going to return a single character. Let's place that within console.log just so that we can see it. Cut this code and paste it within console.log. So the first character in my string is B, but depending on what you wrote, it might be different for you. The character at index 1 would be R. Then 2 is O. So that is the char@at method. The index of method will return the index of the first occurrence of a character. Let's find the first occurrence of an O. It will return an index. And then again, I have to console.log whatever is returned. So let's place this method within console.log. What is the index of the first occurrence of an O? That would be 2. 0, 1, 2. Otherwise, for the last index, let's change the method to be last index of, which would be 4. 0, 1, 2, 3, 4. So the length property, this isn't a method. To get the length of a string, type the string or a variable containing the string, dot length. This isn't a method, but it's very similar. So the length of my username is 7 characters. 1, 2, 3, 4, 5, 6, 7. So that's how to get the length of a string. Now we are going to trim the string. Maybe there's a bunch of white spaces after or before. I will reassign username equal to, let's take our username variable, dot, and use the trim method to trim any white space. Then I will console.log my username. There's my name, and there's no white space after. Let's add some white space before our name. Yep, and there's no white space. To make my name all uppercase, I can use the toUppercase method. Now my string is all uppercase. Then there's toLowercase to make all of the characters lowercase. There's repeat to repeat a string. Within the parentheses of the method, how many times do you want to repeat the string? If I were to type 3, we'll repeat the string 3 times. To determine if a string starts with a given character, we can use the starts with method. This will return a Boolean. I will store that within a result variable. Username dot starts with method. We will check to see if the string starts with an empty space. Then let's console.log the result. That is false. My username does not begin with a space. But what if it did? I'll add one. Then that returns true. This could be useful within an if statement. If result, if the string starts with a white space, let's console.log your username can't begin with an empty space. Else, let's console.log the username. My username has a white space in the beginning. Your username can't begin with white space. If that were false, then we will display my username. So that is the starts with method. There's also ends with. Does my username end with a white space? It does not. But what if it did? Your username can't end with an empty space. Next is the includes method. Does the string contain an empty space? I'll split my username into two. Your first and last name would work as well. Your username can't include an empty space. Currently it does. Your username can't include an empty space. If it didn't, then we pass the test. We will display the username. All right, now this time we will create a phone number. Let phone number equals, make up some phone number, including dashes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. So this phone number is a string, even though it contains numbers, because strings can contain numbers, but we treat them as characters. Let's eliminate all of the dashes in our phone number. Here's one way in which we can do that. Let's reassign our phone number equals our phone number. We will use the replace all method. Which character are we replacing? Let's replace any dashes, comma, then the character to replace the dashes with, or whatever you put for the first character. We will replace all dashes with no characters. Then let's console.log our phone number. And that should eliminate all of the dashes. Or otherwise, you could replace it with a different character. Let's do a /. So 123/456/7890. There's also the pad start method. Pad start. The first value within the pad start method is a specified length. How many characters should the string be? I would like the string to be 15 characters long. Then for the second value, make sure to comma separate it. We can pad the start of the string with a given character. Let's say 0. So the result is a couple zeros, then our phone number. Pad this string with zeros until it's 15 characters long. If I were to set this to 20, then we would have more zeros. There's more padding. Then there's pad end. Pad the end of the string with this character until the string is 15 characters long. All right, everybody, so those are string methods. They allow you to manipulate and work with text, also known as strings. We'll have more practice with these in the future. And well, those are a few useful string methods in JavaScript. Hey everybody, so today I'm going to explain string slicing in JavaScript. String slicing is the process of creating a substring from a portion of another string. This won't alter the original string. Just to demonstrate, let's create a constant for our full name. Go ahead and type in your full name. Or you can copy me. I'm going to extract the first name from my full name and create a new string out of it. So I'll declare this let first name equals. Now to create a substring, we can follow this formula. We take our string, in this case our full name, dot, then use the built-in slice method. Slice, then we can list a starting and ending index. Where would we like to begin? So the first character has an index of 0. We'll start at the beginning, index 0, comma, where are we going to end? 0, 1, 2. This isn't necessarily going to work, and let me demonstrate. So let's console.log our first name. So my first name is BR. So the ending index is actually exclusive. In my full name, we're ending at O, but we don't include it within our substring because the ending index is exclusive. I'll increase the ending index to 3. That should include one more character, which it does. Now let's get the last name. Let last name equals, again, following this formula, take our original string, use the built-in slice method, state the beginning index, 0, 1, 2, 3, 4. Mine will be 4. Yours may be different depending on what your name is. And the ending index, 4, 5, 6, 7. And remember that the last index is exclusive, so I'm going to increase that to be 8. Then we'll display our last name. Console.log last name. And there's my last name. So the reason that I set the beginning index to be 4 and not 3 is because we'll include that space within the result, as you can see here. If you're going to be creating a substring from some position all the way to the end, you don't necessarily need an ending index. I'm going to remove the ending index, and this should work the same. All right, what if I need the first character in this string? Let first char, meaning character, equals, take our string, we will use the slice method. For the first character, you can use 0, 1. Then let's display our first character. And in my example, mine is B. For the last character, let last character full name dot slice. We can use a negative index even. If you're using a negative index, you'll begin at the end. Then by decreasing the number, you'll work your way towards the beginning. So the last character in my name is E. -2 would be DE. 3 is ODE. 4 is CODE for code. Negative indices work as well. With these specific numbers that I've listed, they're only going to work if my name is exactly this. What if I were to change my first name to be, instead of Broseph, like Joseph? Then let's display our first name, then our last name. First name Bro, last name F, which is not correct. To make this program more dynamic, we can combine string slicing with the indexOf method. We'll search the string for the first instance of a space. Then depending on where that space is, we'll take the first part of our full name and create a substring for the first name. Anything after the space will be our last name. So let's turn these lines into comments. We don't need them anymore. Let first name equals, again, take our full name, dot slice. We'll begin at the beginning, index 0. Now where do we end? We're not going to count the number of characters this time. We're going to calculate it. The ending index will be, take our full name, dot, then use the indexOf method. Where's the first index of a space? So that is the ending position, wherever there's a space. Then we'll display our first name. Let me get rid of our last name. There, Broseph. Now for the last name, let last name equals, let's copy this line of code, paste it. The beginning index will be full name dot index of space. You can list an ending index, but we don't need to. We would like to extract every character that comes after this position, so we don't need an ending index. All right, let's see if this works. Broseph space code. We're including that space. So to remedy this, I can add +1. Find the first index of a space, then start in the position after. That's why we're adding +1. Then give me every letter that comes after. And that works just fine. Broseph code. All right, let's go over an exercise. This time we will list an email. Const email equals, why don't you go ahead and type in your email? I'll make one up for me. bro1@gmail.com. I'll extract the first part of my email to be stored as a username. Let username equals, again, we're going to take our string, email, dot, use the slice method. Where are we going to begin? We'll begin at index 0, that's the beginning of a string. Where will we end? We'll end wherever the @ symbol is, but we need to search for it. We'll use the built-in index of method of a string. Email dot index of, what are we searching for? We are searching for the @ symbol. And let's see if this works. Console.log, our username. Yep, bro1. Then let's get the extension. Let extension equals, we can copy this line of code, paste it, make a few changes. This substring will begin where the last one ended. And then again, console.log, the extension, @gmail.com. Again, like I said before, I would like to begin after this index. I will add +1. My username is bro1, my extension is gmail.com. All right, everybody, so that's string slicing. It's the process of creating a substring from a portion of another string. When you create a substring, you won't alter the original. And I've proven that by setting this string to be a constant. You can't change a constant. To create a substring, you take the string, use the built-in slice method, then you can list starting or ending indices. And well, everybody, that is string slicing in JavaScript. What's up, everybody? So in today's video, I got explained the concept of method chaining in JavaScript. Method chaining is a programming technique. It's where you call one method after another in one continuous line of code. I'll give you two examples of the same program, one that uses no method chaining, and another that does. Then we'll be able to see some of the benefits of method chaining. What we'll do in the first version of this program is create a variable for a username, and I will ask the user for some input using window.prompt. The text will be, enter your username. After typing in some username, I would like to trim any white space around the username, take the first character, make it uppercase, take all of the other characters, make them all lowercase, and then display the output. So this program will have a few steps. Let's reassign our username equal to username, use the trim method to remove any white space before or after the name. Then I will get the first character of my username to capitalize it. We'll create a variable of letter equals our username. Follow this with the char @ method, the character at index 0. Letter is going to be a variable. It will hold the first letter of my username. To make my letter uppercase, I will reassign it. Letter equals letter. Use the to uppercase method to make that letter uppercase. Now with the rest of the characters, I would like to make them lowercase, anything besides the first character. I will create a separate variable for extra characters. Let's say extra chars, short for characters, equals, take our original username, use the slice method. We will slice our username everything after the first character. If my name was brocode, and I created a slice of everything but the first character, extra characters would be row code without the B. So then let's take our extra characters, make them all lowercase. Extra characters equals extra characters, followed with the to lowercase method. Then we will combine the first letter, which is uppercase, and the extra characters, which are lowercase. Then store them within our username. Username equals our letter plus the extra characters. Then we will display our username. Console.log, our username. So this program does have a lot of steps. We will run this program, enter your username. I will enter a few white spaces, type in my name, but I'll mix up the capitalization. Press OK, and there's my username. The first letter is uppercase, The rest of the letters are lowercase. So this program does work, but it is a lot to write. Now with method chaining, we can combine some of these steps together and avoid creating variables that we don't need, such as letter and extra characters. So with method chaining, what we'll do is start to combine some of these steps. After getting our username, we will take our username equals take our username again, use the trim method. We're not going to end this method with a semicolon. We're going to end it with a dot to write another method. After trimming the username, get the character at index 0. And then why stop there? Let's method chain again. Make that letter uppercase, following the toUpperCase method. So this will work. It's kind of like in a video game, how you can have a combo. Well, this is a 3-hit combo. Boom, boom, boom. Take our username, trim it, get the first character, and then make it uppercase, all in one line of code. Not only that, let's use some string concatenation. We need to take the rest of the characters in my username, make them all lowercase, then combine them together. Again, let's take our username, use the trim method, method chain, the slice method. Slice the string after the first character. Then method chain again, use the toLowercase method. And that should work. Console.log, my username. We're using a lot less lines of code. And I'll zoom out just so you can see everything. Enter your username, I'll throw in some white spaces, then mix up the capitalization. And that has appeared to work. So that's method chaining. It's a programming technique where you can call one method right after another in one continuous line of code. It's like a video game combo, so to say. So in this case, trim our username, give me the first character, and then make it uppercase. We did method chaining here, here, and then we combined the results using string concatenation, which is something separate entirely. By using method chaining, this helps you avoid creating named variables, but if your method chain is too long, it can become difficult to read. Like here, I am kind of pushing the limits. And well, everybody, that is method chaining in JavaScript. Hey, it's me. So today I'm going to explain logical operators. There's 3 of them. And, or, not. They're used to combine or manipulate Boolean values. Boolean values, if you remember, are true or false. Let's create a program. Const temp meaning temperature. What I would like to do is see if my temperature falls within a certain range. This will be in Celsius. Let's say the temperature is 20 degrees Celsius. Without using any logical operators, let's write this. If our temp is greater than 0, then we will console.log the weather is good. Else if the temperature is less than or equal to 30 degrees Celsius, we will also output the weather is good. Else the weather is bad. Currently my temperature is 20 degrees Celsius. The weather is good. What if I were to change this to something ridiculous like 200 degrees Celsius? Well, the weather is obviously not good. Earth probably got hit by an asteroid or something. Or if I were to change my temperature to like negative 100 degrees Celsius, well, the weather isn't good either. I don't know, maybe the sun disappeared. So what I want to do is output the weather is good only if my temperature falls between the range of 0 and 30. So we're going to change this program. If our temperature is greater than 0, and we'll check another condition, and our temperature is greater than or equal to 30, then we can eliminate this else if clause. Now let's check the temperature. Our temperature is negative 100 degrees Celsius. Well, the weather is bad. If our temperature was 200 degrees Celsius, the weather is also bad. In order for us to execute this if statement, both these conditions need to be true. This one and this one. To join two conditions, you use double ampersand, meaning and. If our temperature was 25, well, that falls within our range. The weather is good. This is true, and this is true, so we will execute this code. If one of these was false, we don't execute it at all. We'll skip over it. So that is the AND logical operator. You can check more than one condition. You can check one thing and something else. Now there's OR, which is double straight bars. With the OR logical operator, at least one of these conditions needs to be true. This has to be true, or that has to be true. If I were to run the same program, well then the weather is good. Let's change the temperature to 250. The weather is good, but it's not, it shouldn't be. So let's rewrite this program. If our temp is less than or equal to 0, or the temperature is greater than 30, then the weather is bad. Else, the weather is good. Our temperature is 250, the weather is bad. Negative 250, the weather is also bad. So with the OR logical operator, we're checking more than one condition. Is this true? Yes, it is. Negative 250 is less than 0. Or is this condition true? This one is false. But since at least one of these is true, we will execute this code. Then we will cover the not logical operator. Let's create a new program. Const is sunny. Is it sunny outside? This will be true or false. We will create an if statement. Our condition will be, is sunny. Is this true? If it is, we will console.log it is sunny. Else, we will console.log it is cloudy. Is sunny is set to true. It is sunny. If this were false, then it is cloudy. Using the not logical operator, we can flip a Boolean from true to false or false to true. I will precede this Boolean with the not logical operator, which is an exclamation point. Now we're checking if it's not sunny. Then we will console.log it is cloudy. Else, it is sunny. Is it not sunny outside? It is cloudy. Let's change this to be true. It is sunny. So basically, the not logical operator, it'll change true to be false and false to be true. All right, everybody, so that's a short topic today. Logical operators. They're used to combine or manipulate Boolean values. Use AND to check to see if at least two conditions are true. With OR, at least one condition needs to be true. And with not will do the opposite. And well, that is an introduction to logical operators in JavaScript. So, yeah, it's me again. So today I'm going to explain the strict equality operator, which is represented by 3 equal signs. Before we dive in, let me make a few important distinctions. A single equal sign is the assignment operator. You usually see it when you assign a value to a variable. The comparison operator, 2 equal signs, is used to compare two values to see if they're equal. Now, the strict equality operator has a whopping 3 equal signs. It not only compares if two values are equal, but if they have the same data type as well. Let me give you a demonstration. Suppose we have a constant named pi. Pi equals 3.14. Pi in my example has a data type of number. I'll create an if statement. We will check if pi is equal to the string 3.14. If it is, let's console.log that is pi. Else, we will console.log that is not pi. Is the number 3.14 equal to the string 3.14? Well, according to JavaScript, that is pi. That's because we're using the comparison operator. We don't care about the data type. We only care about the value. Are the values equal? Now, if I was using the strict equality operator, which is 3 equal signs, well then JavaScript tells me that this is not pi. Because with the strict equality operator, not only do we compare the values, but we also compare the data types as well. These values are both 3.14, but this one is a number data type, and we're comparing it to a string. so they don't match technically. If we were strictly comparing the number 3.14 to the number 3.14, well then we have a match. That is pi. One case where this is pretty helpful is when you accept user input, because user input tends to be a string data type. And then just as an extra measure, you can use the strict equality operator and then be sure that the value is a number data type. There's also the inequality operator. It will return true if two values are not equal. So let's take... Shut up. This time we will examine if pi does not equal the string 3.14. If these are not equal, this condition will evaluate to be true. So this is not pi, else this is pi. Is the number 3.14 not equal to the string 3.14? Well, that is pi still. Using the inequality operator, these values are still the same. The inequality operator will return false. Then there's the strict inequality operator. An exclamation point and two equal signs. Are the values or the data type different? So in this example, that is not pi. They have the same values, but the data type is different. If I turned my variable pi into a string, well, that is pi now. The string 3.14 stored within pi does equal the string 3.14, so this condition turns out to be false. So we execute the else statement. It might take you a little bit of time to get used to this, and that's okay. It is a little odd. But just in case you see these in the future, you'll at least be familiar with them. From now on, we will try and use the strict equality operator if we can. And well, everybody, that is the strict equality operator, and I guess, well, the inequality operator and strict inequality operator in JavaScript. Hey, what's going on, everybody? So today I'm going to explain while loops in JavaScript. A while loop will repeat some code while some condition is true. Take this program, for example. We have a variable username. If our username is equal to an empty string, then we will console.log you didn't enter your name. Else console.log hello username. If I run this program, then check within our console, well, we didn't enter our username. Now, if I were to change this program to a while loop, while our username is equal to an empty string, repeat this line of code forever, until this condition is no longer true. Then when we escape the while loop, we can print the message, hello username. This is what happens when I run the program. We just print this line of code forever, and my computer is probably going to crash. I can't seem to stop. Help! Okay, I think it broke. A while loop will continue some code infinitely while this condition is true. If it no longer is true, then we can escape the while loop. If I were to set my username to be something other than an empty string, well, we never actually enter the while loop. We skip over it entirely and go straight to console.log at the end. So what we do first is check the condition. If it's true, then we get sucked into the while loop and execute this forever. You usually want some sort of way to exit the while loop while you're in it. Otherwise, you get what is known as an infinite loop. So let's rewrite this program. Let username equal an empty string, while our username is strictly equal to an empty string. Let's ask the user to enter in their name. Username equals, I'll use a window prompt. Enter your name. Okay, let's try this again. Enter your name. I'll press OK. We can't seem to close this window until we type in something. You can see I'm clicking on OK, nothing's happening. I will type in my name, press OK. Then our console displays hello, whatever your name is. So that's a benefit of a while loop. Repeat some code until this condition is no longer true. Since we populated our username was not equal to an empty string. We filled username with some characters. What if I instead press cancel? Hello, null. Null means no value. Username will equal null if I press the cancel button. Let's append this condition. Or, username is strictly equal to null. Now, I shouldn't be able to continue until I type in something, and I can't escape if I hit cancel. While one of these conditions is true, execute this code forever. Let's type in our name again. And now we can escape the while loop. There's also another variation of a while loop. It's known as a do while loop. How that works is that you can move while and the condition to the end. So we'll place it here. Then precede the set of curly braces with do. So we will always execute this code at least once, then check the condition at the end. Using a do while loop, I don't necessarily need to set the username. I can set it to be undefined. If I set my username to be undefined, then use a standard while loop, we never execute the while loop. Our username equals undefined. It doesn't equal an empty string or the value null, so we skip over the while loop entirely. So a do while loop is another variation of a while loop. Do the code first, then check the condition at the end. So there's a few different ways you can write the same program. Alright, let's go over another example. We'll create 3 variables. Let logged in. Logged in will be false to begin with. To log in, we have to type in a matching username. I will declare a username but not assign it, and a password. So let's create a while loop. How do we escape the while loop? Let's say while not. I'll use the not logical operator. While not logged in. Once we're logged in, once this is true, we escape the while loop. We will ask a user for their username. Username equals window.prompt. Enter your username. Let's ask for a password as well. Password equals enter your password. I'll add an if statement within the while loop. We'll check to see if our username is strictly equal to, then make up some username. My user name. And if our password is strictly equal to some password, like my password. If our username and password both match these values, then we can log in. So logged in will equal true. Then I'll console.log a confirmation message. You are logged in. Else, let's console.log another message. Invalid credentials. Please try again. All right, let's see if this works. Enter your username. I am just going to press OK. Enter your password. I'll type in something legitimate, so I'll type in my password. Invalid credentials. Please try again. That's because I didn't type in a username. I'll type in my username. Be sure it matches. My username. My password. And we are now logged in. So since we set logged in to be true, when we go back to the beginning of our while loop, this condition is no longer true, while not logged in. But since we're logged in, we escape the while loop. Now another variation of this is the do while loop. Let's cut the condition along with while, add it to the end, then add do to the beginning. So we'll check to see if we're logged in at the end. It pretty much does the same thing, but with one exception. In this program, how this is different is that I can set logged in to be true to begin with. We'll still receive that prompt. I'll type in my username, type in my password. We are currently logged in, so we do not continue the while loop. If we used a standard while loop, and we begin by being logged in, well, we never ask for any of this. We never enter the while loop. While not logged in, do all of this. But since we are logged in, we don't do any of it. Alright everybody, so that's while loops. Repeat some code while some condition is true. While some condition remains true, execute this code forever until it's no longer true. And well everybody, that's while loops in JavaScript. Alright, what's going on people? So today I'm going to discuss for loops. A for loop will repeat some code a limited amount of times. With a while loop can repeat some code infinitely. With the for loop, we can do something a certain or limited amount of times. Here's an example. Let's say we would like to display the word hello 3 times. With the for loop, we can write something like this. Now to create a for loop, type for, parentheses, curly braces. Within the set of parentheses, we have up to 3 statements. The first is that we can create a temporary counter, much like we're assigning a variable. Let's create a counter named I. Let I. I is a common naming convention for counters within a loop, I meaning index. So let I equal, what number would we like to start at? Let's start at 0. Then semicolon. This is the first statement. We'll create a counter to keep track of the number of iterations. The next statement is the condition in which we continue the for loop. We will continue this for loop as long as I is less than or equal to 2. That's if we're going to execute this for loop 3 times. 0, 1, 2. That would be a total of 3. Then the third statement, we can increment or decrement our counter I. So let's increment our counter by 1 during each iteration by typing I++. And that's a for loop. I is set to 0, will continue as long as I is less than or equal to 2. Then during each iteration, we will increment I by 1. That means we will execute this for loop 3 times. What are we going to do when we execute each iteration? Let's console.log hello. So this should display the word hello 3 times. Yep, hello 3. Now if I were to instead console.log I, we can see what I is. So during the first iteration, I, our counter, is 0, then 1, then 2. If I wanted to count up to 10, I could change my condition to be this. I is less than 10. So we begin at 0, then we count up to 9. So if I need 1 through 10, I'll set I in the beginning to be 1, then continue as long as I is less than or equal to 10. There, so we have numbers 1 through 10 using a for loop. We can even increment by a different number. Instead of incrementing our counter by 1, let's increment by 2. So I plus equals 2. So then we should count up by 2s. 1, 3, 5, 7, 9. If I want to start at 2, I can change our counter to start at 2. Count from 2 to 10, but increment by 2. 2, 4, 6, 8, 10. If we would like to count down, let's start at 10, then count down to 0. Let I equal 10. We'll continue as long as I is greater than 0. Then I minus minus to decrement. Hey, for fun, after we escape the for loop, let's console.log Happy New Year. It's as if we're counting down to midnight on New Year's Eve. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Happy New Year. Or we could count down by 2. I minus equals 2. 10, 8, 6, 4, 2. Or 3. Or whatever number. 10, 7, 4, 1, Happy New Year, or whatever number you want. Now I'm going to cover continue and break. This time we will count to 20. We need a for loop. We'll create a counter. Let I equal, I'll set I to be 1. That's our first statement. Our condition is we'll continue as long as I is less than or equal to 20, then increment I by 1 during each iteration. So to test this, let's console.log I. So we have the numbers 1 through 20. So with continue, we can skip an iteration. I'm going to write an if statement. If I is equal to, now there is a superstition that 13 is an unlucky number. Let's say if I is equal to 13, we will skip that iteration. I know it's a weird example. So if I is equal to 13, let's continue. Continue will skip this iteration of the loop. Else, we will console.log whatever I is. So now when I run this program, we skip over 13. We jump from 12 to 14. So if you ever need to skip an iteration, you can use the continue keyword. Now there's break. Break will break out of the loop entirely. We've seen this keyword in switches to break out of the switch. If I equals 13, then just exit the for loop entirely. So in this example, we count up to 12, but since I now equals 13, we break out of the loop entirely. We don't continue the rest of the iterations. Alright everybody, so those are for loops. You can repeat some code a limited amount of times. There's up to 3 statements we can write. We can create a temporary variable that serves as a counter, a condition in which we should continue, then we can increment or decrement our counter. And those are for loops in JavaScript. Hey, what's going on everybody? In this video, we're going to create a number guessing game using JavaScript. So why don't you go ahead and sit back, relax, and enjoy the show. All right, let's get started everybody. So the first thing that we're gonna need is to set the minimum and the maximum numbers in our number guessing game. So we'll create 2 constants. Const min num for the minimum. I will set my minimum to be 1, but feel free to pick a different number if you would like. Then a maximum. Const max num. I will set my maximum to be 100. So what we got to do is generate a random number between our minimum and our maximum, inclusively. So let's create another constant. Const answer. Then we'll generate a random number between 1 and 100, our minimum and our maximum. To do that, we can type math.random. The random method of math will generate a random number between 0 and 1. We will multiply this by, within a set of parentheses, the range between our maximum minus our minimum. Then add +1. Let's see what we have so far. Just to test everything, I'm going to console.log our answer. Okay, let's inspect, go to console. Here's my answer currently. 56 point, and then a bunch of decimal places after. I will round our answer by enclosing this equation with math.floor to round down. Okay, let's see what we get again. 39, 89, 20, 71, 27, 17, 46. Okay, that seems like it's working. What if we have a higher minimum? Let's say between 50 and 100. Well, I have 7, 22, 43, numbers that are below our minimum. So if we have a minimum besides 1, I will add to the end of this equation our minimum again. Okay, let's see if that works. So if I need a random number between 50 and 100, this equation should work. 97, 80, 79, 52. All right, that seems like it's working. So this is the equation you'll need to generate a random number between your minimum that you set and your maximum. But let's change our minimum back to 1 and make sure our maximum is 100. All right, let's move on to step 2. We'll create a variable named attempts to keep track of the attempts it takes a user. I will set attempts to be 0 and let guess. I will declare this variable but not assign it quite yet. We'll take care of that later. I will also create a Boolean variable named running, and I will set this to be true. The reason that we have the Boolean variable running is so that we can exit the game when it's over. We'll set running to equal false. So to keep the game running, we'll use a while loop. While running equals true. Now, if this is a Boolean variable, you don't necessarily need this portion, equals true. You can just set this to be while running. While this Boolean is true, keep the game going. Then when we want to exit the game, we will set running to equal false. So that will be at the end. Now we need to accept some user input. I'll do this with the window prompt. We will set our guess to equal window.prompt. I'll use a template literal. Guess a number between, I'll add a placeholder, our minimum, through, add another placeholder, our maximum. All right, to test this, I'm going to console.log the type of guess, as well as what guess is. There's something I need to show you. Guess a number between 1 and 100. I'll guess something right in the middle, 50. Let's inspect, go to console. So my user input of 50 is a string data type. We'll need to convert it to a number for comparisons. So after we get our guess, let's reassign it and typecast it as a number type. Let's try that again. Guess a number between 1 and 100. I'll type 50. Okay. Inspect, console. We have our guess of 50, and it's a number data type. What if you were to type in something that wasn't a number? Like a string of characters such as pizza. Here's the result. If you typecast some characters that are non-numeric, you know the numbers 0 through 9, you'll end up with not a number. Pizza can't be converted to a number, unfortunately. I will delete this line of code. We no longer need it. I'll add an if statement. There's a function to check to see if something is not a number. Is not a number function. If our guess is not a number, if this evaluates to be true, let's add an alert. Window.alert. Please enter a valid number. Guess a number between 1 and 100. What if I type pizza? Please enter a valid number. Now, what if somebody types in a guess that's below our minimum or above our maximum? I'll add an else if statement. Else if our guess is below our minimum or our guess is above our maximum. We'll window.alert. Please enter a valid number again. Guess a number between 1 and 100. What if I type in 150? That's above our maximum. Please enter a valid number. Please enter a number between 1 and 100. -1. Please enter a valid number. If the user's guess is a number, and it's between our range, between the minimum and the maximum, we'll execute an else statement. If they reach the else statement, that means they have a valid number. We'll increase our attempts variable by 1. Attempts ++ to increment it. If the guess is less than the answer, then we'll window.alert too low. Try again. Else if the guess is greater than the answer, we'll window.alert too high. Try again. If the guess isn't lower than the answer, and the guess isn't higher than the answer, that means the guess must equal the answer. Within an else statement, we'll congratulate the user. They have the right answer. Window.alert correct. The answer was, and I should probably use a template literal for this if we're inserting variables. The answer. We'll let the user know how many attempts it took. It took you the variable attempts, then the word attempts. At the end of our else statement, we'll move running equals false to within the else statement at the end to exit the game. We no longer want to play once we have the correct answer. All right, and this should work. Let's try it. Guess a number between 1 and 100. I'll guess something right in the middle, 50. Too low, try again. Okay, so the answer is between 50 and 100. 75. Too high. So it's between 50 and 75. 62. Too low. 68. Too high. So it's between 62 and 68. 65. Too high. 63. Too low. 64. Yeah, correct. The answer was 64. It took you 7 attempts. And we can exit. All right, everybody, so that is a number guessing game in JavaScript. Hey, welcome back. So today I gotta explain functions in JavaScript. A function is a section of reusable code. You declare that code once, and you can use it whenever you want. All you have to do is call the function to execute that code. Here's an example. We'll create a function to sing happy birthday. Whenever we call this function, it's gonna sing happy birthday. So to declare a function, you type function, a unique function name. Let's name our function happy birthday, because it's, well, the happy birthday function. Then you add a set of parentheses, then you add a set of curly braces. Any code we write between this set of curly braces, we can reuse whenever we want. So what do we want to do exactly with this function? I'll create the lyrics to my own happy birthday song. Console.log happy birthday to you. Let's repeat that again. Happy birthday, dear you. Happy birthday to you. Trust me, I'm going somewhere with this. So we have a function. When we run the program, it currently doesn't do anything. To execute this code within the function, we have to call the function by its name, happy birthday. Then add a set of parentheses. So now we should execute this code. Yep, happy birthday to you, happy birthday to you, happy birthday, dear you, happy birthday to you. So to call a function, you type the function name, then you add a set of parentheses. I like to think of the parentheses as two telephones talking to each other. That's how I remember it. So if I were to call this function again, what do you think's going to happen? Well, we're going to execute this function twice. 3 times? We'll execute it 3 times. As many times as I want, in fact. That's what a function is. It's a section of reusable code. Reuse it whenever you want. You just have to call it. You can send a function some values or variables. Let's change our happy birthday function. I will turn this line into a template literal. Let's replace you with the placeholder. Then we'll add a username. I'll add one more line. We'll use a template literal. You are, insert a placeholder, age, years old. So when I run this program, we have an uncaught reference error. Username is not defined at happy birthday. So our happy birthday function doesn't know what our username is or the age. So we can send some information to the function when we call it. So within the set of parentheses, what would we like to send this function? Let's send our name. So whatever values you place within the function, be sure to comma separate them. So why don't you go ahead and send the happy birthday function a name and an age. But there's one step missing. These are known as arguments. They're data that you send a function, but you need a matching set of parameters within the parentheses of the declaration. In a way, we can define some temporary variables, and they're all comma separated. We will define a username parameter as well as age. Now this function should work properly. Happy birthday, dear bro code, you are 25 years old. So these are parameters, and what you send to the function are arguments. Let's call the function, but send different information. Happy birthday. How about SpongeBob? SpongeBob will be, I don't know how old he is according to SpongeBob lore, but let's say he's 30 years old. Happy birthday, dear SpongeBob, you are 30 years old. How about Patrick this time? It's his birthday. Everybody gets a birthday. Patrick will be 37. Happy birthday, dear Patrick. You are 37 years old. So that's a benefit of passing arguments to a function. When the function receives this data, it can do something with it. Now, the order of the parameters does matter. If I were to switch age and username, here's what happens. Happy birthday, dear 37. You are Patrick years old. With the arguments that you're passing to your function, you'll want to be sure that the parameters match up. All right, now I'm going to cover the return keyword. We'll create a few other function examples. We'll create a function to add 2 numbers. Function add. Then we'll need 2 arguments, which we will name x and y. So when we invoke this function, I would like to add x and y together. I'll create a temporary variable named result, just to store the result. Result equals x plus y. So I'm going to add two numbers together. Let's add 2 and 3 together, and let's see what happens. Well, nothing appears to happen. Well, we can send some data back to the place in which we call a function, but we need to use this return keyword. Let's return the result. So 2 plus 3 should be 5. After this function resolves, think of this function becoming the value 5. So we'll probably want to do something with that value. I'll store that within a variable. Let answer equal add 2 and 3. Then let's console.log the answer, which should be 5. When you return something from a function, after you resolve the function, think of it as becoming whatever is returned. In this case, it's our result. Or otherwise, I can place this function within console.log if we don't plan to store it at all. So add 2 and 3, then display the result, which is 5. There is a shortcut too. You don't necessarily need to declare a variable within this function. We could shorten this to return x plus y. That is also valid. So that should return 5. Okay, let's create a subtract function. Function subtract will return x minus y. But we need a matching set of parameters because I forgot that. Okay, let's see what happens when we subtract 3 from 2. That'll give us -1. Let's multiply. Function multiply. We'll multiply x and y together. Return x times y. We will multiply 2 times 3, which is 6. Divide. We need parameters x and y. Then return x divided by y. Then we will invoke the divide function, pass in 2 and 3. And the result is 0.666 repeating. Let's go over a more complex example. We'll create a function to determine if a number is even or odd. Here's the function. Function is even. We have one parameter, a number. So when we invoke the function, we'll have to pass in a number. So when we receive a number, how do we check to see if this number is even? Here's one solution. We'll use an if statement. If our number modulus 2. Modulus gives you the remainder of any division. If this number divides by 2 evenly, if this is equal to 0, and yes, I'm using the strict equality operator, I'm trying to use that more often. If our number is divisible by 2, then let's return the Boolean value true. Else we'll return false. Okay. Let's console.log. Let's check to see if a number is even. Let's start with 10. Is 10 even? That is true. How about 11? That is false. 12? 12 is even. So that's kind of cool. If you would like a shortcut for this, you can use the ternary operator. That would look something like this. We are going to return then a condition. What are we checking? Is our number modulus 2 strictly equal to 0? Question mark. So that is the ternary operator, the question mark. If it is true, then we will return a Boolean value of true, colon, false, if it's false. Is 12 even? That is true. Is 13 even? No, it's not. It's odd. How about 14? That is true. All right, last example. I think we're probably getting the hang of this now. We'll create a function to see if an email is valid. Function is valid email. What kind of information are we going to send? We'll set that up as a parameter. We will need an email. We'll invoke the isValidEmail function, and pass in an email. Why don't you type in your email? I'll just make one up. bro@fake.com. So when we invoke this function, this string of text will become our email. We'll check to see if our email contains the @ character. We'll use an if statement. If email, and there's a built-in method for this, the includes method. If our email includes the @ character, then we will return true. That is a valid email. They have the @ character. Else, we will return false. Is my email valid? That is true. Let's remove the @ character. brofake.com. Maybe it's a website or something. That is false. Let's try another email. Again, we're going to invoke the function is valid email. elonmusk.com. Don't actually go there. I don't know what's going to pop up. That is not a valid email. All right, how about Zuckerborg@meta.com? That is a valid email. It contains an @ character. And for something like this, if we're returning either true or false, we can use the ternary operator. Return. Then our condition is we're going to check if our email includes the @ character. Then add the ternary operator. If this is true, return true. Else, we will return false. So these should be the same, which they are. All right, everybody, so that's an introduction to functions. It's a section of reusable code. You declare some code once and use it whenever you want. You call the function to execute that code. If you need to send your function some data, you'll need a matching set of arguments and parameters. And you can return something too with the return keyword. We'll have more practice with this in the future, don't worry. And that is an introduction to functions in JavaScript. Hey, what's going on, everybody? So today I'm going to explain variable scope in JavaScript. Variable scope is where a variable is recognized and accessible. In this beginner's tutorial, we'll be discussing the differences between a local scope and a global scope. Suppose we have a variable. Let x equals 1. Each variable name needs to be unique within that scope. I couldn't declare another variable named x, where I set x to equal 2. If I were to run this, we have a syntax error. Identifier x has already been declared. You can reuse the same variable names in your program as long as they're within different scopes. To demonstrate, let's create two functions. Function1. Within function1, we will declare a variable x. X equals 1, then we will console.log whatever x is. Then let's create function2 by copying function1 and then paste it. Function2, x will equal 2, console.log x. If I were to invoke function1, x equals 1. If I were to invoke function2, well, x equals 2. So we have two variables with the same name in our program. That's legal as long as they have different scopes. Any variable declared inside of a function has a local scope, or anytime you declare a variable within a set of curly braces. There's no naming conflicts because they're within different scopes. That way you can declare variables with the same name, which we've done with x. Now functions can't see inside of other functions. Within function2, we will declare variable y equals 2. Then console.log x. Within function1, we will console.log y. If I were to invoke function1, we have an uncaught reference error. Y is not defined at function1. Functions can't see inside of other functions. Function1 has no idea what y is. We've declared that within another function. It's kind of like functions are neighboring houses. You can't necessarily see inside of your neighbor's house. Function1 has no idea what variable y is. Likewise, function2, if I were to invoke it, function2 has no idea what x is. Each of these variables are declared inside of a function, so they have a local scope. A global scope for a variable is any variable declared outside of a function. With function1, let's get rid of x, and we will console.log x. Function 2, we will get rid of y, console.log x. If I were to declare a variable outside of these functions, let x equal 3, I'll invoke function 1, we'll display x. X is 3, let's invoke function 2, x is 3. Any variable declared outside of a function has a global scope. It's available through the whole program. A global variable is recognized and accessible from anywhere. Hey, this is Bro from the future. I was editing this video and I thought of a really good analogy for global variables. Let's say that a function is a house. We live in function 1 and our neighbor lives in function 2. We can see inside of function 1, but we can't see inside of our neighbor's house at function 2. Anything that's declared in the global scope isn't found within any houses, it's outside. Everybody can plainly see it. It's kind of like a creepy stalker that's under a streetlight at 3 in the morning. Everybody, while inside of their house, can still see everything outside. That's an analogy I thought was kind of accurate to describe a global scope. However, it's not recommended to declare global variables in a large program, just because you can have naming conflicts. In a large program, I might accidentally reuse the variable x or change it somewhere. X is a very common name for a variable. So in a large program, I would stick with local variables. But in a small program like this, it's fine. When inside of a function, we'll use any local instance of a variable first. If it's not found, we'll look at the global scope. So within function 1, let's declare x to be 1. Within function 2, we'll declare x to be 2. And then within the global scope, we have x equals 3. If I were to declare function 1, do you think x will equal 1 or 3? Well, it's 1. If we have two variables with the same name, and they're in different scopes, we'll use the local version first. That's why x is 1 and not 3. If I were to invoke function 2, well, x equals 2. If these local variables weren't available, we would use the global version instead, where x equals 3. Alright everybody, so that is variable scope. It's where a variable is recognized and accessible. You have a local scope. That's any time a variable is declared within a set of curly braces. That variable is then only accessible to anything within that set of curly braces. And a global scope is where a variable is declared outside of any functions. It's available throughout the whole program. And well everybody, that is variable scope in JavaScript. Hey, what's going on everybody? In today's video, we're going to create a temperature conversion program using HTML, CSS, and JavaScript. So sit back, relax, and enjoy the show. Alright, let's begin everybody. We will begin within our HTML file. Make sure you've linked a script to your JavaScript file, which we'll fill in later. So within the body of our document, we will create a form element. Within our form, we will create an h1 heading for the title of this program, which we will name temperature conversion is good. After our h1 element, we'll create an input element. This is a self-closing tag. It's a text box. Since we're going to be converting temperatures, I will set the type to be number. So that should give us some arrows to increase or decrease the number, or type one in if we need to. I'm going to give this text box an ID of text box. We'll be referring to this text box by its ID later. I'm also going to go ahead and set an initial value of 0. Then we can increase or decrease the number, like I said before. It is a little small, but with CSS, we will increase the size. What I'm going to do now is create two radio buttons, along with labels. So we have input. Input is a self-closing tag. The type will be radio. And for the ID, this will be a radio button to convert to Fahrenheit. I can never spell Fahrenheit. We'll want the radio buttons in the same group. I will set the name of the group to be unit. Oh, looks like I misspelled type. There we go. So I'm going to place our radio button on a new line. So within our first input element, I will add a line break. Alright, so after our first radio button, I'll create a label for it. Label. This label will be for to Fahrenheit. And the text will be Celsius to Fahrenheit. Or if you prefer, you could create like an arrow. I don't really like the look of that. Let me use an emoji instead. So on Windows, to create an emoji, you can hold Windows and semicolon. Is there an arrow? That'll work. So when you click on the label, you should also be able to select the radio button. That's because the for attribute is the same as the ID attribute of the radio button. Okay, let's copy both the first radio button and the label, then paste it. But change Fahrenheit to Celsius. Let's switch these around. Fahrenheit to Celsius. To Celsius. I'm also going to add a line break after our first label. So right here. As well as here. Google wants to translate my webpage from German to English. It's probably because of the word Fahrenheit, I'm guessing. Now I'll create a button. The type will be button. The text will be submit. There is an on-click attribute for buttons. On-click. When we click on this button, we can execute a JavaScript function. Eventually, we'll be creating a function named convert. Actually, let's take care of that now before we forget. So within our JavaScript file, function convert. We'll fill this in later. So when we click on the button, we will execute the convert function. Then lastly, we're going to display a result, whatever the new temperature is. We'll use a paragraph element. The ID will be result. And just as a placeholder for now, I'm going to type select a unit. All right, so far so good. Let's style this program with CSS now. Be sure to save your HTML file. We'll move on to CSS. We will first change the body of our document. Let's change the font family of the body of our document. I'll pick Arial with a backup of sans serif. I'll change the background color too. Background-color. I like using HSL values. Let's type a color such as black. We will change the color to be HSL. I'll go with a very light gray color, like 95%. So the background is going to be slightly light gray. We'll fill in the form section to be pure white. We will select our H1 element. That's going to be the header. I'll pick a color. Again, I'll be using HSL values. Let's go with, I don't know, blue. Feel free to pick a different color if you would like. That's not bad. Then we'll fill in the form. Our form contains pretty much all of these elements. So let's select our form. I will change the background color. I'll just copy this line and paste it. But I'll make this pure white. I'll text align center everything within this form. So everything should be centered. I'll set a max width of the form because right now it's taking up 100% of the width of the web browser. So max width will be, how about 350 pixels? We would like this form to be within the middle, aligned horizontally. We can set margin to be auto to automatically center that. I'll add a little bit of padding around the elements within our form. Padding. Let's do 25 pixels. I'll smooth the corners of the form using border radius. Border radius. 10 pixels. Then I'll add a box shadow. Box shadow. The first value is the horizontal offset. Let's set that to be 5 pixels. Then the vertical offset, I will set that to be 5 pixels. The third value is the blur radius, because right now it's fairly concentrated. Let's stick with 15 pixels. Not bad. You can also select a color. Again, I'm going to use HSL values. You can also change the transparency. I'll set mine to be 30%, or approximately 30%. 0.3. Not bad. So that's my box shadow. Now we're going to change the text box. So this text box does have an ID. Text box. Let's select this element by its ID. I'll set the width to be 50%. It's going to take up 50% of the width available. Let's text align center. The number is going to be right in the middle. Let's change the font size. Let's do 2EM for 200%. I'll add a border. 2 pixels solid. Then I'll pick some HSL values for the color. I'll make it a little transparent. Maybe like 80%. Let's select a border radius. 4 pixels to smooth the corners. I'll add a little bit of margin below the text box. Margin dash bottom. 15 pixels is good. That's going to push the radio buttons down further, just to give this text box more space. Let's work on the radio buttons next. So we are selecting the labels. So let's take every label. I'll change the font size so it's a little bigger. 1.5 EM for 150%. I'll make the font weight bold, just to bold it. There. Let's select our button. We are selecting our button. I'll add a little bit of margin above the button. Margin dash top, 15 pixels. Let's change the background color of the button. Pick a color. I'll pick red. And again, I'm going to use HSL values because I like them. That's decent. I'll change the font size of the button, 1.5 EM for 150%. I'll remove the border, border none. I'll add some padding. 10 pixels for the top and bottom of the button, 15 for the sides. I'll round the corners with border radius. Border radius, 5 pixels. I'm going to change the font color. Color, white. Then when I hover my cursor over the button, I will change the cursor to be a pointer. And that appears to work now. So when I hover over the button, I'll use the hover pseudo class to change the background color of the button. We are selecting our button, then select the hover pseudo class. We'll make the background color just a little bit darker. We'll change the lightness of our HSL value to be like 10% darker. So I have 60%, I'll change that to be 50. So now the background should change when I hover over the button. Lastly, let's change the CSS properties of the result. So this should have an ID of result. Result. I'll make the font size a little bit bigger. Font size 1.75 EM is good. And I'll make the font weight bold. Font weight bold. All right, and that is all the CSS we need. Be sure to save everything, and then we will move on to our JavaScript file. All right, so what I like to do is at the top of my JavaScript program, I will declare all of the constants and variables that I'll need. So let's get our text box. I'll set this to be a constant. Const text box equals document.getElementById. The ID that we're selecting is our text box. We'll need the 2 Fahrenheit radio button. Let's copy this line, paste it. Get the ID of 2 Fahrenheit. Const 2 Fahrenheit, get element by ID, 2 Fahrenheit. Then 2 Celsius. 2 Celsius. Const 2 Celsius, the ID is 2 Celsius. So that will be this radio button. Copy this line, paste it. Then we need the result to display the result. Result, get element by ID, result. Within our HTML file, we don't necessarily need to select a unit anymore. We'll add that later if somebody presses submit without selecting a radio button. Then we need let temp for the temperature. When we click on the submit button, we will execute this function, convert. So what are we going to do within this function? We'll begin with an if statement. We'll check to see if our 2 Fahrenheit radio button is selected. So take 2 Fahrenheit. We'll use the checked property. If this radio button is checked, it's going to return true. If it's not, it's going to be false. Else if 2 Celsius is checked, 2 Celsius.checked, we'll perform some different actions. Else, let's change the content of our result. So here, result.text content equals select a unit. Let's see if this works. Be sure to save everything. I am not going to select a radio button, I'm just going to submit. And that's correct. Select a unit. We didn't select one. Let's be sure that these 2 radio buttons are working. Just temporarily, I'm going to change the result within the if and else if statement. You selected 2 Fahrenheit, and you selected 2 Celsius. I just want to be sure that these radio buttons are working. So let's convert 2 Fahrenheit, submit. You selected 2 Fahrenheit. We'll select the second radio button. You selected 2 Celsius. Okay, we know that this program is reading these radio buttons successfully, so we no longer need these 2 lines of code. We're going to get the number from our text box. We'll store that within temp. Temp for temperature. Temp equals, take our text box, access the value within. So when we accept user input, it's of the string data type. I'm going to typecast the value as a number, so we can use it with math. Okay, then we're going to take our temperature and convert it to Fahrenheit. Here's the formula. Temp equals temp times 9 divided by 5 plus 32. Then we're going to update the text content of the result. Result.textContent equals our temperature. Then I'm going to add plus Fahrenheit. So to add the degree symbol on Windows, you can hold Alt, then type 0176 on the numpad. So this will be Fahrenheit. Let's type 100 degrees Celsius to Fahrenheit. That gives us 212 degrees Fahrenheit. 10 would be 50. 1 degree Celsius would be 33.8. 0 is 32 degrees Fahrenheit. If you would like to add some precision following our temperature, there's a built-in method, toFixed. We'll add 1 point of precision. This will give us 1 digit past the decimal place. 0 degrees Celsius converted to Fahrenheit is 32.0 degrees Fahrenheit. 10 degrees Celsius is 50 degrees Fahrenheit. Let's copy these 3 lines, then paste them within the else if statement. We'll keep this line the same, but we'll change the formula. Temp equals, within parentheses, temp minus 32 times 5 divided by 9. Then change Fahrenheit to Celsius. So what is 32 degrees Fahrenheit converted to Celsius? That is 0. 100 is 37.8. All right, everybody, so that is a simple temperature conversion program using JavaScript, HTML, and CSS. Hey, what's going on, everybody? So today I'm going to explain arrays in JavaScript. Think of an array as a variable-like structure that can hold more than one value. For example, let's say we had a variable named fruit. Go ahead and pick a fruit. I'll pick an apple. Our variable can store one value, but we can turn a variable into an array, and it can store more than one value, and we can do so by enclosing all values with a set of straight brackets. Now my variable of fruit is now an array. It can store more than one value. Just be sure that each value is comma separated. This time I'll add an orange and a banana. Just to make it more obvious that this is an array, I'm going to add an S so that my variable name is plural. It's not mandatory, but it helps with readability. I now have an array of fruits. But let me show you something. If I were to console.log my array of fruits, Well, JavaScript is going to print out all of the elements in this array. Each item, each value, is known as an element. We have 3 elements. If you need to access an individual element, following the array, you have to add an index number, enclosed in straight brackets. If I would like the element at the first position, that would have an index of 0. That would give me an apple. Fruits at index of 1 would be orange. Fruits at index of 2 is banana. If I were to attempt to access the element at index 3, well, it's undefined. We only have 3 elements within our array: 0, 1, 2. Arrays always begin with 0. You can even change one of these elements by accessing that array at a given element. Let's access our array fruits at index 0. I will set this equal to be a coconut. So now we have coconut, orange, banana. Let's change fruits at index 1 to be a coconut. Apple, coconut, banana. Index 2 will be a coconut. Apple, orange, coconut. If I set fruits at index 3 to be a coconut, let me console.log that too. Fruits at index 3. We can add a new element to that array. Otherwise, to add an element, there's a built-in method of arrays. Fruits.push. To push an element to the end. I will add a coconut to the end of my array. Apple, orange, banana, coconut. Then we have pop. Pop is going to remove the last element. Apple, orange, undefined. The unshift method will add an element to the beginning. Take our array, use the unshift method, unshift. I will add a mango to the beginning of my array. Mango, apple, orange, banana. Then we have shift to remove an element from the beginning. Fruits.shift. Now we have an orange, banana, and my last 2 elements are undefined. To get the length of an array, there's a length property. Let's create a new variable. Let num of fruits to store the number of fruits that we have. Type the array name dot length. Then let's console.log the number of fruits we have. We have 3 fruits. I'll add another. I'll add a coconut to the end. And we have 4. So that's how to get the length of an array. There's a length property. Type the array name dot length. We can find the index of an element if there's a match. Let index equals, let's search for an apple. Fruits dot index of method. What are we searching for? Let's search for an apple. Then I will display the index. So our apple is located at index 0. Let's search for an orange. That's index 1. Banana. That's 2. Coconut. 3. What if we search for an element that doesn't exist, like a mango? Well, this method will return -1. That could be helpful within an if statement. You can check to see if this method returns -1. Then if it does, that means the element wasn't found, and you can let the user know. If index equals -1, display that element wasn't found. Now, if you would like to loop through the elements and display them, there's an easier way to do that. You can use a for loop. So for, there's up to 3 statements. We'll need a counter or some sort of index. Let I equal 0, that's the first statement. We'll continue this as long as I is less than our fruits array dot length property. Then we will increment I by 1. If we have 4 elements, we should execute this loop 4 times. During each iteration, I will console.log our fruits array, but the index, instead of being like 0, 1, 2, 3, a hard number, we'll use our counter, our index of I. And let's get rid of that line. Now we should loop through all of the elements of this array and print them out individually. Using a for loop, we can even increment by a different number, like 2. I plus equals 2. So here we're only displaying the apple and the banana. If I set index to be 1, then increment by 2, we'll display orange, then coconut. So using a for loop, there's a few different ways in which you can display the elements of an array. If you need to display the order of this array in reverse, we can change this around. We will set our counter I to be the length of our array. then we'll continue as long as I is greater than or equal to 0, then I minus minus. There's one change I'm going to make. We have undefined coconut, banana, orange, apple. So the length of my array is 4. But if I were to access our array fruits at index 4, where would that be? 0, 1, 2, 3. That's out of bounds. I'm going to set our index to be fruits.length minus 1. 0, 1, 2, 3. Our length is 4, minus 1 is a total of 3. Now we're printing our array in reverse. Coconut, banana, orange, apple. There's also an enhanced for loop. It's a shortcut to displaying the elements of an array. You can write something like this. Let fruit of our array fruits. Really, this variable can be anything, but I like to write a singular version of my array name. Then during each iteration, I will display each fruit. Apple, orange, banana, coconut. This is an enhanced for loop. It's kind of like a shortcut to displaying the elements of an array. If this array name were, I don't know, like meats, you could say, let meat of meats. And then display each meat. But of course, they're still fruit. That's a shortcut you can use. Now to sort an array, you can use the sort method. Fruits.sort. And that should sort the elements in alphabetical order. Apple, banana, coconut, orange. To sort them in reverse order, you can tack on the reverse method to the end. Fruits.sort method.reverse method. Now they're all backwards, in reverse alphabetical order. Orange, coconut, banana, apple. Alright everybody, so that's an introduction to arrays. We'll have a lot of practice with this in the future, so if you don't remember everything, that's okay. An array is a variable-like structure that can hold more than one value. A variable can hold one value. An array can hold many. And well, everybody, those are arrays in JavaScript. Hey everybody, today I'm going to explain the spread operator in JavaScript. The spread operator is represented by 3 dots. The spread operator allows an iterable, such as an array or string, to be expanded into separate elements. What this does is unpack the elements. Here's an example. Let's create an array of numbers. Pick some numbers. I'll just pick 1 through 5. 1, 2, 3, 4, 5. Then just to test this, let's console.log my array numbers. In this array, what if I would like to find the greatest value? Well, one way in which I could do that is let's declare a maximum. Let maximum, this is going to be a variable, equals, I will use the max method of math. What would happen if I place our array within this method? Then I will display our maximum. So we have not a number. Using the max method, we can't place an array directly within this method. However, by utilizing the spread operator, we can spread this array into different elements. So we will precede this array with the spread operator. We are going to unpack the elements. Now if I run this program again, we have our result of 5. When you use the spread operator, imagine that you're opening a box and taking out all the contents inside, like you're unpacking something. Let's find the minimum this time. Let minimum equals math.min. We will pass our array of numbers, then use the spread operator to spread our array into different elements. What is the minimum value from this array? That would be 1. You can also do this with strings too. You can separate a string into different characters. Let's create a username. Equals, type your name. First name and last name. I will create an array named letters. Letters equals, we'll create a new array. Let's take our username, it's a string, and use the spread operator. Then I will display our letters. Console.log letters. And here's my name, divided into different characters. What we have is an array of characters. With my array of characters, I can join them back together and insert characters between each element. I will method chain the join method after our array. We'll add a dash between each character. So now my username is all one string, but there's a dash between each character. Okay, now this time we're going to create an array of fruits. We'll make a shallow copy of an array using the spread operator. add some fruit. I'll add an apple, an orange, and a banana. Then I will console.log my fruits. I can create a shallow copy of this array using the spread operator. A shallow copy means it's a different data structure, but it contains identical values. I'll create a copy of fruits named new fruits equals an array. Let's take our fruits array, then use the spread operator. Let's display new fruits, and it should be an identical copy. Yep, there's no apparent change. We have two different arrays, but they contain identical elements. We can combine two or more arrays using the spread operator. Let's create an array of vegetables. Let's add some carrots, celery, potatoes. I'll rename new fruits as foods. Let's add our array of fruits, we're spreading it, comma, then we will spread our vegetables array. Then we will display our array foods. This array contains all of the elements from these two arrays, fruits and vegetables. We can use the spread operator to combine arrays. We even have the capability to append separate elements along with unpacking these arrays. I will also add eggs and milk. We have all of the elements from our two arrays, plus a few extras, eggs and milk. Alright everybody, so that's the spread operator. It's 3 dots. It allows an iterable, such as an array or string, to be expanded into separate elements. And well everybody, that is the spread operator in JavaScript. Hey, what's going on everybody? Today I'm going to explain REST parameters in JavaScript. REST parameters is a parameter prefixed with 3 dots. They allow a function to work with a variable number of arguments by bundling them into an array. It's very similar to the spread operator, which we talked about in the last video. The spread operator expands an array into separate elements. REST parameters do the opposite. They bundle separate elements into an array. Spread will spread an array into separate elements. REST parameters will bundle separate elements into an array. It effectively does the opposite. How could REST parameters be useful? Let me give you an example. Say we have a bunch of different food. Const food1 equals pizza. We'll create a few different food variables. Let's start with 4. Food1, food2, food3, food4. We have pizza, hamburger, hot dog, and sushi. I'm going to create a function that uses REST parameters. It's going to output all food that I send it. We'll pretend that we're opening a fridge. Imagine that all of this food is in a fridge. Open fridge. Fridge short for refrigerator. To use REST parameters, I need 3 dots. We're going to stick all of this food into an array. But what should the array name be? Let's say foods. That's descriptive. Then I'm going to console.log my array of foods. Now I'm going to call this function open fridge. I will send this function a variable number of arguments. This method is going to display an array. We have food1, pizza, food2, hamburger. Hamburger is also within our array. Food3, hot dog, food4, sushi. Let me add one more food. Let's add ramen. Food5 will be ramen. Then I will add food5. You can see that I can send this function any number of arguments that I would like. This function is designed to accept any number of arguments. I could combine this function with the spread operator. When I'm displaying my foods array, all of these elements are in an array, but I could separate them back into separate elements by using the spread operator, which is the same 3 dots as the REST parameters. REST parameters are used as parameters. The spread operator is used whenever you have an array, or any sort of collection of something. So now when I combine the REST parameters and the spread operator, I can display all of my separate elements. You can even use REST parameters to stick all elements within an array. So this time I'm going to create a separate function to get food. We will use rest parameters. Our array name will be foods. All we're going to do is return foods. Take all of these separate elements, stick them within an array, then return that array. So I'm going to create a new array, const foods equals, call our getFood method, pass in a variable amount of arguments. Let's pass in food1, food2, food3, food4, and food5. And then we got to display it. Console.log myArray foods. So that's how the rest parameters can be used to combine elements and bundle them into an array. Then if you want, you can return the array or do whatever you want with it. Let's go over a second example. We'll create a method to sum a bunch of numbers together. Function sum. We will use rest parameters so we can accept any number of arguments. Our array name will be numbers. What we'll do within this method is have a result. Result equals 0. We'll keep track of the current sum within our result. I'll create a for loop to iterate over our array. For every let number of numbers, take our result plus equals the current number. And then we are going to return our result. Now we'll have const total equals, invoke our sum function, pass in as many numbers as we would like. Let's start with 1. Oh, then I should probably display the total. Console.log. I'll use a template literal. Your total is, I'll add a placeholder, total. Your total is $1. Let's add a few more arguments. 2. The total is now $3. 3, $6. 4 is 10. 5 is 15. Let's create a function to calculate an average. Let's copy our sum function. Let's name this function getAverage. All we have to do when returning our result to get the average is divide our result by the length of our numbers array. Divided by numbers.length property. That will give you the average. So now, const total equals get the average. Maybe these are test scores. One student got a 75, another got 100, another student has 85, 90, and a 50. Let's console.log the total. The average is 80. Let's go over example 3. You can use the rest parameters to combine strings together. We will create a function to combine strings. We'll send in a title, like Mr., a first name, such as SpongeBob, a last name, SquarePants, he's the third. We still need to make this function though, but const full name equals whatever string is returned. All right, let's work on this function. Function combine string. Let's make this plural, strings. We need to use rest parameters. Let's name our array strings. An easy way to do this is to return our array of strings and use the built-in join method to join all of the strings together. But we'll add a space between each string. All right, we should now have a full name variable. That's all of the strings combined. So let's console.log our full name. Mr. SpongeBob SquarePants the third. That's one way in which you could use the rest parameters to combine a bunch of strings into one, such as if you're creating a full name. Alright everybody, so those are rest parameters. They allow a function to work with a variable number of arguments by bundling them into an array. It's the opposite of the spread operator. The spread operator expands an array into separate elements. The rest parameters bundle separate elements into an array. And well, everybody, those are REST parameters in JavaScript. Hey everybody, so in today's video we're going to use JavaScript, HTML, and CSS to create a dice roller program. This is an optional project. You will need some images of dice to work with. If you're able to find some images of dice, I would save them somewhere, maybe on your desktop. Once you have images of your dice, we're going to create a new folder. New folder, I'll name my folder dice_images. Then take all of your dice images, move them to that folder. And now we are ready to begin. We'll create all of the HTML elements that we'll need. I will create a div section. This div will have an ID of container to contain our program. I'll include an h1 heading with text of dice roller. After this h1 element, I'll create a label. The label will have text of number of dice. Afterwards, I'll use an input element. I'm going to zoom in a little bit temporarily. With this input element, I'll type in a number of dice I would like, such as 1, 2, 3. However, I can type in characters, which I would like to avoid. I will set the type attribute of the input element to be number. We're indicating to the user to select a number and not type in anything. Although there are ways to circumvent this. This will be good enough for now. For the input element, we can set a default value. I will set the value attribute to equal 1 for the default. We can go below 0. I'll set a minimum with the min attribute. Min equals 1. We can't go below 1, but we can select any number 1 or above. Now we'll create a button. The button will have text of roll dice. The button will have its onClick attribute, I keep on spelling onlick, onClick attribute set to a JavaScript function. Let's say roll dice. We'll still need to define this function in JavaScript. After our button, I'll create two div sections. The first will have an ID of dice result. This will display some text, the numbers of the dice we roll. The second div element will be for the images. ID dice images. And that is all the HTML that we'll need. Let's head to our CSS file, and I'll zoom back to 100%. Let's select our ID of container. Hashtag container. I will change the font family to a sans serif font, such as Arial, with a backup of sans serif. I will text align center, increase the font size. In this project, I'm going to use REM instead of EM, because we'll be working with a lot of different font sizes. EM is the font size relative to the parent. REM is for the root. For this specific project, I'll stick with REM. And I will set the font weight to be bold. Let's style our button next. We are selecting our button. I'll increase the font size of the button to be 1.5 REM. I'll add a little bit of padding, 10 pixels by 15 pixels. I will set the border radius to round the corners, 10 pixels. Remove the border because it's ugly. Border none. Pick a background color for the button. I'll pick something blue, but I like using HSL values. Something like that looks good. I will change the font color to be white, and I will set the font weight to be bold. Not bad. When I hover my cursor over the button, I will change the cursor to be a pointer. Let's change the background color of the button when we hover over it. We are selecting the hover pseudo class of the button. Let's take our background color. I'll increase the lightness by 10%. So that should change when we hover over the button. Now when I click on the button, I'll increase the lightness even more to show that it's active. With our button, we will select the active pseudo class. I'll set the lightness to be 70%. So when we click on the button, it should flash momentarily, which it is. Let's style the input element, because I can barely see it. With our input element, I need to scroll down. Let's increase the font size to 2 rem. I'll set a width of 150 pixels. Text align center. And font weight bold. With our HTML file, we do have 2 empty div elements currently. We'll style these at the end. Once we get our images to populate, we'll style that last. With the onClick attribute of the button, we set a function of roll dice. Now we need to define it. Within our JavaScript file, we will define a function to roll dice. We have a lot of constants to declare. I'll create a constant for the number of dice we would like. What's the value of this input element? I will define const num of dice. What is the number of dice we need to roll? Equals document.get element by ID. The ID of this input element is, I actually forgot. What was it? Oh, we didn't set an ID. Okay, let's do that. Okay, so for the input element, the ID will be num of dice. Num of dice. But I would just like the value. I will access the value of whatever this input element is. For the next constant, we're going to get the dice result. This empty div section. Const dice result equals, let's copy this line of code, but we don't need the value. We just need that ID, dice result. Then let's do this with dice images. So we can copy this, paste it, const dice images. The ID was dice images. I'll create 2 empty arrays. Const values. This will be an empty array. We'll store all of the dice rolls, the numbers. Then we'll need an array of images. Const images. This will be for the images of the dice. At this point in time, we're going to create a for loop that will loop once for every dice that we roll. We have to generate a random number between 1 and 6 for each dice we're rolling. If I'm rolling 3 dice, I need a for loop to iterate 3 times. Let's create a for loop. Let I equal 0. Continue this as long as I is less than the number of dice. Then increment I by 1. During each iteration, I need to generate a random number between 1 and 6. I'll store that within a constant. Const value, that will be the random number, equals math.random method. This generates a random number between 0 and 1, but I'm going to multiply it by 6 to give us a random number between 0 and 5. It's not going to be a whole number though, so I'm going to round it using math.floor. Then enclose this part of our equation. Now we should get a random number between 0 and 5, but I need a random number between 1 and 6, so I'll add 1 to the end. Plus 1. So now we'll get a random number between 1 and 6. Just to be sure that this all works, temporarily, I'm going to console.log our value. If I roll 1 dice, we should get 1 random number. 1. Let's try 3 dice. 5, 4, 6. 3, 2, 4. Alright, we don't need this console.log statement anymore. We know that it's working. With these values, I'm going to push them into our array of values. Take our array of values, use the push method, add our value that we randomly generate during each iteration. And let's see if this works. I'm going to console.log my array of values, just to be sure that there's some numbers in there. Let's roll 4 dice. inspect, console. I have an array of 4 elements, the numbers 6, 3, 2, 6. So that does work. All right, here's the tricky part. I need to take my array of images, use the push method. I will create a string representation of an HTML element. I need to get one of the images found within this dice images folder. Using angle brackets, I will create an image element. I will set the source equal to that folder name. So my folder name was dice_images. Dice_images / So with my images, it might be different for you. Mine are labeled appropriately, for 1, 2 for 2, 3 for 3, so on and so forth. I will use a placeholder, add our value, this number, then follow this with the file extension of the images. My images are PNG images. Do pay attention to that. After we exit this for loop, we should have an array of HTML images. Then we're going to take our dice result constant, change the text content to equal all of the values. I'll use a template string. I will display the word dice, add a placeholder. I'm going to join all of the elements together, all of the values. To do that, you can take your array of values, use the built-in join method, and I will join them all by a certain character or characters. I will join all of these numbers by a comma and a space. Let's see if this works. I'm going to roll 1 dice. Yep, dice. I rolled a 1. I rolled a 4. I rolled a 3. Let's roll 2 dice. I have 2, 5, 4, 6, 2, 2, 3, 6, 3, 2. Then we have to get the images. Let's take our dice images constant, access the inner HTML, set this equal to, take our array of images, use the built-in join method. I'm not going to join them by any character. I'll join them by an empty string. And let's see if this works. I would like 1 dice. Yeah, there it is. 2 and 3. Now, for some reason, if your dice isn't displaying, with our image element, I will set the alt attribute to equal a string of dice space, add a placeholder, value. Let's say I get the folder name wrong. I will rename this as dice image. I'll attempt to display 1 dice. Dice 3, dice 4, dice 3. So in case our image can't display for some reason, we'll at least display the alternative text. This is good for troubleshooting and for screen readers for accessibility. Let me correct the name of the folder again. So with our dice images, at least for me, they're kind of big, and I'd like to space them out a little bit. Our last step is we're going to go back to our CSS style sheet. I will select the ID of dice result. That's going to be for this title right here. I'll add some margin around this text. Right now it's kind of compressed. I will set margin of 25 pixels. Then with our dice images, ID dice images, with my ID of dice images, take each child image, set a width of 150 pixels should be good. Yeah, they're a lot smaller now. I'll add a little bit of margin too. Margin, 5 pixels. Yeah, that's not a bad looking program. All right, everybody, so that was a dice roller program you can make using JavaScript, HTML, and CSS. Impress your friends. And that's pretty much it. Hey, what's going on, everybody? So in today's lesson, we're going to create a project where we generate random passwords. This will help us solidify our understanding of functions and random numbers. This will be an exercise for beginners. By setting different options, we can change the format of the password. And well, let's begin, everybody. All right, let's begin. We'll need to let our program know what the length of our password is going to be. Let's create a constant to store that. Const password length. Set this equal to maybe 12, but we can adjust that accordingly. We'll create a boolean to specify if our generated password is going to contain lowercase characters. We'll create a constant include lowercase. Do we want to include lowercase characters? We can set this to be true or false. We will set this to be true. Do we want to include uppercase characters? Include uppercase. I will again set this to be true. Do we want to include numbers? Const include numbers. I will set that to be true. Do we want to include symbols? Const include symbols. We'll define a function at the top of our program. Function to generate password. We have a lot of parameters to set up. We're going to pass in all of these constants as arguments. So we have a length, include lowercase, include uppercase, include numbers, and include symbols. When we call this function, we have to pass in all of these arguments. So we will call our generate password function, pass in our password length, include lowercase, include uppercase, include numbers, and include symbols. At the bottom of our function, we will be returning a password. But for now, I'm just going to write an empty string, because we still need to determine what that password is going to be. After finishing the generate password function, this will return a string password. We will store that within const password equals whatever is returned from the generate password function. And just so that this is more readable, although not necessary, I'm going to place each of these arguments on a new line because I'm OCD about things being in alignment. And then at the very end of this program, I will display a template string of generated password. I'll add a placeholder, then we'll display our password that we generate. So right now, it's not going to display anything. We're returning an empty string. But that is everything we need outside of this function to generate our password. Basically, we're passing in options when we generate our password. Do we want to include lowercase characters, uppercase characters, numbers, and or symbols? We have a number and a bunch of Boolean values. Within our password, we're going to create a few constants within this generate password function. We will create one long string of all of the lowercase characters, chars, equals, I'm going to go through the alphabet. We will have one long string of alphabetical characters. And I think I got all of them. So there should be 26. Now we're going to do this with uppercase characters. Const uppercase chars equals, I'm going to turn on caps lock, go through the alphabet, we'll create a constant of number characters. Number chars equals 0 through 9. And symbols. Const symbol chars. Which symbols would you like to include? I'll just add a bunch. That's probably good enough for now. Feel free to add more or less. We will create a variable for allowed chars, meaning characters, and an empty password. Let password equal an empty string. If some of these constants are true, we would like to take that corresponding set of characters and concatenate it to the allowed char string. So what we'll do is take our allowed characters variable, use string concatenation by using plus equals. We'll check to see if include lowercase is true or false. We can use the ternary operator for that. If we would like to include lowercase characters, we will string concatenate our lowercase chars, our lowercase characters. Otherwise, we'll concatenate an empty string. Let's do this with uppercase characters. With our allowed characters, let's string concatenate and check if we're including uppercase characters. Question mark. If this is true, we will concatenate all of the uppercase characters we've declared. Otherwise, we'll concatenate an empty string, so we don't include them. Let's do this with number chars. Include numbers. Are we including numbers within our password? If so, we will return our number chars string, and then symbols. Are we including symbols within our password? If so, concatenate our string of symbol characters. All right, just to test everything, afterwards, I'm going to console.log our allowed characters. So right now, I'm going to switch all of these constants to be false. So right now, we're not including any characters. If I were to set include lowercase to be true, we would include all of the lowercase characters. That's one long string. Let's test uppercase. Yep, we are including all of the uppercase characters. Include numbers. Yes, that works. And include symbols. That also works. At this point in the program, we're going to have one gigantic string of all of the possible characters. Before we move on with the program, I do want to run some checks using some if statements. First, let's check to see if the password length is 0 or less than 0. Right now it's set to 12. Using an if statement, if the length of the password, is less than or equal to 0, we need to let the user know that the password length must be at least 1. We will return a string. Password length must be at least 1. Right now we're not generating a password, we're returning an empty string. If I set the password length to be 0, we will generate this message. Password length must be at least 1, or even a negative number, like -1. Password length must be at least 1. Let's set that back to be 12. What if we don't select any options? What if all of these character options were false? We can check the length of our allowed characters variable. So if our allowed characters length property is strictly equal to 0, this will only be possible if all of these options are set to false. We will return a template string. At least one set of characters needs to be selected. And let's see if this works. Yes, it does. At least one set of characters needs to be selected. I can select any options that I would like. I will set these all to be true. Now here's the hard part. For as many iterations as our password is, we will select a random character from all of the different possibilities. We will use a for loop. We will let I be our index, our counter. We will continue this for loop as long as I is less than the length, the password length. Then increment I by 1 during each iteration. If our password length is 12, we will execute this for loop a total of 12 times. Now we will generate a random index. Const random index equals, we will use the random method of math. This generates a random number between 0 and 1. I can multiply this number that's randomly generated by the length of our allowed characters. Let's say we're including only lowercase characters. Well, this is a total of 26 characters in the alphabet. If I'm taking math.random times 26, I'll be given a random number between 0 and 25, but I will need to round it down. Let's enclose this equation with the floor method of math to round down. Math.floor. We'll use string concatenation with our password. Currently our password is an empty string, but we will use string concatenation. We will string concatenate a randomly chosen character from our string of allowed characters. Password plus equals our allowed characters at the index of random index. Then at the end of this program, we will return our password. And let's see if this works. Let's close out of this function. We don't need it anymore. And let's see if this works. Yeah, there's our password. So every time I run the program, I get a new random password. And I can turn these options on and off. Let's set all of these options to be false to begin with. And I will set the length to be 0. Let's see what happens. Password length must be at least 1. All right, how about a password of 10 characters long? At least one set of characters needs to be selected. Let's select only lowercase characters. Yep, we only have lowercase characters. Let's allow uppercase characters now. Let's allow numbers. I didn't get any of that time. Let's do it again. Okay, there's a number. I guess numbers don't come up very frequently. And let's include symbols. And there's a few symbols in there. All right, everybody, so that was an exercise to generate random passwords. It should give you some practice with functions and working with random numbers. And well, everybody, that was a random password generator in JavaScript. Hey, welcome back, everybody. So today I gotta explain callbacks in JavaScript. A callback is a function that is passed as an argument to another function. They're used to handle asynchronous operations such as reading a file, network requests, or interacting with databases. These activities take some time to complete. Now with JavaScript, we don't necessarily wait for a process to finish before continuing with the rest of the program. For example, if we were to read a file, if it takes a long time to read that file, JavaScript might continue on with the rest of the program. We might attempt to display the contents of that file before we're finished reading it. That's where callbacks come in. We're telling JavaScript, hey, when you're done, call this next. When you're done reading the file, then display the contents, only after that process is complete. I'll give you a few examples of the syntax of a callback. We'll start with something really simple. We'll create a function to display the word hello. This will be the hello function. Then I will console.log the word hello. So I can invoke this function, hello, to execute it. Hello. What if we were to create a function for goodbye? Function goodbye. We will console.log goodbye. Okay, after hello, let's invoke goodbye. We have hello, then goodbye. What if my hello function takes a lot of time to process? Well, JavaScript isn't necessarily going to wait around before executing the goodbye function. I'm going to add a few lines of code. You don't need to copy this. These few lines of code are going to make us wait for 3 seconds. You don't need to write this down, but do pay attention. We will execute the hello function followed by the goodbye function. But we're going to pretend that our hello function takes a little bit of time to process. So now we have goodbye already executed, followed by hello, but it should be the other way around. I would like to guarantee that the goodbye function follows after the hello function. Well, I can do that by adding a callback to the goodbye function after the hello function is complete. We'll get rid of this goodbye function invocation. To use a callback, you pass a function as an argument to another function. We will pass the goodbye function as an argument to the hello function. So within the set of parentheses, type the name of the function, goodbye. Now be sure you don't add a set of parentheses after the function name. You'll call it right away. We are passing the name of the function as an argument. But we need a matching parameter. I will name this parameter callback. After everything within this function is complete, let's take our callback, then invoke it by adding a set of parentheses. Invoke meaning call. All right, now let's see what happens. We have our hello function, followed by the goodbye function, in that order. Let's create another function. What about a leave function? We'll tell somebody to leave. Console.log leave. I will pass the name of this function as an argument to the hello function. Leave is now our callback. After executing the hello function, we will execute our callback, and in this case, it's the leave function. Let's create another function for wait. function wait. Console.log wait. We'll pass the name of the function as an argument to the hello function. Wait is now our callback. We will execute the hello function, followed by the wait function. So by using callbacks, we are guaranteeing that the function passed in will execute next. You can pass callbacks as well as other arguments to a function. Let's go over a second example. I will create a function to sum two numbers together, x comma y. I'll also add a callback. Callback x comma y. We have 3 parameters total. Within the sum function, we will create a local variable of result, add x plus y, and then I will call my callback. Then I'll pass the result as an argument to the callback function. Then I will create a function to display the result to my console. Display console. There is one parameter. We have a result argument we're receiving. Then console.log my result. All right, now we will invoke the sum function, but we have 3 arguments that we need to pass in: a callback, a value for x, and a value for y. Let's invoke the display console function as a callback. Again, be sure to not add a set of parentheses after the name, because then you'll invoke it right away. X will be 1, y will be 2. And let's see the result. The result is 3. So within our sum function, calculate the result first, then after that process is finished, then display the result to the console. Let's create a separate function to display the result to our document object window, our web page basically. Let's pretend that this wasn't here. I'll create an h1 element with an ID of my h1. I will create a separate function, display page, to display on the web page. I think display DOM would be more appropriate, but I haven't explained what the document object model is yet. So let's just work with display page. We will accept a result. I will change the text content of the my h1 element. Document.get element by ID. The ID was my h1. We will change the text content to equal our result that we receive. As a callback, we will use the display page function. Display page. There, and the result is 3. After this calculation processes, execute the callback, and this time we are passing it to the display page function that we created. All right, everybody, so that's a callback. It's a function that is passed as an argument to another function. They're used to handle asynchronous operations, operations that may take a variable amount of time, such as reading a file, network requests, or interacting with databases. We're not exactly sure when these processes are going to complete. By using a callback, we can ensure that a function executes after these processes are complete, and not before, accidentally. All we're doing is saying, hey, when you're done, call this next. We'll have more practice with callbacks, especially in the upcoming topics. And well, everybody, those are callbacks in JavaScript. Hey, it's me again. Today I'm going to explain the forEach method in JavaScript. The forEach method is used to iterate, meaning loop through, the elements of an array and apply a specified function to each element. You have an array. We can use the built-in forEach method of arrays and send each element through a callback to a function. Here's an example. I'll create an array of numbers. Let numbers equals 1 through 5. Then I'm going to create a function to display each element. Function display. There will be one parameter, an element. We will individually display each element within this array. Console.log each element. I can display each element of this array by using the forEach method. We will take our array, use the built-in forEach method, then pass a callback as an argument. We will pass our display function as an argument. So this should display all of the elements in my array to the console. 1, 2, 3, 4, 5. Believe it or not, the element argument is provided for us with the forEach method. Behind the scenes, the forEach method will provide to a callback an element, index, and array argument. An element for the current element that we're on when looping through this array, an index that keeps track of the current index number, and the location of the array itself. In this case, it would be numbers. That's why when we pass the display function as a callback, we're already provided with an element argument behind the scenes. So we're using the forEach method to display all of the elements of this array. Let's use the forEach method again to double each element before displaying it. I will create a new function. Function double to double the value of each element. Element, index, and array are provided for us automatically. For each element, what are we going to do? Let's take our array at index of index. Index keeps track of the current index number. So during each iteration, it's going to increment by 1, starting with 0. We will take our element, multiply it by 2. All right, so let's take our numbers array, use the forEach method, then pass a callback to our double function. So now all of these elements should be doubled. Let's triple them now. We'll create a function for triple. Function triple. We will set the parameters to be the same, but we will multiply each element by 3. Then pass in a callback for triple. So now we have 3, 6, 9, 12, 15. They're all tripled. Let's square each element. Function square. Again, the element, index, and array arguments are provided for us. Take our array that we receive at index of the current index number, set this equal to square a number, we can use the power method of math, then raise a base to a given power. We are raising our base of element to the power of 2. If I pass our square function as a callback to forEach, we will now square each number before displaying it. 1, 4, 9, 16, 25. Then this time, let's create a cube function. Function cube. Raise our element to the power of 3. Pass our cube function as a callback to the forEach method. And now each number is cubed. 1, 8, 27, 64, 125. Let's create a more practical example. I will create an array of fruits. Let fruits equals some fruit. We have an apple, we have an orange, a banana, and a coconut. We'll create a function to display each element. Function display. It's kind of like what we did before. An element argument is going to be provided to us. During each iteration, let's console.log each element. And then we will use the built-in forEach method of our array, fruits. Fruits.forEach. We will pass our function as a callback to display each element of this array. Apple, orange, banana, coconut. Let's create a function to make all of these strings uppercase. Function uppercase. We'll need an element, index, and array. Element, index, array. During each iteration, let's take our array that we receive, add the index of our index, equals, take the element that we receive, use the toUppercase method. So we have an uppercase function that utilizes the toUppercase method. Remember that a method usually belongs to something. This method belongs to the element that we receive. Functions are standalone. Before displaying each element within my array of fruits, let's take our fruits array, use the forEach method, then apply a callback to uppercase to make all of the elements uppercase before displaying them. What I'm going to do is copy all of these elements so they will begin uppercase. I'll create a lowercase function. Function lowercase. We have our element, index, and array. With this line of code, we will use the toLowercase method. Within the forEach method, we will pass our lowercase function as a callback. to make all of the elements lowercase. Let's set the elements of our array to be all lowercase again. This will be a challenge round. We will capitalize the first letter in each element of this array. We will create a function, capitalize. The element, index, and array arguments are going to be provided to us. Take our array that we receive. At the current index, set this equal to. We're going to get the first character in each element. We will take our element, get the first character, char at index of 0, method chain to uppercase to make this letter uppercase. Then we will string concatenate our element, use the slice method. We'll create a substring, begin at index 1. This portion is going to create a substring of every character besides the first. The first character we're going to make uppercase. So now this should work. So let's take our capitalize function, pass it to the forEach method, and now the first character in each element is all uppercase. All right, everybody, so that is the forEach method. It's used to iterate over the elements of an array and apply a specified function as a callback to each element. You take your array, use the forEach method, then pass a callback as an argument. It's really useful if you need to apply a function to each element of this array. And well, everybody, that is the forEach method in JavaScript. Hey, it's me again. Today I gotta explain the map method in JavaScript. The map method accepts a callback and applies that function to each element of an array. It's very similar to the forEach method. However, it returns a new array. That's a key difference. For example, let's create an array of constants. I'm picking constants just to demonstrate that we're not changing any elements in this array. We have const numbers. I'll select the numbers 1 through 5 to keep it simple. I will create a function to square each number. Function square. We have one parameter, we have an element. All I'm gonna do is return math.pow. This will raise a base to a given power. We are raising our element to the power of 2, then returning it. We're gonna take our array of numbers, use the built-in map method, then pass in our function as a callback. The map method will return a new array. We will create a new array to store the values that are returned. So I will create const squares equals numbers.map. And then let's display our squares. I'll use console.log for now. Console.log our squares. Here are all the numbers squared. 1, 4, 9, 16, 25. Let's create a function to cube these numbers now. We'll copy and paste our square function, but change it to cube. We'll raise our element to the power of 3. Const cubes equals, take our original array numbers, dot, use the map method, pass in a callback to the function we would like to use, cube. Then we will console.log our array of cubes. And we have some new numbers. 1, 8, 27, 64, 125. The map method is very similar to forEach, but after completion, the map method returns a new array. We still have our original numbers, whereas in forEach, we'll change them. That's a key difference. Let's go over a new example. We'll create an array of students. Const students equals, for my first student, I will pick SpongeBob, then Patrick, Squidward, Sandy. That's good enough. I will create a function to make all of these strings uppercase. Function uppercase. There is a single element. Remember, the element is going to be provided for us with the map method. Element, index, and array. But we only need element in this case. I will return our element dot to uppercase method. And that's it. We'll create a new array. Students, what can we name this? Students upper, I suppose. we will take our array of students, use the map method, pass in the function we would like to apply as a callback. Then I will console.log students upper. Within my array, all of the students' names are all uppercase. Let's create a function for lowercase. Function lowercase to lowercase. I will create a new array. Const students lower equals the name of the array, students, dot map, pass in our function as a callback. Then display the array of students lower. Now all of the names are now lowercase. All right, third example. This one is more practical. We'll create an array of dates. Const dates equals certain regions will order their dates differently. For example, you might have the year followed by a month, then a day. We're going to rearrange the order of these dates using the map method. So come up with a few dates. I picked 2024, January 10th. 2025, February 20th. 2026, March 30th. Feel free to rearrange these however you want. I will create a function to format dates. We have one parameter, a single element. Within this function, I will create a temporary array named parts. We're going to split each date into parts and store it within an array within this function. Const parts equals element dot split. We are going to split each element, but where? We are going to split at each dash. For example, with my first element, we'll split this date into 2024, that will be the first element, 1 and 10. Then we'll reformat these parts. I will return a template string. So I'm going to need some placeholders. So $, curly braces. Let's take our array of parts at index of 1. That will be the month. I live in the United States. We arrange our dates with month, then day, then year. I will place my month first. /. Let's include another placeholder. Parts at index of 2. That will be the day of the month. / parts at index 0. That will be the year. We will create a new array. Const formatted dates equals, take our original array, dates, use the map method, then pass the function name as a callback. Then after, I will console.log our formatted dates. And here they are. For me, the dates are now January 10th, 2024, February 2nd, 2025, March 30th, 2026. Feel free to arrange these however you like. Alright everybody, that is the map method. It's very similar to the forEach method. The map method accepts a callback and applies that function to each element of an array. However, it returns a new array when it's finished. That's nice if you need to preserve the original array that the elements came from. And well everybody, that is the map method in JavaScript. Hey again everybody, it's me. Big surprise there. Today I'm going to explain the filter method in JavaScript. The filter method creates a new array by filtering out elements. In this example, we'll create an array of numbers. We will filter out any numbers that are odd. Let's add the numbers 1 through 7. Now we need a function. Function is even. We have one parameter, we have an element that's going to be provided to us by the filter method. We are going to return, then write a condition. We will take our element, modulus 2. The modulus operator gives you the remainder of any division. You can use modulus 2 to check to see if a number is even. If this condition is 0, strictly equal to 0, then we will return true. We will be returning a Boolean, true or false. The filter method will take any values that return true and stick them within a new array, which will effectively filter out any elements we don't need that don't return true. Let's see if this works. I will create a new array, even nums equals, take our original array, use the filter method, pass in a callback, is even. We will display console.log our new array, even numbers. And there we are, 2, 4, 6. Let's do this with odd numbers. Function is odd. Take our element, modulus 2. Is this strictly not equal to 0? That means the number is odd. Let's create a new array. Let odd nums equals our original array, numbers, dot, use the filter method, pass in a callback, is odd. Let's check out our new array, odd nums. There we are. We have the numbers 1, 3, 5, 7. Any numbers that are odd. Let's go over another example. I will create an array of ages. I'll use const this time instead of let. Const ages. Pretend we're teaching a college class. We might have some students still in high school. Let's say a student is 16, another is 17, 2 are 18, 19, 20, and then we have somebody that's just a little bit older. They're 60. We'll use the filter method to filter out anybody that is under 18. We will find all of the adults. We will need a function. Function is adult. We have one element as a parameter that's going to be provided to us. We will return a condition. Return, check our element. Is it greater than or equal to 18? So that's our function. Let's create a new array of adults equals, take our original array, dot, use the filter method, pass in a callback, is adult. Then display our new array, console.log adults. We have 5 elements. The age of these students is 18, 18, 19, 20, and 60. Let's do this with is children to find anybody that's under 18. Is child function, return element less than 18. We'll create a new array, const children equals, take our original array, use the filter method, pass in a callback, is child, then display the new array. We have 2 students that are children. One is 16, the other is 17. Last example, we'll create an array of words. Const words. Add some words. I think I'll add some fruit. I'll add an apple, orange, banana, kiwi, pomegranate, and a coconut. I will filter out any words where the length of that word is above 6. So we will create a function. Function get short words. We have an element as a parameter. We will return a condition. We will check if our element access the length property of that element. They're strings, so they all have a length property. How many characters are they long? That's the length. Check to see if the length of this element is less than or equal to 6. If it is, return true. If not, return false. We will create a new array. Let's call this array short words equals, take our array, use the built-in filter method, pass in a callback, get short words. Then we will console.log the new array. Short words. In our array, there are 4 elements with the length of the characters of each string is 6 or under. Apple, orange, banana, kiwi. Then to finish this off, let's get any long words. We'll create a new function. Get long words. Check the length of the element to see if it's above 6. Then we will create a new array. Const long words equals, take our original array, use the filter method, pass in a callback, get long words. Then we will display our new array, long words. Within our original array, there's 2 words that are considered long, pomegranate and coconut. These words each have more than 6 characters. Coconut is 7, pomegranate is 11. All right, everybody, that is the filter method. It creates a new array by filtering out elements. Your callback is likely going to check in condition. Does each element pass this condition? And well, everybody, that is the filter method in JavaScript. What's going on, everybody? So in today's video, I got to explain the reduce method in JavaScript. The reduce method reduces the elements of an array to a single value. In this example, we'll create an array of prices, as if it was a shopping cart. We'll sum all of the prices within our shopping cart and return a total. We'll need an array to work with. Const prices equals an array. Think of some prices, type in anything, as long as it's a number. I'll keep this simple and use whole numbers. I'll add something that is $5, another that is 30, 10, 25, 15, and 20. We will create a variable for a total. Const total equals, take our array of prices. We will use the built-in reduce method of arrays, but we do need to pass in a callback to a function. We need to create a function that will sum all of these values. Let's create a function to sum. Our sum function will have 2 parameters. The first will be an accumulator. The second will be the next element. All we're going to do is return our accumulator plus our element. I'll explain how this works momentarily. I just want to be sure that everything runs fine first. Within the reduce method, we'll pass in a callback to the sum function. That will return a single value, a total in this case. Let's see what our total is. Console.log, I'll use a template string, pick a unit of currency, I'll pick American dollars. Add a placeholder, let's display our total. So my total is $105. If you would like to add cents to the end of that, you can follow this with the toFixed method, then add 2 decimal places. for cents. Alright, so how does this work exactly? We have 2 parameters, accumulator and element. It might be easier if I were to rename these parameters. You can rename parameters. Let's say accumulator is the previous element. Element is the next element. We're returning the previous element plus the next element. During the first iteration, we'll have 0 and 5. Well, 0 plus 5 would give us 5. 5 is returned to the accumulator. Whatever value is returned becomes the accumulator during the next iteration. So now, our accumulator is 5. The next element is 30. Then we are going to return the accumulator plus 30, which is 35. We'll return this to the accumulator during the next iteration. The accumulator is now 35. The next element is 10. 35 plus 10 would give us 45. Return that to the accumulator and add the next element, 25. So you just follow that pattern. Alright, let's go over another example. We'll create an array of grades. Const grades equals, these will be some number grades, 75, 50, 90, 80, 65, and 95. We'll find the maximum value from this array. We'll create a constant to hold to the maximum value. What is the maximum score? Const maximum equals, take our grades array, use the built-in reduce method, then we need to pass in a callback to the reduce method. We need a function to get max. There's 2 parameters, an accumulator and the next element. Like I said, feel free to rename them. We will return the max method of math. Math.max, pass in these 2 parameters, accumulator and the next element. Within the reduce method, we'll pass in a callback to get max. The value returned will be the maximum grade from this array. So let's console.log whatever the maximum is. The maximum score from this array is 95. Let's do this with the minimum. Let's copy this function, change any instance of max to min. Get min math.min. Let's create a new constant, const minimum equals our array of grades. Use the reduce method to return a single value, then pass in a callback to get min. Let's console.log the minimum. The minimum score from this array is 50. Alright everybody, that is the reduce method. It's a built-in method of arrays to reduce the elements of an array to a single value. You can use it to sum the elements of an array. Another possibility is to find the minimum or maximum value from an array. And well everybody, that is the reduce method in JavaScript. Hey everyone, so today I'm going to explain function expressions in JavaScript. A function expression is a way to define functions as a value or a variable, not to be confused with function declarations, where you define a block of reusable code that performs a specific task. We're already familiar with function declarations, such as this. Function, then you create a function name, such as hello in this example. Let's console.log the word hello. With the function expression, we can assign a function to a variable or pass it as a value to another function. So this time, we're going to write a function expression. I will create a constant named hello equals a function, parentheses, curly braces. We'll do the same thing. We will console.log hello. And if I were to run this, the identifier hello has already been declared, so for now I'm just going to remove this function declaration. All we're doing is assigning a function to a variable. To use the function that's stored within, we have to take our variable name and add a set of parentheses to invoke it, kind of like it's a pair of telephones talking to each other. Hello. Using JavaScript, we also have the capability of passing a function as a value. I will introduce the setTimeout function. There's going to be two parameters, a callback to a function, and an amount of time we're going to wait, then execute this function. This will be in milliseconds. 3000 milliseconds translates to 3 seconds. Let me put this function back. After 3000 milliseconds, I will execute the hello function. 1, 2, 3, hello. Instead of using a function declaration, we are going to pass a function expression as an argument to the setTimeout function. Instead of a callback, we will create a function. We will pass an entire function as an argument. What are we going to do? We will, after 3 seconds, console.log the word hello. And let's see if this works, just to prove that I'm not a liar. 1, 2, 3, hello. In JavaScript, it is legal to pass an entire function as an argument or treat it as a value. We'll use previous examples of the map, filter, and reduce methods of arrays. I will create an array, const numbers equals the numbers 1 through 6. 1, 2, 3, 4, 5, 6. I would like to square each of these numbers. What we've done in a previous lesson is declare a function, square. We had one parameter in that example. We had an element. What we did is we returned math.pow to raise a base to a given power, or raising our element to the power of 2. The map method will return a new array. Const squares equals numbers.map. We're passing in a callback to square. Then console.log squares. This works. We are using a function declaration. But this time, we will now use a function expression. We will treat this function as a value. Let's cut this function, replace the callback, then paste it within the map method. Then we just need to remove the name. We don't need a name. And this is still going to work. Yeah, it still does. We don't necessarily need to think of a function name. One of the benefits of doing this is that we're not polluting the global namespace with function names. We're only going to be using this function once. There's no need to declare a function. Let's create a function expression to cube these numbers now. As a beginner, it might be helpful to write out your functions as a declaration first, then transform it into a function expression. Function cube. We have our element as a parameter. I'm going to copy this. Return math.pow element to the power of 3. We will create a new array, const cubes equals numbers dot map. We don't need to pass in a callback. We will cut this entire function, paste it within the map method. Then we don't need the name. Then console.log cubes. There are all the original numbers cubed. All right, I think we're starting to get the hang of this. Let's quickly use the filter method to filter out any even or odd numbers. I will create const even nums equals take our array numbers. We will use the filter method. Then we will pass a function expression as an argument. There's one parameter, an element. We are going to return element modulus 2 to see if it's divisible by 0. Is the result strictly equal to 0? Let's see if this works. Console.log even nums. There they are. We have 2, 4, 6. Let's do this with odd numbers. Odd nums. Use the filter method again. All we're going to change is strictly not equal to 0. Return any odd numbers. 1, 3, 5. Then lastly, reduce. We will sum all of the elements of this array. Const total equals our numbers dot reduce. Pass in a function expression. We have two parameters, an accumulator and an element. We will return accumulator plus our element. Return the total, which is 21. We already do have some practice with map, filter, and reduce. Instead of using function declarations, then passing a callback, we can pass an entire function expression as an argument to these methods. In the next topic, I'll discuss arrow functions, which shortens the syntax even further. You'll like arrow functions. Alright everybody, so those are function expressions. They're a way to define functions as a value or a variable. We've both defined a function expression as a variable. We stored that within this hello variable. We've also passed entire functions as an argument, which you can do with JavaScript. There's a few benefits of function expressions, one of which is you don't need to keep on thinking of function names. You can perform a function once, then just forget about it. They're also used in callbacks and asynchronous operations, higher order functions, closures, and event listeners. These are topics we still need to discuss, but we will be using function expressions a lot. Don't worry, we will have more practice. And well, everybody, those are function expressions in JavaScript. Hey, hello there. So today I'm going to explain arrow functions in JavaScript. An arrow function is a concise way to write a function expression. It's good for simple functions that you only use once. Here's the formula. You have your parameters, arrow, then some code you would like to perform. Here's an example. Suppose I have a function declaration. I have the hello function. All we're going to do is console.log the word hello. To use this function, I need to call it by its name, add a set of parentheses. This will display the word hello. A concise way to write the same function is to use an arrow function. We'll begin with a function expression, then convert it to an arrow function, just so we understand the differences. This time I will create a constant hello. Hello is going to be a constant that stores our function expression. If I were using a function expression, we would say function, parentheses, curly braces, then the code we want to perform. Console.log the word hello. This would do the same thing. Hello. A more concise way to write this function expression would be to use an arrow function. Following this formula, we list our parameters. We don't have any. We need a set of parentheses, arrow, then some code we would like to perform. I'm going to console.log the word hello. And that works. we're sticking an arrow function within a variable or named constant. To invoke the arrow function within, we just follow that constant or variable with a set of parentheses like we're calling it, as if it's a pair of telephones talking to each other. You can send some arguments to an arrow function. We'll need to set up the parameters. I will have a name parameter. Within our code, let's console.log. I'll use a template string, hello, add a placeholder, add my name parameter. Now I need to pass in an argument because right now it's hello, undefined. Pass in your first name as an argument. Hello, bro. Within your code, if you need to include more than one statement, you'll need to enclose all of that code within a set of curly braces. Let's add a new line. Console.log, you are old. Hello, bro, you are old. Okay, let's set up another parameter. This time, we will accept an age argument. Let's transform our second console.log to be you are, add a placeholder, our parameter age, years old. Now we'll pass in a second argument for age. Hello, bro, you are 25 years old. So that's the basics of an arrow function. You have your parameters, arrow, then some code you would like to perform. There's no need to create a function declaration. Let's go over another example. We have the set timeout function. This function accepts a callback. Then a given amount of time, we are then going to execute this code, this callback. After 3 seconds, 3000 milliseconds, I will execute whatever this callback is. Let's create a function to say hello again. Function, hello. We will console.log the word hello. I will pass in a callback. After 3 seconds, we say hello. In place of a callback, I could use a function expression. Let's cut our function. Remove this argument, then paste our function expression. Remember, we don't need the name for a function expression. This works as well. Hello. Or otherwise, we can use a more concise arrow function. We will pass that as an argument. We have our parameters, we don't have any, arrow, then some code. Console.log the word hello. After 3 seconds, we display the word hello. Now we'll use arrow functions with map, filter, and reduce. We have an array of numbers. Const numbers equals the numbers 1 through 6. Let's start with using the map filter to square each of these numbers. But we will use arrow functions. Const squares equals our original array, numbers, dot map. Normally, we would pass in a callback as an argument, but we're not going to do that. We'll use an arrow function. We have one parameter, an element, arrow, take each element, use math.pow to raise our element to a given power. Then let's console.log our squares. Console.log squares. There they are. Here are all the original numbers squared. 1, 4, 9, 16, 25, 36. Let's cube each number. Const cubes raise our element to the power of 3. Console.log our cubes. There are all the numbers cubed. We'll use the filter method to filter out any numbers that are odd. Const even nums equals our array numbers. We will use the filter method. We can pass in a callback, but we don't need to. We will pass in an arrow function. We have our element as a parameter, arrow. We don't necessarily need a return statement if we have only one line of code. Take our element, modulus 2, is it divisible by 2? And does this strictly equal 0? If it does, it's an even number. Let's console.log our even numbers. 2, 4, 6. Let's do this with odd numbers. Odd nums. Take our element, modulus 2. Is it strictly not equal to 0? Display our odd nums. 1, 3, 5. And lastly, let's do reduce. We will get a total by summing all of the elements of this array. Const total equals our original array dot reduce, pass in a callback or an arrow function. This time we have two arguments, an accumulator and an element. We have an arrow, return our accumulator plus our element, then display the total. Our total is 21. All right, everybody, so those are arrow functions. They're a concise way to write a function expression. They're good for simple functions that you only use once. You list your parameters within a set of parentheses, an arrow, then some code you would like to perform. In this example, we've written a more concise way to use the map, filter, and reduce methods. Normally, we can pass in a callback as an argument, a function expression, or an arrow function. And well, everybody, those are arrow functions in JavaScript. Hey, what's going on, everybody? In today's video, I'm going to discuss objects in JavaScript. An object is a collection of related properties and/or methods. Properties are things that an object has, such as a first name or an age. A method is a function that belongs to an object. For example, I have a person object. Our person can say hello, and they can say bye. Methods are just functions that belong to an object. What can this object do? Objects can represent real-world objects, such as people, products, or places. In this example, we'll be creating some people objects. People from the show SpongeBob. We'll start from scratch, though. We'll create a person object. I'll use a constant, although it's not necessary. Const person equals, then add a set of curly braces. We'll start with any properties. You can add as many properties as you would like. They're in key value pairs. This person will have a first name key, colon, then some value. This person's first name will be SpongeBob. Separate each key value pair with a comma. Let's include a last name property. Last name, colon, space, will be SquarePants. Add a comma when you're done with this key value pair. We'll add an age property of 30. Age has a different data type. It's a number. The first two in my example were both strings, SpongeBob and SquarePants. Let's add a Boolean. Is employed, colon, space, I will set that to be true. He has a job at the Krusty Krab. Okay, that's good enough for now. I would like to access these properties. Let's console.log. If I need one of these properties, take the object you're referring to, in this case person, dot the name of the property. Let's do first name. Person.firstName property, that would give me SpongeBob. Let's do this with last name. Take the object name, dot the name of the property. Person.lastName is SquarePants. Let's do this with age. Person.age is 30. Person.isEmployed is set to true. All right, let's create another object. We'll create an object for Patrick. Const person. Now, objects can't have the same name. Objects need different names. For example, I can't have two person objects. They can't have the same name. Syntax error. Identifier person has already been declared. I will rename our first person as person1. Our second person will be person2. Then any place in which I'm referencing person will now need to be person1. Let's reuse these same key value pairs. Person2's first name will be Patrick. His last name will be Star. Patrick will be, I don't know how old he is according to the TV series, let's say he's 42. Is Patrick employed? No. He just watches TV all day. Now I would like to access person2's properties. Okay, we'll console.log, person2's first name, person2's last name, person2's age, person2 is employed. Okay, for person2, we have Patrick, star 42 false. So those are properties of an object. They're key value pairs. Add as many as you would like. In this example, these properties mimic real-world attributes that a person might have, like a first name, last name, age, whatever you can think of. But not only that, objects can have dedicated functions that we refer to as methods. What sorts of actions can these objects perform? For example, a person could eat, they could drink, they could sleep. What sorts of things do people do? So just to keep this simple, I am going to create a function to say hello. We'll start with person 1. Say hello, colon space. This will be a function expression. What are we going to do? When we invoke this function, let's console.log. What would SpongeBob say if he's greeting somebody? Hi, I'm SpongeBob. Be sure you're not including a semicolon at the end. That should work. Let's test it. I'm going to have person 1 invoke their say hello method. Hi, I'm SpongeBob. Let's add a say hello method to Patrick, person 2. We'll change the output of say hello. What would Patrick say? Hey, I'm Patrick, ... Now we'll have person 2 use their say hello method. Hey, I'm Patrick. You can add as many methods as you would like. So with these functions, we're using a function expression. If you prefer, you could even use an arrow function. List your arguments, arrow, then the code you would like to perform. This would work too. Let's add an eat method. Eat function. We'll use a function expression for SpongeBob. Let's console.log. What is SpongeBob eating? I am eating a Krabby Patty. We'll include an eat function for Patrick as well. What's Patrick gonna eat? Patrick is eating... I'm eating roast beef, chicken, and pizza. And if you would like, you can use an arrow function for this example. List your parameters, arrow, then the code you would like to perform. It's not necessary, but I do like arrow functions. Person 1, SpongeBob, will use his eat method. Same thing goes with Patrick, person 2. So SpongeBob is eating a Krabby Patty. Patrick is eating roast beef, chicken, and pizza. All right, everybody, so JavaScript objects are a collection of related properties and/or methods. Properties are what an object has. Methods are functions that an object can perform. They can represent real-world objects such as people, products, or places. Properties are key value pairs. Methods are functions that belong to an object. And well, everybody, that is an introduction to object-oriented programming in JavaScript. Hey, so we gotta talk about this. This is a keyword. It's a reference to the object where this is used. The object depends on the immediate context. If we had a person object, and we're accessing their name property, we could replace person with this. As long as we're within the context of that person object, we'll create an object, const person1. Let's add a property for name. The name will be SpongeBob. And a favorite food property, fav food. SpongeBob likes hamburgers, more specifically Krabby Patties. I will give SpongeBob a say hello method. This will be a function. All we're going to do is console.log. I'll use a template string. Hi, I am. I'll use a placeholder. Let's attempt to use person 1's name. Let's see what happens. Let's take our object of person 1. I will invoke their say hello method. Let's see what happens. Hello, I am, and there's nothing here for the name. Inside of this object of person 1, if I would like to access one of these properties, I'm going to precede the property with this. This dot the name of the property. And that should work. Hi, I'm SpongeBob. we're using this within the context of person1. It would be like us saying person1.name. There would be no difference. This is a reference to the object we're within. If I said this.favoritefood, well, favfood for short, hi, I am hamburgers, it would be like us saying person1.favefood. Let's add another method. I will add an eat method. Let's console.log. I'll use another template string. Add a placeholder. This.name is eating. Add another placeholder. This.favefood. Let's have person1 use their eat method. SpongeBob is eating hamburgers. The cool thing about the this keyword is that if we create a new object with these same methods, we'll use the second object's properties. Let's copy person1, paste, change person1 to person2. The name for person2 will be Patrick. Favorite food will be pizza. Let's have person2 use their eat method. SpongeBob is eating hamburgers. Patrick is eating pizza. Since we're in the context of person2 now, imagine we're replacing this with person2. Person2.name, person2.favefood. If you were to use this outside of any objects, I'm going to console.log this. What we're returned with is a window object. Basically, we're returning the window to see our website. Technically, we're inside of an object already, our window object. And we have all of these properties. But since we're using this keyword inside the context of person1 and person2, we'll instead make a reference to those objects. Hey, one thing I forgot to mention, this keyword doesn't work with arrow functions. For example, with person2, let's convert this to an arrow function. Blank is eating undefined. When you use this within an arrow function, it's making a reference to that window object still. Our window object does have a name, that's why it's appearing empty, but favefood is undefined because our window object doesn't have a favorite food property. Alright everybody, so that is the this keyword. We will be using this keyword a lot. All it is a reference to the object where this is used. And that is the this keyword in JavaScript. What's up, people? So today I gotta explain constructors in JavaScript. A constructor is a special method for defining the properties and methods of objects. In prior videos, we've constructed objects like this. We would declare an object, assign it some properties, and some methods. You know, this works, but what if we have to create a lot of objects? Here I'm manually creating 3 different car objects. That can be a lot of work. What we could do instead is use a constructor to construct these objects automatically. All we have to do to construct these objects is pass in some unique data to the constructor to construct these objects. Here's an example. We are going to create a function, car. Do pay attention to the capitalization. We'll need to set up some parameters. What sorts of properties will we accept when we construct a car object? How about a make, model, year, and color? These are arguments we'll receive when we construct a car object. To assign these properties, we're going to use this keyword .make equals the make that we receive. Let's do this with model. This .model equals the model we receive. This .year equals year. This .color equals color. That's good enough for now. Our car constructor is a reusable method where we can define the properties and methods of objects we create. To use this constructor, I will create an instance of an object. I will use const, car1 will be our first object. Equals, we'll need to use the new keyword, type the name of the constructor, car. Car is a special method. We'll need to pass in some arguments. We'll need a make, model, year, and color in that order. My first car, feel free to send some different data to the constructor, but for me, my first car will be a Ford. Make sure each value is comma separated. Mustang, the year will be 2024, and the color will be red. We should now have a car object with the name of car1, and I'm going to console.log car1's properties. car1.make Ford. Let's do this with the other properties. We have model, Mustang, year, 2024, and color, red. Now, this method is reusable. We can reuse it to create other car objects. Let's create const car2 equals new car. We'll pass in different data this time. The make will be Chevrolet. I will pick a Camaro, the year 2025, and the color will be blue. Now I can display car2's properties. Let's select car2.make, car2.model, car2.year, car2.color. We have a Chevy Camaro, year 2025. The color is blue. Let's create one more car. Same process as before. Const car3 equals new car. I'll go with a Dodge Charger, the year 2026, and the color will be silver. Let's access car3's properties. car3.make, car3.model, car3.year, car3.color. Dodge Charger 2026, the color is silver. Another thing with these parameters too, you can name these parameters anything. When we assign these properties, it can be kind of confusing. Like this.make equals make. Really, we write our constructors this way just for readability. Technically, this would work if we renamed our parameters. For example, make will be parameter A, model will be B, year is C, color is D. Then be sure to change these when we assign them. A, B, C, D. This would still work. However, this constructor isn't as readable. Like, what the heck is A, B, C, and D? It would be good practice to clearly define our parameters for readability purposes. All right, now let's add a method. We'll take this dot drive equals a function. We'll console.log. I'll use a template string. You drive the, I'll add a placeholder, this dot model. With cars 1 through 3, let's use the drive method. car1.drive. You drive the Mustang. car2.drive. You drive the Camaro. And car3.drive. You drive the Charger. All right, everybody, so that's a constructor. It's a special method for defining the properties and methods of objects. It helps with code reusability. We can reuse it to create many objects, instead of having to type them all out manually. And well, everybody, those are constructors in JavaScript. All right, let's do this thing. So I gotta talk about classes in JavaScript. Classes are an ES6 feature that provides a more structured and cleaner way to work with objects, compared to the traditional constructor functions that we're normally used to. Classes are going to be really helpful when we reach future topics such as the static keyword, encapsulation, and inheritance. In this example, I have a constructor for a product. Our product needs a name and a price. For example, we have a shirt and the price is $19.99. Instead of using a constructor method, we're instead going to use a class. Our class will include a constructor. So let's start from the beginning. To create a class, you type class, then the name of the object. So our class is going to serve as a blueprint. Our objects will be products. Then add a set of curly braces. To use a constructor, we can use the constructor keyword within our class. List any parameters. We will have a name and a price for each product. We will assign the properties of this.name equals the name parameter that we receive. This.price equals price. I will also create a function. Our function will be display product. Now, inside of a class, you don't need to use the function keyword. When we would like to display this product, we will console.log product colon space, I'll include a placeholder, this dot name. Let's also output the price. Price, pick a unit of currency, I'll use American dollars, this dot price. Let's create some product objects. Const product1 equals, to create a new object, we have to use that new keyword, the name of the class, product. The constructor is going to be called automatically, but we do need to pass in a name and a price as arguments. We will pass in a shirt. The price will be $19.99. Just to be sure that everything works, let's invoke the displayProduct method. Product1 dot displayProduct method. Here are the details of our product object. Product shirt, price $19.99. Let's create a few more. So this class is reusable. Product2 will be pants. I'll pick $22.50 for the price. Let's display product2, and we will use the displayProduct method of our class. Product pants, the price is $22.50. Looks like I only have one decimal point. I'm going to make one change. After the price, I will use the toFixed method and set this to be 2 decimals. There, $22.50. All right, product 3. Const product 3 equals new product. Our third product is going to be underwear. This underwear is really expensive. It's $100. It's really good underwear, guys. Product 3 dot display product underwear, price $100. Here's a challenge round. I'm going to add another method. This method will have one parameter, sales tax. We'll create a method to calculate a total including tax. So let's create a new method. Inside of a class, we don't need the function keyword. Calculate total. There will be one parameter, sales tax. All we're going to do is return this dot price plus, to calculate the sales tax, we'll take this dot price times the sales tax, assuming it's a percentage. Okay, let's display product1 dot display product. I'm also going to create a constant for the sales tax. That's not going to change. Const sales tax. Let's say the sales tax is 5%, 0.05. I will create a variable const total equals, let's take product1, use the calculate total method, but we have to pass in sales tax. We can either pass in this number or this variable. Once we have our total, let's display it. Console.log, I'll use a template string, total price, in parentheses, with tax. I'll add a placeholder, display the total, pick a unit of currency, I'll use American dollars, then I'll add toFixed to set it to 2 decimal places. All right, our product is a shirt, price is $19.99, total price with tax is $20.99. Let's do this with product 2. Product2 dot display product, product2 dot calculate total. Pants $22.50, total price $23.63. Let's check out our really expensive underwear. Product3 dot display product, product3 dot calculate total. Our underwear is $100, including sales tax, it's $105. All right, everybody, so those are classes. They're an ES6 feature that provide a more structured and cleaner way to work with objects, compared to the traditional constructor functions that we learned about in the last video. Classes are going to be really helpful with a few upcoming topics. And well, everybody, those are classes in JavaScript. Hey people, let's do this thing. So the static keyword. Static is a keyword that defines properties or methods that belong to a class itself rather than the objects created from that class. In summary, a class owns anything static, not the objects. So what we're going to do is create a class for math utilities. Class math util for short. we'll create our own version of pi. We'll use the static keyword. The name will be pi. Pi will equal 3.14159, just the first few digits. I'm going to zoom in a little. If I would like the static property, I have to access it by its class. So let's console.log the name of the class, mathUtil dot the name of the property, pi. Our static property is 3.14159. I don't need to create an object in order to use this property. I don't have to type const mathUtil1 equals new mathUtil. I would have to type mathUtil1, that's the name of this object, in order to access pi. All I have to do is type the name of the class. And that's pretty convenient. Anything declared as static belongs to the class itself, and not any object created from that class. So now we're going to create a static method. We'll use the static keyword. We'll get a diameter once we pass in a radius as an argument. Get diameter. We have one parameter, a radius. All we're going to do is return radius times 2. Okay, let's console.log. Again, we have to type the name of the class, mathUtil, dot the name of the method, get diameter. We have to pass in a radius, though. Let's pass in 10. Our diameter is 20. Let's create a new static method for get circumference. Get circumference. The formula is going to be, we will be returning 2 times this, meaning mathUtil, dot pi, times the radius we receive. Let's console.log. Let me make the C capital. The name of the class, mathUtil, dot get circumference. Pass in a radius. The circumference is 62.83. Let's create one more for get area. Static get area. We need a radius. We will return this dot pi times radius. So that's radius squared. Console.log, mathUtil, the name of the class, get area. Pass in 10, and the area is 314.15. In the next example, we'll have a mix of regular properties and methods and static properties and methods. This will be example 2. We'll create a class of users. Class user. We'll create a static variable to keep track of the amount of users we create. User count. I will set that equal to 0. I'll include a constructor. Let me just space this out a little. Our constructor is going to be automatically called when we instantiate a new object. We need one argument, though, when we create a new user. We need a username. Once we have our username, we will assign this dot username equals username. Not only that, but when we create a new user, I'm going to increase our user count by 1, just so we can keep track of how many users we create. So inside the constructor, you can write additional code. It's not only for assigning properties. Let's take user.userCount ++ to increment it. Let's create some user objects. Const user1 equals new user. Pass in a username. I'll pass in SpongeBob. Then let's console.log user1's username, which is SpongeBob. Let's attempt to access user1's user count. With user1's user count, we get undefined. That's because our user doesn't have user count as a property. It's static. That means it belongs to the class, not any objects created from the class. To access user count, we have to type the name of the class. User in this case. We have one user. Let's see what happens when I create a new user object. User2 will equal Patrick. Our user count is now 2. Let's display user2's name. Yep, we have SpongeBob and Patrick. The total user count is 2. Let's create a third user. User3 will be Sandy. Console.log user3.username. Our user count is now 3. We have a static property that's keeping track of the amount of users we create. Let's create a method. The first one will not be static. Say hello. All we're going to do is console.log. I'll use a template string. Hello. My username is, I'll add a placeholder, this.username. Let's have user1 use their say hello method. Same thing with user2 and user3. Hello, my username is SpongeBob, Patrick, and Sandy. Now we'll create a static method. We'll get the user count. Get user count console.log. I'll use a template string. There are, I'll add a placeholder, user.userCount, users online. Now, in order to access this method, I have to type the name of the class. User.getUserCount. Oops, and I can't console.log that. User.getUserCount. There are 3 users online. Alright everybody, so that is the static keyword. It defines properties and methods that belong to a class itself rather than any objects created from that class. In summary, the class owns anything static, not the objects. And well, that is the static keyword in JavaScript. Hey, what's up everybody? So in today's video, I gotta explain inheritance. Inheritance allows a new class to inherit properties and methods from an existing class. These two classes have a parent-child relationship. A child will inherit properties and methods from a parent. It's kind of like a family tree. A child will inherit genes from a parent. Inheritance helps with code reusability because we don't need to keep on repeating the same properties and methods if all the children share them. Here's an example. We'll create an animal class. Class animal. We'll have a property of alive. If you're an animal, you start off being alive. All animals should be able to eat and sleep. We'll create methods for those. We'll have an eat method. All we're going to do is console.log. I'll use a template string. This. Now I'll add a placeholder. This.name is eating. And a sleep method. Sleep. This.name is sleeping. Animal will be the parent class. We'll create children classes that inherit these properties and methods. Let's create a few children classes. Class rabbit. Our rabbit class will inherit all the properties and methods of the animal class. To declare a parent-child relationship, the child will extends the parent, animal. For the rabbit, I'm going to give this class a name. Name equals rabbit. This will be a property. If you're familiar with the static keyword, you can make the static. Now we'll create a fish class that also extends animal. Class fish extends animal. Fish will have one property. Name equals fish. And a hawk class. Class hawk extends animal. We'll have one name property. Hawk. All right, let's see if this works. If we create a rabbit, fish, and hawk object, they should have access to these properties and methods. Let's create const rabbit equals new rabbit. Const fish equals new fish. Const hawk equals new hawk. All right, let's see if our rabbit has an alive property. Console.log, take the name of the object, rabbit, dot, access a property or method. Alive, that's our property. The rabbit is alive. But what if the hawk swoops in and kills the rabbit? Let's change the alive property of the rabbit. Rabbit.alive equals false. The rabbit is no longer alive. Now let's see if our rabbit has access to a eat and sleep method. Rabbit.eat. This rabbit is eating. And sleep. Rabbit.sleep. The rabbit is sleeping. Let's test this with fish. Fish.alive, fish.eat method, fish.sleep method. The fish is alive, the fish is eating, the fish is sleeping. And hawk. Hawk.alive, hawk.eat method, hawk.sleep method. The hawk is alive, the hawk is eating, the hawk is sleeping. Our children classes of rabbit, fish, and hawk all inherited the properties and methods of the parent animal class. This helps with code reusability, because I don't need to declare all of these properties and methods within each of the children classes like this. We're saving a lot of lines of code. It's not that apparent with just a few child classes, but imagine if you had hundreds of different child classes. Well, by using inheritance, you would be saving a lot of time. But not only that, the children can have their own unique properties and methods too. For example, rabbits will be able to run, but fish and hawks can't run. That's a method that only belongs to rabbits. Within our rabbit class, let's create a new method, a run method. We'll console.log, I'll use a template string, this, add a placeholder, this.name is running. Within our fish class, let's create a swim method. Swim. This.name is swimming. And hawks will be able to fly. We'll create a fly method. This.name is flying. Let's minimize these classes. Let's take our rabbit object, display the alive property, the eat method, the sleep method, and the run method. Rabbit.run method. The rabbit is eating, the rabbit is sleeping, the rabbit is running. Now let's do this with fish. Fish.alive, fish.eat method, fish.sleep method. Now, does the fish have a run method? It does not. Fish.run is not a function. Run is a method that belongs to the rabbit class. Fish can't run because, well, they don't have legs. We did not give our fish class a run method. They can swim though, but they can't run. Fish.swim method. The fish is swimming. Let's do this with hawk. Our hawk cannot swim, but it can fly. We'll use the fly method. The hawk is eating, the hawk is sleeping, the hawk is flying. And of course, our rabbit can't fly or swim. Does our rabbit have a fly method? It does not. Rabbit.fly is not a function. Alright everybody, so that's inheritance. It allows a new class to inherit properties and methods from an existing class. A child inherits properties and methods from a parent. It helps with code reusability. I don't need to declare all of these properties and methods for each of these classes. I can simply reuse it. That helps us follow the dry principle. Don't repeat yourself. And well everybody, that is an introduction to inheritance in JavaScript. Yo, what's going on everybody? So in today's video, I'm going to explain the super keyword in JavaScript. Super is a keyword that's used in classes to call the constructor or access the properties and methods of a parent. The parent is also known as the superclass. It's very similar to the this keyword. This refers to this object. Super refers to the parent of that object. Here's an example. We'll use inheritance to create a parent class of animal. Class animal. Our animal class will have 3 children, also known as subclasses. Class rabbit extends animal. Class fish extends animal. Class hawk extends animal. We'll add an empty constructor for now for the animal class. Then we need a constructor for the rabbit class. So rabbits, they'll have a name property, age, and a run speed. We'll assign these properties within the constructor. This.name equals the name that we receive. This.age equals age. This.runSpeed equals run speed. Let's copy this constructor. Now with fish don't have a run speed, but they'll have a swim speed. Let's replace run speed with swim speed. Copy the constructor again, paste it. Hawks in this example won't have a swim speed. They'll have a fly speed though. Replace swim speed with fly speed. Now let's attempt to create some of these objects. Const rabbit equals new rabbit. We need a name for this rabbit. You could just say rabbit, or if you want to be creative, you could say something like Bugs Bunny. But let's just stick with rabbit to keep it simple. Our rabbit will be 1 year old and has a run speed of 25 miles per hour. If you use kilometers, feel free to use kilometers. Let's do this with fish. Const fish equals new fish. The name of our fish will be fish. Our fish is 2 years old and has a swim speed of 12 miles per hour. Then with hawk, const hawk equals new hawk. Our hawk will have a name of hawk. Our hawk will be 3 years old and has a fly speed of 50 miles per hour. So when I run this program, we have an uncaught reference error. Must call superconstructor in derived class before accessing the this keyword. So what JavaScript is telling us is that before we can use the this keyword, we have to call the constructor of the parent, the superclass. Within each of these respective constructors, we will invoke the constructor of the parent, the superclass with the super keyword. So let's do that for each of these constructors. Now our program actually runs now. So one of the benefits of using constructors is that if there's any properties that the children all share in common, we can send them to the constructor of the parent. As you can see, we're repeating ourselves a lot. Each of these children classes has a name and age property that we're assigning to each. We would like to follow the dry principle. Don't repeat yourself. So why don't we write this code once and reuse it? So within the constructor of the parent, we'll accept a name and age property. We'll assign this.name equals name and this.age equals age. Now we can remove that within each of the child classes so we don't repeat ourselves. There's less code to write now, but we do need to pass in these arguments to the parent constructor, name and age for each. And that's all there is to it. In this example, when we construct an object, either a rabbit, a fish, or a hawk, we'll accept 3 arguments, a name, age, and either a run speed, a swim speed, or a fly speed depending on the animal that we're creating. Any properties they share in common, we can send to the parent constructor. It helps with code reusability, and there's a lot less to write. It's not that evident with 3 children classes, but imagine if you had hundreds of different classes. Like what if this was Pokemon? There's like, what, 1,000 Pokemon now? We would have to copy and paste those properties like 1,000 times for each, if we're constructing individual Pokemon. But since all of them share those same properties, we can write it in one place, and make any changes only in one place. So let's test this to see if it works. Let's console.log our rabbit's name, which is named rabbit. Let's console.log the rabbit's age. The rabbit is 1 year old. And let's see if the rabbit has a run speed. 25, as in 25 miles per hour. Let's do this with fish, fish.name, fish.age. Let's see if the fish has a run speed. Name is fish, age 2. Run speed is undefined because fish can't run because they don't have legs, but they do have a swim speed though. Swim speed, 12 miles per hour. Then hawk. Hawk.name, hawk.age, hawk.fly speed. Name is hawk, age 3. The hawk has a fly speed of 50 miles per hour. So that's how you can use the super keyword in a class to call the constructor of the parent. It helps with code reusability. Any properties that the children share in common, in this case a name and age, the constructor of the parent can take care of that. We don't have to repeat the set of code every single time for each child. We write it in one place and reuse it. Another thing you can do too with the super keyword is extend a method from the parent. So what we're going to do within the animal parent class is create a move method. Within this method, we will console.log the following message. Add a placeholder, this.name moves at a speed of, add a placeholder, speed, mph for miles per hour, or if you prefer, you can use kilometers. Our move method will have one parameter, a speed that we need to pass in to use. So within each of these children classes, we'll write a method that also extends the move method of the parent. Rabbits will have a run method. We'll output the following message. Console.log. I'll use a template string. This, add a placeholder, this.name, can run. Let's copy our run method, paste it for fish, but change swim to run because fish can't run. This.name, can swim. Then with hawks, they'll have a fly method. Fly, this.name, can fly. With our rabbit object, let's invoke the run method. This rabbit can run. Let's do this with fish. Fish.swim. This fish can swim. And hawk.fly method. This hawk can fly. Within each of these children classes, we're going to extend the move method of the parent animal. Within the run method of our rabbit class, not only are we going to output this message, we'll also extend the move method of the parent and display that message as well. To refer to the parent class, we use the super keyword. It's very similar to this, but it means the parent. Use the parent's move method. But we do have to send a speed argument. Let's send the run speed of the rabbit, this.runSpeed. Let's do this with our fish class. We'll extend the move method, super.move, send in this.swimSpeed, and hawk, super.move, this.flyspeed. Now let's take our rabbit, use the run method, and we should extend the move method. This rabbit can run. The rabbit moves at a speed of 25 miles per hour. Let's do this with fish, fish.swim. The fish can swim. The fish moves at a speed of 12 miles per hour. And hawk, hawk.fly method. This hawk can fly. The hawk moves at a speed of 50 miles per hour. So that's how you can use the super keyword to extend a method of a parent. Alright everybody, so that's the super keyword. It's a reference to a parent. It can be used to call the constructor of a parent and or access the properties and methods of a parent. And well everybody, that is the super keyword in JavaScript. Hey, hello. So today I'm going to explain getters and setters in JavaScript. Getters are special methods that make a property readable. Setters are special methods that make a property writable. We can use getters and setters to validate and modify a value when reading or writing a property. It helps with validation when creating an object or updating one of its properties. Here's an example. We will create a class of rectangle. We need a constructor. We will have two parameters, a width and a height. We will assign this.width equals width, this.height equals height. Now let's create a rectangle object. Const rectangle equals a new rectangle. For the width, let's say -1 million, something ridiculous. And for the height, I want the height to be pizza, the word pizza. Then let's console.log our rectangle's width and the rectangle's height. We have created a rectangle object with the width of -1 million and a height of pizza, which doesn't make any sense. We could use some validation when creating an object. We don't want people to enter in garbage values like -1 million or string when we're expecting a positive number for the width or height. That's where getters and setters come in. We'll begin with setters. When setting one of these properties, either initially through a constructor or updating one of them later, such as setting the width or height equal to some value, we can go through a setter first. Outside of our constructor, we will set a property. We'll begin with width. This will be a special type of method. The parameter will be new width. What do we want to check before assigning this property? Using an if statement, let's check to see if the new width that the user sends us is greater than 0. If it is, we will assign this dot underscore width. Using an underscore prefix, it tells other developers that this is a private property. You shouldn't touch it at all. You could say that this private property of width is different than our standard width property. We will assign the private property of width equal to the new width we receive. Else, let's console.error, not log, we'll use error this time. Width must be a positive number. All right, let's see what happens. Width must be a positive number, and our width is currently undefined, which is good. Okay, let's do this with height. Let's copy our setter for width, paste it, but change every instance of width to be height. Set height, new height. Be sure to use that camel case naming convention. If new height is greater than 0, assign the private property of height equal to the new height. Else, console.error, height must be a positive number. And there we go, that worked. Width must be a positive number, and height must be a positive number. Our width and height are currently undefined. In order to set the width and height, we have to pass in a positive number. For the width, I will say 3. For the width, 4. Now when we access width and height, those numbers still aren't showing up. That's because these properties are writable via setters, but they're not readable. That's where getters come in. We'll create 2 getters. One for width, we'll need to use the get keyword, get width. This will be another type of method. All we're going to do is return this private width. And that appeared to work. We have 3 for the width. Let's do so with the height. We will return this private height. We have 3 and 4. Now by using setters, we can even update those values later. Let's take our rectangles width, set that equal to be 5. Take the height, set it equal to be 6. And that also appears to work. But again, if I try and update those values to some garbage values like -1 million and the word pizza, we get those errors again. And our object retains its initial values that we previously assigned it, 3 and 4. With getters, we can even use the property accessor, that dot, to access a property that doesn't necessarily exist. For example, we will get area. We'll perform a calculation. We will return this private width times this private height. So now we can access area as if it was a property. We have 3 for the width, height 4, Our width times our height gives us an area of 12. Our area isn't a property technically, it's not found within our constructor, but we can access it as if it was a property with a getter. With getters, you can even add additional logic. I would like to preserve the initial values of our width and height. When I return their value, I will use the toFixed method to give each of these a precision of 1. Let's do that with the width, the height, and the area, but that's going to be a little more complex. We'll enclose width times height, then add toFixed 1. And why stop there? I'll add centimeters to the end of each. I'll use a template string, add a placeholder, then add cm for centimeters, 3.0 cm, and the area. 12.0 centimeters. Let's make that centimeters squared because it's area technically. When you're assigning values, even when you're initially creating an object, you can go through the setters for input validation. When you retrieve values and try and read them, you can add additional logic too. Let's go over a second example. We will create a class of person. We need a constructor. We will accept a first name, last name, and an age. This dot first name equals first name. This dot last name equals last name. This dot age equals age. Let's construct a person. Const person equals new person. Let's enter in some values that don't make sense. The person's first name will be the number 420. Their last name is the number 69. Their age is the word pizza. Let's console.log our person object's first name, which is the number 420, their last name, 69, and their age, the word pizza. We need to validate this input before assigning the properties. That's why we need setters. We will set the first name property. This is a special type of method. The parameter is going to be a new first name. We need to be sure that this value passed in is a string and the length is greater than 0. We could write something like this. We need an if statement. Let's check the type of our new first name. Is it strictly equal to a string? And is our new first name's length property greater than 0? If all of that checks out, we will assign this private first name equal to the new first name we receive. Else, let's console.error first name must be a non-empty string. Let's see if this worked. I'm going to save. First name must be a non-empty string, and currently our first name is undefined. Okay, that worked. Let's copy our setter for our first name, paste it, change every instance of first name to last name. New last name. Check if the type of our last name is equal to a string, and if our new last name, the length of it, is greater than 0. If it is, assign the private last name property equal to the new last name. Else, last name must be a non-empty string. That also worked. Our first name and last name are undefined. Let's do this with age. Set our age. The parameter is going to be new age. Using an if statement, is the type of new age strictly equal to a data type of number? And is our new age greater than or equal to 0? If it is, take this private age equals our new age. Else, we're going to console.error. Age must be a non-negative number. We can no longer assign pizza for our age, unfortunately. All right, we have our setter set up. Now let's work on the getters. Let's assign some legitimate values. For the first name, SpongeBob. Last name, SquarePants. Age, 30. We don't have those errors anymore. That means they're set, but those properties aren't readable. That's why we need getters. Let's get the first name, get first name, return this private first name. There's SpongeBob, his first name. Get last name. Return this private last name. There's his last name. Let's create a getter for a full name too. Let's console.log a full name, even though we have no property for that. That's undefined. We'll use a getter to mimic a full name property by just combining the first name and the last name properties. Get full name, return. I'm going to use some string concatenation. This private first name plus a space character, this private last name. And there's his full name, SpongeBob SquarePants. And the age. Get age, return this private age. And SpongeBob is 30. All right, everybody, those are getters and setters. Getters are special methods that make a property readable. Setters are special methods that make a property writable. By using a combination of both, we can validate and modify a value when reading or writing a property. And well, everybody, those are getters and setters in JavaScript. Hey, what's good, everybody? So in today's video, I'm going to give you a lesson in destructuring in JavaScript. Destructuring allows us to extract values from arrays and objects, then assign them to variables in a convenient way. We can use straight brackets to perform array destructuring, or curly braces to perform object destructuring. I'll give you 5 different examples. Example 1. Swap the value of 2 variables. We'll have let A equal 1, let B equal 2. To use array destructuring, we need a set of straight brackets. Add the variables A, comma, B. This will equal, we're creating a new array on the right-hand side, B, comma, A. On the left-hand side of our equals, we're using destructuring. On the right-hand side, we're creating an array. Let's see what's within variables A and B. Console.log variable A, then variable B. So if these values are swapped, we should have 2, then 1, not 1 and 2. That's example 1. We can use destructuring to swap the value of 2 variables. Example 2. We can swap 2 elements in an array. Let's create an array of colors. Const colors equals an array. Pick some colors. I'll go with RGB, so that would be red, green, blue. Let's add black and white. Suppose I would like to swap the position of the first element and the last element. This first element has an index of 0. This particular last element has an index of 4. Again, we're going to use array destructuring. We need a set of straight brackets. We'll take our array, colors, at index of 0, comma, our array, at index of 4. We want to swap red with white. 0, 1, 2, 3, 4. That's the 4th index. Equals, we're creating a new array by using straight brackets, colors at index 4, comma, colors at index 0. Then let's print our array. Console.log our array of colors. There we go. We have white, green, blue, black, red. That's how we can use destructuring to swap 2 elements in an array. Example 3. We can assign array elements to variables. We'll declare a bunch of variables. Const, we'll use destructuring. We're destructuring an array. We need a set of straight brackets. We'll create some variable names. First color, second color, third color. I will assign this equal to our array colors. Let's print these variables. Console.log, our first color, we have red, second color, green, third color, blue. You could combine array destructuring with rest parameters. We have 2 colors left. Let's assign that to a new array. We'll use rest parameters. I will name this array extra colors. Then we will console.log extra colors. And that should be a new array that has the remaining colors, black and white. That's how to assign array elements to variables using destructuring. Example 4, extract values from objects. We'll create 2 people objects. Const person1. Person1 will have a few properties. First name will be SpongeBob. Last name will be SquarePants. Age will be 30. And a job, meaning occupation. Not John, job. His job is that he is a fry cook. Alright, let's copy person1. Looks like that N should be capital in last name. Alright, let's copy person1, paste it, change person1 to person2. The first name of person2 will be Patrick. Last name, Star. Age will be 34. Person2 is not going to have a job property. He's unemployed. Using destructuring, I can extract values from these objects. We'll create a few variables. Const, we'll use object destructuring. We need a set of curly braces this time. We'll create these variables. First name, last name, age, and job. Now this equals, let's start with person1. Let's display these variables. Console.log first name is SpongeBob. Last name, SquarePants. Age, 30. Job, fry cook. Let's do this with person2. Patrick Star, his age is 34. Person2 does not have a job property. Person1 does, though. Our job variable is undefined, as you can see here. You can set default values when using destructuring. If somebody doesn't have a job property, we'll set job to equal unemployed. Let's see if that works. Yep, Patrick Star, age 34. His job is he's unemployed. That's how you can extract values from objects. Values extracted can even have default values. Alright, last example. We can destructure in function parameters. We can pass an object to a function and destructure it when it's passed in. Let's create a function. We will create a function to display a person. With the parameters, we'll use destructuring. We're destructuring an object. We need a set of curly braces. We'll receive an object, such as this. I'm going to invoke display person. We'll pass in person1 as an argument. When we receive person1 as an argument, we'll destructure that object right away. We will create a first name parameter, last name, age, and job. All we'll do is print a few lines using console.log. I'll use a template string. Let's say name, colon space. I'll add a placeholder. First name, and last name. Let's add a new line. Age, colon space, add a placeholder, age. Then lastly, job. Job, colon space, add a placeholder, job. We're passing in person1 and destructuring it. we should display name SpongeBob SquarePants, age 30, job fry cook. Let's pass in person 2 as an argument. Name Patrick Star, age 34, job is undefined. Again, we can set a default value when destructuring. If an object doesn't have a job property, we will set that equal to be unemployed. Patrick Star, age 34, job unemployed. Then if we pass in person 1 again, his job should not be unemployed. He's a fry cook. There is a job property, so we do not use the default value. Alright everybody, so those are a few examples of destructuring. There's a lot you can do with destructuring. You use a set of straight brackets to perform array destructuring, or curly braces for object destructuring. They allow you to extract values from arrays and objects, then assign them to variables in a convenient way. And well, that is destructuring in JavaScript. So yeah, we're doing a thing today. Today I gotta explain nested objects in JavaScript. Nested objects are objects inside of other objects. They allow you to represent more complex data structures. A child object is enclosed by a parent object. By using nested objects, we have the capability of creating some very complex data structures. For example, a person object could contain an address object, as well as a contact info object, or a shopping cart object. Each item in your shopping cart is an individual object, such as a keyboard, a mouse, or a monitor. Each of these child objects would have their own properties and methods. For example, a price, a name, specifications on the item, a shipping method. Nested objects are just objects inside of other objects. Let me give you a basic example. We'll create a person object. Const person equals an object. We need a set of curly braces. A person might have a full name property. I will set that to be SpongeBob in this example. SpongeBob SquarePants. An age of 30. Is SpongeBob a student? Is student. He's in boating school, so let's say that's true. Objects can also contain arrays. We'll create an array of hobbies. To declare an array, you need a set of straight brackets. What sorts of hobbies does SpongeBob have? He knows karate. He does jellyfishing. I need one more. Let's say that he enjoys cooking. Now we're going to create a nested object. This person object will have an address object. So we need a set of curly braces. A few of the properties of the inner address object could be a street. SpongeBob has an address of 124 Conch Street. His city will be Bikini Bottom. And a country. We won't do a full address, but I think this is good enough for this example. So SpongeBob lives in the ocean. Let's say that his country is international waters. I'll just abbreviate international. Our person object has a nested address object inside of it. To access some of these properties of our person object, we would type the name of the object, use the property accessor, which is dot, then the name of the property. Full name. SpongeBob SquarePants. Let's print his age. 30. Is SpongeBob a student? That is true. I'm going to display the array of hobbies. Person.hobbies. This will give you an array. But if you need individual elements, you have to list an index number. So hobbies at index 0 would be karate. 1 is jellyfishing. Index 2 is cooking. Let's console.log our person object dot the address object. This would return an entire object. If you need one of the properties within this object that's within the person object, you would have to follow the inner object with the property accessor again, that dot. Person.address.street, which would give you 124 Conch Street. The city, person.address.city, Bikini Bottom, person.address.country, international waters. So when accessing a property within a nested object, you have to use the property accessor twice, that dot. If you would like to loop through the properties of a nested object, you can write a for loop like this. for const property in person.address console.log, take our person object, access the nested object, address, then use the index of operator, the straight brackets, give me the current property, and there we are. All right, let's make something a little more complicated. We're going to create a class that utilizes nested objects. So we will begin with class address. Our class will have a constructor. For an address, we need these three things. Feel free to add more if you would like. A street, city, and country. Then we'll assign these properties. This.street equals street. This.city equals city. This.country equals country. Now we'll create a person class. Class person. Our person class will also have a constructor. We'll need a name, age, and an address. For the address, I'm going to use rest parameters. We can pass in different parts of an address and store it within an array. When we create a person object, we will assign this.name equals name. This.age equals age. Now for the address, we're going to construct an address object. This.address equals a new address. We're going to call the constructor of our address class and pass in our address. I'm going to utilize the spread operator to spread our address. We'll send our address object a street, city, and country. All right, let's construct some of these person objects. Const person1 equals a new person. This will call the constructor, but we have to pass in arguments to match the parameters. A name, we'll just do a first name to keep it short. An age, SpongeBob will be 30. We also need an address, a street, city, and country. 124, const street. City will be Bikini Bottom. His country will be international waters. And just for readability, I'm going to put the address on a new line. Let's create person 2. Person 2 will be Patrick, age 37. Patrick will live on 128 Conch Street. He'll have the same city and the same country. Then let's make person 3. Person 3 will be Squidward, age 45. Squidward will live on 126 Conch Street. All right, let's see if this all worked. Console.log. Let's start with person 1. Person1.name, which is SpongeBob. Age 30. Let's get his address. Address, and this returns an object, which is good. That's what we wanted. We have a nested object, an address object. For some of the properties within that address object, we have a street, city, and country. We use the property accessor again of dot. Give me the street, 124 Conch Street, the city, Bikini Bottom, and the country, international waters. All right, let's confirm this with person 3, just to be sure it all works. Person 3, give me the name, Squidward, age 45. Address gives me an object. We'll use the property accessor again. Give me the street, 126 Conch Street, the city, Bikini Bottom, and the country, international waters. This will also all work for person 2, if it worked with person 1 and 3. All right, everybody, so those are nested objects. They're objects inside of other objects. They allow you to represent more complex data structures. A child object is enclosed by a parent object. In this example, Our address is the child object of the person object. We're creating a new object within our person object. And well, everybody, those are nested objects in JavaScript. Hey, what's up everybody? So in today's video, I'm going to show you how we can work with an array of objects in JavaScript. What we'll do is create an array of fruit objects. We'll create 5 fruit objects. To create an object, you need a set of curly braces. Each object will be comma separated. Just for my own readability, I'm going to place each object on a new line. Objects can have their own unique properties and methods. Our first fruit object will have a name of apple, a color of red, and calories, meaning calories per serving, of 95. This is our first object. Let's copy these properties, paste them for object 2, change name to be orange, color will also be orange, calories 45. Object 3, name will be banana, color, yellow, calories, 105. Object 4, coconut, color, white, calories, 159. Then our last object will be pineapple. Color, yellow, calories, 37. Alright, and here is our array of objects. There's a lot we can do with this. If you ever need a property within one of these objects of your array, you would take the array, in this case fruits, add an index number, dot the name of the property. For example, name. I need the name property of the first object, which would be apple. So let's test that. Console.log. What is the name property of our array fruits at index 0? That would be apple. 1 is orange. 2 is banana, 3 is coconut, 4 pineapple. Let's select a different property. Let's go with the calories. 95, 45, 105, 159, 37. That's how to access a property within an array of objects. To add a new object, you can use the push method. Let's take our array of fruits, use the push method. We will push a new object into our array. The name will be grapes, color, purple, calories, 62. Then let's console.log our array. Console.log fruits. So we have 6. Apple, orange, banana, coconut, pineapple, and grapes, which I misspelt. Grapes. You can use the pop method to remove an element. Fruits.pop. This should remove pineapple. Apple, orange, banana, coconut, no pineapple. Or splice. Splice will remove elements at certain indices. Fruits.splice. Let's select indices 1 through 2. All we're left with is apple, coconut, pineapple. You can use the forEach method to loop through the elements of your array. Let's display each object's name. Fruits.forEach. We need a callback, a function expression, or an arrow function. Let's use an arrow function. For every fruit, do this. Console.log each fruit. This will return entire objects. For one of the properties, we'll select dot the property, name. We have all the fruit names. Let's go with the colors and the calories. There we are. There's also the map method. The map method will run each element through a function and return a new array. Let's create an array of fruit names. Const fruit names equals take our array of fruits, use the built-in map method. We'll use an arrow function. For every fruit, arrow, return the fruit's name. Then we will console.log our array of fruit names. And here's our array of fruit names. Let's do this with colors. Fruit colors. Return every color property of each fruit. Then console.log our fruit colors. Red, orange, yellow, white, yellow. Let's do this with calories. Fruit calories. Return each calories property. Console.log our fruit calories array. So the map method will return a new array. Let's cover filter. Filter will return a new array after using each element and checking a condition. Let's return a new array where the color of each fruit is yellow. There's two. Const yellow fruits equals take our array of fruits, use the filter method. We have one parameter, a fruit, arrow, then a condition. We'll return this fruit if the fruit's color property is strictly equal to yellow. Then console.log our array of yellow fruits. And there's two, bananas and pineapples. Their colors are both yellow. Let's create a new array of any fruits that are low in calories, where the calories are below 100. Const low cal fruits. Take our array of fruits, use the built-in filter method. For every fruit, arrow, check the calories of each fruit. Is it less than 100? If it is, put it within this new array. And here we are. We have three fruits that are low in calories. Apple, orange, pineapple. The calories are 95, 45, 37. They're all less than 100. Let's find any high-calorie fruits. Change our array to be high-cal fruits, where the calories of each fruit is greater than or equal to 100. Console.log our array of high-cal fruits. There are two. Bananas and coconuts. The calories are 105 and 159. Let's use the reduce method now. I'll admit this is going to be a little tricky, but I'll try my best to walk you through it. The reduce method will return a single value. In this case, an object. One of these objects. Let's return the object with the greatest amount of calories. We'll store that within a constant. Const max fruit equals take our array of fruits, use the reduce method. There's going to be two parameters. An accumulator, which keeps track of the greatest value during each iteration, and the next element. But I think we should rename these. Let's rename our accumulator as max. It's going to be the current record holder of the object with the greatest amount of calories. Element will be fruit, meaning the next fruit. Here are the two parameters. Arrow, what are we going to check? Is our fruit, the next fruit in line, are the calories greater than our current record holder's calories? Max.calories. Just for readability, I'm going to put this on a new line. We're going to use the ternary operator. Is this true? Does the next fruit have more calories than our record holder? If it does, we'll return our fruit, meaning the next fruit. Colon, meaning otherwise, return the max again. Let's see if this works. Let's console.log our fruit with the maximum amount of calories, which is our coconut, with 159 calories. If you just need the calories, you would type .calories. That will just give you the calories. But in this case, we're returning an entire object. Let's find the fruit with the least amount of calories. Let's copy our code, paste it, and make a few changes. Min fruit, change max to be min. The condition will be, is the calories of the next fruit less than the calories of the minimum record holder? Then console.log our min fruit, which is our pineapple with 37 calories. Alright everybody, so those are a few ways in which you can work with an array of objects. There's a lot you can do with them. You can map, you can filter, you can reduce, you can splice, you can pop, you can push, all sorts of things. And well, that is an example of an array of objects in JavaScript. Yo, so what's up? Today I'm going to be talking about the sort method in JavaScript. The sort method is used to sort elements of an array in place. However, with the sort method, we sort elements as strings in lexicographic order, not alphabetical. If I could summarize what lexicographic means, it means alphabet plus numbers plus symbols as strings. Let me give you an example with just alphabetical characters. I have an array of fruits. To sort this array, I can take the array name fruits, use the built-in sort method, then console.log my array of fruits. Let me expand this. And here's my array, all sorted. When sorting, we treat any elements as strings. What if my array were numbers? I'll add the numbers 1 through 10 in a somewhat random order. Let's change our array to be numbers. Numbers.sort, console.log numbers. Here's the result. We have 1, then 10, then the rest seem to be in order. We're not sorting this array numerically, we're sorting this array lexicographically. We're treating each of these numbers as strings. That's why we have 1, then 10. 10 isn't at the end where we expect it would be. There's a couple extra steps we need to do involving sorting numbers. Inside of the sort method, we have to write a custom comparison function. This is normally a callback, but you can write a function expression, or even better yet, an arrow function. We'll write an arrow function in this case. Let me zoom in. With an arrow function, we first need parameters. We'll have parameters A and B. We'll examine two contiguous elements. 1 then 10, 10 then 2, 2 then 9, 9 and 3, so on and so forth. Then we need an arrow. Then we'll write A minus B. Our function A minus B will return either a negative, 0, or positive value, depending on what values we're examining. The sort method will sort those values into place depending on what the value returned is. Our array should be sorted. You can see that 10 is at the end, instead of right after 1. For reverse order, you could say B minus A. Now we're starting with 10 and ending with 1. You can even sort objects by a given property. Let's go over that example. We will create an array of people. Const people equals, this will be an array. We'll include 4 objects, all comma separated. The first will have a name property of SpongeBob, age 30, and a GPA. GPA 3.0. I'm going to zoom out. For the next object, I'm just going to put that on a new line. Let's copy all of these properties, change name to be Patrick, age will be 37, GPA 1.5. Again, for the next object, we will have Squidward, age 51, GPA 2.5. Then lastly, we'll have Sandy. Name, Sandy. Let's make Sandy 27. GPA, of course, it's going to be a 4.0. I would like to sort this array of objects by each person's age. We'll take our array of objects that's stored within people, use the built-in sort method, use our arrow function, A, comma, B, arrow. We'll take parameter A, that's person 1, dot, access their age property, minus parameter B, access their age property. And that's all you got to do. Now let's console.log our people. There we are. We have Sandy, who's the youngest, then SpongeBob, Patrick, Squidward. For reverse order, you'll just change A to be B and B to be A. Squidward, Patrick, SpongeBob, Sandy. Or we can sort by a different property. Let's do GPA this time. A.GPA, B.GPA. We have Patrick with the lowest GPA, followed by Squidward, SpongeBob, Sandy. Then reverse order would be B.GPA minus A.GPA. Sandy, SpongeBob, Squidward, Patrick. Let's try sorting by the name property and see what happens. A.name minus B.name. We have SpongeBob, Patrick, Squidward, Sandy, but that doesn't seem to make sense. These aren't in alphabetical order. If you need to sort by a property that contains a string within an object, there's a different formula. We will take A.name, use the built-in local compare method, compare to B.name. This method will examine two strings for lexicographic order. Now these are all arranged lexicographically, starting with Patrick, then Sandy, SpongeBob, Squidward. For reverse lexicographic order, we would take B.name.localCompare, then examine A.name. I've just now realized that there's a lot of SpongeBob characters whose first name starts with an S. Like we have 3 right here. Squidward, SpongeBob, Sandy, Patrick. Alright everybody, so that is the sort method. It's used to sort elements of an array in place. It sorts elements as strings in lexicographic order, not alphabetical. And well everybody, that is the sort method in JavaScript. Hey everybody, in today's video I'm going to show you how we can shuffle the elements of an array using JavaScript. This is an optional video. You might find this topic helpful if you're interested in making a game using JavaScript, or any sort of application where you need some randomness. In this example, we'll create a deck of cards. Our deck of cards will be an array. We have an A for ace, the numbers 2 through 10. Let me finish typing those in. J for jack, Q for queen, K for king. I'm not going to include any suits for these cards, such as ace of hearts, ace of clubs. That might be overkill for this example. One method you might see floating around online to shuffle the elements of an array is to use the sort method, then pass in an arrow function where you take math.random minus 0.5. I would not recommend using this method just because the results of this method aren't perfectly uniform. Let me console.log cards. This array appears shuffled, but it's not that uniform. But not only that, the larger the array becomes, this method becomes increasingly more inefficient. I would not recommend using the sort method to shuffle an array. Instead, I would recommend using the Fisher-Yates algorithm. We'll create a dedicated function for this. So we will define a function to shuffle. There will be one parameter, an array. Then to invoke this function, we'll type the function name, pass in our array of cards. So what do we want to do exactly? We're first going to loop through the elements of this array. We'll start at the end and work our way towards the beginning. We'll use a for loop to decrement. So within our shuffle function, we'll create a for loop. We will declare index of I, let I equal our array dot length. Then -1. That's the first statement. Our array has 13 elements, but the last index is 12 because arrays start with 0. If the array's length is 13, we need to subtract 1 to get 12, which would give us the ending index of 12. We'll continue this loop as long as I is greater than 0. Then I minus to decrement. Now we have to generate a random number between the end and the beginning, somewhere within this range. We'll create const random. Random will store a random number. Take math.random method times I, our index, plus 1. We'll need to round this number. We're now going to enclose this equation with math.floor to round down. Math.floor, and enclose this equation. Alright, during the first iteration of this loop, we should generate a random number between the end and the beginning. We'll swap our king with a random element within this array. So to swap two elements of this array, we can use destructuring. In this context, to use destructuring, we'll take our original position, array at index of I. During our first iteration, that will be the king. We'll swap our king with our array at a random index, the one that will be randomly generated, equals our array at index of random, comma, array at index of I. Then to finish using destructuring, we need to enclose both sides of this equation with an array. There, and that will swap two elements of your array. Now, if I run this program, this will shuffle the elements of my array. I would recommend using a dedicated shuffle function, because in a game, it's likely you're going to shuffle something more than once throughout that game. Like I said, this isn't a necessary topic to continue on with the series, but if you're ever interested in making a game using JavaScript or need some element of randomness, well then this function would work great. And that is how to shuffle the elements of an array using JavaScript. What's up, everybody? So in today's video, I'm going to explain date objects in JavaScript. Date objects are objects that contain values that represent dates and times. These date objects can be changed and formatted to suit our needs. Here's an example. We will create a date object that contains the current date and time. To do so, let's create a constant named date. Date will be an object. We will call the date constructor with the new keyword, date. Then pass in no arguments for the current date and time. So I'm going to console.log my date object, which gives me my current date and time. As of right now, I'm filming this video on a Thursday, November 9th, the year 2023, at about 7 in the morning. So depending on when you're watching this video, the date and time is going to be different. If you would like to create your own custom date and time object, you'll have to pass in some arguments. You can follow this order for the date constructor. The first argument corresponds to a year, then month, day, hour, minute, second, and milliseconds even. So for the year, let's say 2024, the month, 0 corresponds to January, 1 is February, then that means a month of 11 is December. Let's say January, so that will be 0. For the day, 1 for the first. For the hour, 2 in the morning. This is in military time, by the way. For the minute, 3 minutes after the hour. For the seconds, 4 seconds after the minute. We can even add milliseconds if we would like. So for the milliseconds, let's say 5. And here's my new date object. Monday, January 1st, 2024, about 2 in the morning. Passing in a string representation of time to the date constructor is also valid. Let's say the year is 2024, January 2nd. For the time, you're going to type T for time, 12 noon. Then add Z for UTC time. And there's my new date again. Tuesday, January 2nd, 2024, 6 in the morning. Another format you can use is within the date constructor, pass in a given amount of time in milliseconds since epoch. If I could describe epoch, I would describe it as when the date your computer thinks time began. If you were to pass in 0 to the date constructor, you'll be given a date and time around December 31st, 1969. So within the date constructor, you can pass in a given amount of milliseconds since this date. So if I was to pass in 1.7 billion milliseconds, what I'm telling the date constructor is, give me the date and time that's 1.7 billion milliseconds since that epoch date. When I pass in 1.7 billion milliseconds, the date that I'm given is Tuesday, November 14th, 2023, about 4 p.m. Passing in milliseconds would be good for some sort of timer. Now let's use the current date and time. I will pass in no arguments. You can extract individual values from a date object. I would like the year. Const year equals take our date object. I will use the get full year method to get the year. Then I will console.log the year, and this will be a number, 2023. Let's get the month. Const month equals our date object. Use the built-in get month method. Then I will console.log the month. Currently for me, it's November, not October. So remember, January is 0. December is 11. Let's get the day. Const day equals date. Get date, not day. If you get the day, that will give you the day of the week, like Sunday, Monday, Tuesday, that sort of thing. Let's console.log the day. So for me, it's the 9th. Let's get the hour. Const hour equals date. Get hours, plural. Console.log the hour. For me, it's 7 in the morning. Let's get minutes. Const minutes equals get minutes. Console.log the minutes. It is 7:45 in the morning. Get seconds. Get seconds. Console.log the seconds. So 7:45, 21 seconds after the minute. Now, if you need the day of the week, here's what you can do. Const day of week equals date get day. That will give you the day of the week. Console.log day of week. For me, that is 4. Sunday is 0, Monday is 1. So that means it is Thursday. Now, with the date object, you can even set the date with a method. Let's console.log the date. I'm going to set the year. Date set full year. I will set the year to be 2024. Yep, Saturday, November 9th, 2024. Let's set the month. Set month. I will set the month to be January, so I will pass in 0. Tuesday, January 9th. Let's set the day. That would be with set date, not day. I will set it to be the 1st, January 1st. The hours with set hours. Let's go with 2 for 2 in the morning. Set minutes. 3 minutes past the hour. Set seconds. 4 seconds past the minute. You can even compare dates as well. Let's create 2 date objects. Const date1 equals a new date. I'll pass in a string representation of a date. We won't include the time, though. For the year, let's say 2023. December, that would be 12/31. New Year's Eve, basically. And for date 2, let's say date 2 is New Year's Day. 2024, January 1st. Using an if statement, let's compare to see if date 2 is greater than date 1. If it is, then let's console.log Happy New Year. So date 2 is greater than date 1. We'll print Happy New Year. Let's change date 2 to be 2023, December 30th. Well, nothing happens then, but that's to be expected. Alright everybody, so those are date objects. They're objects that contain values that represent dates and times. These date objects can be changed and formatted to suit our needs. And well everybody, those are date objects in JavaScript. Hey, what's going on everybody? So in today's video, I gotta explain closures in JavaScript. A closure is a function defined inside of another function. The inner function has access to the variables and scope of the outer function. By using closures, they allow for private variables and state maintenance. JS libraries and frameworks such as React, Vue, and Angular use closures all of the time. You'll see closures fairly often with function-based components. You have functions inside of other functions. Let me give you a very basic example. We'll have an outer function named outer. Within the outer function, we'll have a function named inner. The inner function has access to everything within the outer function. this scope. If I was to create a variable, let message equal the word hello, within my inner function, I can use this message variable. Console.log my message. Now, if I invoke the outer function, nothing appears to happen. When we call the outer function, we're now within the scope. But then what? There's one of a few things we could do. If I would like to call the inner function from within the outer function, I would need to call it somewhere here. Let's call the inner function at the end. There we go. We have displayed the word hello. Everything within the outer function is part of a closure. We have a function defined inside of a function. This inner function has access to everything within that scope, including this message variable. One benefit of using closures is that any variables are considered private. Outside of the outer function, I will attempt to update our message. Message equals goodbye. Now, this doesn't work, as you can see. This message variable is in a different scope. It's kind of like it's in another dimension. What we've done here is we have created a different message variable in a different scope. Outside of the outer scope, I have no way of accessing the message variable. So that's one of the benefits of closures. You can encapsulate variables and make them private. Let me give you another example. A closure can maintain the state of a variable. We'll create a counter program. So I'm going to create a function to increment. Within the increment function, I will set a count variable equal to 0. I will increment our count by 1, then console.log. I'll use a template string, count increased to, I'll add a placeholder, we'll display our count variable. Now, anytime I attempt to call the increment function, it'll increase our count by 1. But if I was to execute this function again, well, we're redeclaring this variable of count. We're resetting it every time we call this function. I can't get the count to go past 1, because we keep on resetting it. But by using a closure, we can have state maintenance. We can maintain the state of this variable, and remember what this variable was previously. I mean, I could take this variable and declare it outside of the function, but then we don't have any security for that variable. I will set the count equal to 1,000,000. We're maintaining the state of that variable, but it's not private. Anybody and anything can access and change that variable. A closure maintains the state of a variable and makes it private. What we'll do is enclose all of this code within another function. We'll create a function to create a counter. How do we access the scope within the create counter function? Here's another possibility. We will return an object. We will need a set of curly braces. Our object will have a property of increment, and its associated value will be a reference to increment. There is a shorthand version of this. You can just use the function name as a property. We're returning an object with a method of increment. So now I'm going to create an object named counter. Counter equals invoke the create counter function. This will return an object that has an increment method. So I'm going to take our counter object, use the increment method. Count increased to 1. Not only do we have an increment method, we have a count variable as well. You could say that what we've done with this outer function, it's very similar to creating a class. We can use classes to instantiate objects. In this case, we used a function to return an object. So if I was to take my counter and increment it again, our closure should maintain the state of that variable count. Count increased to 2. It's not resetting every time we call the method. Count increased to 3. Let's attempt to access our count variable. Counter.count equals 0. Then I will console.log our count. Reference error, count is not defined. Let's attempt to display our count variable. Console console.log, take our counter object, access the count variable. It is undefined. We don't know what it is. It's hidden. Your closure can have more than one function. So what we'll do is create a getCount function. We'll use the getCount function to return our count if we need access to it. Function getCount. We will return our count variable. Within the return statement, we're returning an object. We will add another property of a reference to the getCount function. So now within our counter, we have a method to get the count variable. Let's console.log. I'll use a template string. The current count is, I'll add a placeholder, take our counter object, use the getCount method. The current count is 3. If I was to increment our counter again, well, that increased to 4. All right, last example. We're going to create a closure for a game where we keep track of points. We have a score. Let score equals 0. We'll define the functions. Function increase score. We'll have one parameter, points. In order to score some points, we have to pass in some points as an argument. Take our score plus equals our points. Then let's console.log. I'll use a template string plus add a placeholder, our points. Then I'll add PTS, meaning points. It's shortened. Let's create a function for decrease score. Change increase to decrease. Score minus equals points minus points. And then let's get our score. Function get score. Return the score. If I need to increase the score, I will invoke the increase score function. But I have to pass in points. We scored 5 points. Let's do this again. We scored 6 points. Let's decrease the score. I will subtract 3 points. Minus 3 points. Let's get the current score. Console.log. I'll use a template string. The final score is, add a placeholder, get score. The final score is 8. I'm going to add points after that. 8 points. All right, problem with this is that we can take our score and set it to anything. You scored like a kajillion points. So for some security, let's enclose all of this code within a closure. I'll create an outer function. Function create game. This will return an object. Let's cut all of this code, paste it within the outer function of create game. And then at the end, we will return an object that has references to these functions. Return an object. We need curly braces for that. A reference to increase score, decrease score, and get score. So now, I will use the create game function to return an object. Const game. Game will be our object. We will invoke the create game function and return an object. So now if I want to increase the score, decrease it, or get the score, I have to use the methods of this object. Game.increaseScore, game.decreaseScore, and game.getScore. We have 5 points, 6 points, minus 3 points, and then we have the final score of 8 points. Well, everybody, those are closures. Think of them as a function defined inside of another function. The inner function has access to the variables and scope of the outer function. These are used frequently with JS libraries and frameworks such as React, Vue, and Angular, especially when you work with function-based components. And well, everybody, those are closures in JavaScript. Hey, what's going on, people? So in today's video, I'm going to explain the setTimeout function in JavaScript. The setTimeout function allows you to schedule the execution of a function after an amount of time, in milliseconds. The times are approximate. They vary based on the workload of your JavaScript runtime environment. I wouldn't recommend using setTimeout for anything precise like a stopwatch. It's an approximation. To use the setTimeout function, you pass in a callback to a function and a delay in milliseconds. Here's an example. I will create a function to say hello. All we're going to do is window.alert the word hello. I will use the setTimeout function, pass in a callback. We'll pass in a callback to say hello, then execute it after 3000 milliseconds, so 3 seconds. Let's see if this works. 1, 2, 3, hello. An anonymous function works too. So instead of a callback, we'll use an anonymous function. Function, parentheses, curly braces, window.alert the word hello. 1, 1000, 2, 1000, 3, 1000, hello. Or even an arrow function. We have parameters, arrow. What are we going to do? Window.alert the word hello. 1, 1000, 2, 1000, 3, 1000, hello. You can use the clear timeout function to cancel a timeout before it triggers, but we have to pass in a timeout ID. So what we'll do with this setTimeout function is assign it to an ID stored within a variable or constant. Const timeout ID equals our setTimeout function that'll display the word hello. I can clear this timeout with the clear timeout function, but I have to pass in that ID as an argument. Immediately after calling the setTimeout function, we will cancel it. Let's try it. 1, 1000, 2, 1000, 3, 1000. Yeah, nothing's happening. We canceled it. Alright, what we'll do this time is create a button using HTML. When we click on the button, we'll set a timeout to display the word hello. So let's clear all of this, go to our HTML file. We'll create a button. The button will have text of start. And I'm going to zoom in. I will set the onClick attribute to equal a function. We will start a timer, then add a set of parentheses. When we click on the button, do this function. So within our JavaScript file, we will create a start timer function. Function start timer. We will set timeout. I'll use an arrow function. Let's window.alert the word. We will display the word hello after 3000 milliseconds. Alright, so nothing's going to happen until I click the button. I'm going to click it now. 1, 1000, 2, 1000, 3, 1000, hello. Let's create a second button to clear the timeout if we need to stop it. Let's copy our first button, paste it, change the text of the button to be clear. We will clear the timeout, but we'll need another function. Clear timer. So there's our second button. We'll need a timeout ID. So outside of this function, I will declare a variable of letTimeout ID. When we start our timer, we will assign the setTimeout function an ID of timeout ID. Then we can stop it using this ID. We will create a function to clear the timer. We're going to use the clear timeout function. Clear timeout. We need to pass out a timeout ID as an argument. which we will do. And then just to be sure that everything works within both these functions, let's console.log something. Let's say the word started within our start timer. And within our clear timer, let's display the word cleared, just so we know that these functions were called. So I'm going to save everything. I'm going to start the timer, but not clear it. Let's start now. 1 1000, 2 1000, 3 1000. Hello. Let's go to our console. And it says that we started. Well, starter. I clearly can't spell today. Started. We're going to start, then cancel. Start, 1 1000, 2 1000, clear. And nothing happened. Let's go to our console, inspect, console. We started set timeout, and then we cleared it. Alright everybody, that is the set timeout function. It's a function in JavaScript that allows you to schedule the execution of a function after an amount of time in milliseconds. Execution time may vary based on the workload of the JavaScript runtime environment. And well everybody, that is the set timeout function in JavaScript. Hey, what's going on people? So in today's video, we're going to create a digital clock using JavaScript, HTML, and CSS. So let's get started. The HTML for this project is going to be very minimal. I will create a div element. The ID of the div element will be clock-container. Within this div element, we'll have a nested div element with an ID of clock. We have a clock within a clock container. As a placeholder, temporarily, the text on the clock will be 00:00:00:00. 00000000. And I'm just going to zoom in temporarily. And that is all the HTML that we need. Let's head to our CSS style sheet. Let's begin with the body. I will set all margin to be 0 originally. Let's select our clock container, ID, clock container. I'll use flexbox for the clock container. Display, flex. I will justify content in the center. Justify content center. If you would also like to vertically align, you'll need to add the following 2 lines of code. I will align items center. This CSS property will vertically align any elements, but the clock container itself is kind of small. For example, I'll add a border of 2 pixels solid. The elements within the clock container are aligned both horizontally and vertically, but the container itself is kind of small. To vertically align this element within the window itself, we'll have to increase the height of the clock container. I will add height of 100 VH for the viewport height. And we can remove the border. Yep, the clock is now within the middle of the container, both horizontally and vertically. But if you prefer it to be at the top, you can eliminate these last 2 lines. It's up to you. Let's style the clock itself. We are selecting the ID of clock. I will change the font family to be monospace. This is the normal size when I'm zoomed into 100%. I will set the font size to be 6.5 rem. Then set the font weight to be bold. And text align center. If you would like a background image for the body of your document, I just so happen to have one right here. It's a picture of Central Park in New York. This is optional, but if you would like to include a background image of this project within your CSS style sheet, you'll add the following CSS properties. I will set the background image property to be a URL. So what is the name of that image? I'm going to copy the name of it and paste it within this URL function. I'll set the background position to be the center. Right now we're seeing the top left of the image instead of the center. Background position will be center. If you're using a small image, your image might be repeating itself to take up all the available space. To prevent that, you can set the background repeat property to be no repeat. Mine already wasn't repeating though, but yours might be. Then we'll set the background size to cover. By adding this property, this image will cover the entire window and maintain its aspect ratio. If you do have additional content besides this clock, you can keep the background in place when you scroll down by adding this property. Background attachment to be fixed. This property isn't going to be apparent because we don't have a scroll bar, but if you did have a scroll bar, the background will stay in place at least. Let's head back to our clock element. I will change the color, the font color, to be white. If you would like a background blur effect, you'll add this property. We'll set the backdrop filter property to be a blur function. The greater the number, the more blur effect you're going to have. So this is 5 pixels. If I were to increase this to 50, well, there's a lot of blur then. I'll set my blur to be 5. I would just like a little bit, as if we're looking through glass. I'll increase the width to be 100%, to take up 100% of the width of the web browser. Width 100%. To give this glass look a foggy appearance, we can add a background color that's slightly gray. Background-color. Let's select gray, but I like using HSL values. So for the lightness, I'll set it to be 100%, but I'm going to lower the alpha down to like 10%. Now the background has a foggy glass appearance. If you were to increase the amount of alpha, that'll increase the lightness. I'll keep mine as 10%, 0.1 for the alpha. Alright, now we just need to get this clock to run. So let's save everything, go to our JavaScript file. We will create a function to update our clock. Immediately when we begin this program, we will update our clock once, immediately. Now we need to get the current time. Let's declare a constant of now. What is the time right now? This will be a new date object. To get the hour, we will say const hours equals, use the built-in get hours method. Then let's do this with minutes. Const minutes equals now dot get minutes method. And seconds. Const seconds equals now dot get seconds. I'm going to change the text content of the clock to be a time string. It will be a template string. How do we want to arrange our numbers? Const time string equals a template string. First, we'll add a placeholder for our hours, colon, minutes, colon, seconds. Then we will select the ID of clock. Document.getElement by ID. The ID that we're getting is our clock. Change the text content to equal our time string. When we save, the time on the clock should update. Currently for me, it's 8 o'clock. For each of these placeholders, for hours, minutes, and seconds, I would like each to take up 2 digits. We'll add some zeros for padding. For example, this time will be 080016. There's a built-in string method for that. So with hours, minutes, and seconds, we will convert these to strings. We'll use method chaining, then add toString. Do this for hours, minutes, and seconds. With strings, there's a pad start method. For the first 2 characters, pad them with a 0. Let's copy this method and paste it for minutes and seconds. Now, when I save and update the time, we have 0 padding. 08, 01, 54 in this case. To get this clock to update every second, will follow update clock with the set interval function. Set interval works like set timeout, except it will call a function repeatedly, not just once. But we need a callback. The callback will be update clock. Call this function after every 1000 milliseconds. And now our clock should run. Currently, this clock is in military time, although I'm recording this at 8 in the morning. If you would like this clock to be a 12-hour clock, then add AM or PM, here's the following changes we're going to make. We'll declare hours with let instead of const so we can change it and reassign it. We'll create a new constant of meridium for AM or PM. This will equal hours. Is hours greater than or equal to 12? We'll use the ternary operator to check this. If hours is greater than or equal to 12, meridium will be PM. Otherwise, it will be AM. Then, after our meridium, we'll reassign hours. Hours equals hours. Modulus. Modulus gives you the remainder of any division. Hours modulus 12. If this is 0, we'll use the OR logical operator, or 12. After seconds, we'll add a placeholder for our meridium. Currently, we lost our padding for the hours, so we're going to cut this part of our code to convert hours to a string and pad it. We'll take hours equals hours to reassign it, follow hours with converting it to a string using the toString method, and pad it before displaying it. All right, and that has appeared to work. All right, everybody, so that is a digital clock program you can make using HTML, CSS, and JavaScript. Hey, what's going on, everybody? In today's video, I'm going to show you how we can create a stopwatch program using JavaScript, HTML, and CSS. So sit back, relax, and enjoy the show. All right, let's get started, everybody. We will create an H1 heading with text of stopwatch, and I will give this H1 element a unique ID of my H1. Then we'll create a container for our stopwatch. This will be a div element. This div element will have an ID of container to contain everything. Our container is going to have two sections, two div elements. The first div element is going to be for our display. ID display. I'll give this div element some initial text as a placeholder. We'll have zeros for hours, minutes, seconds, and milliseconds. Then our next div element will have an ID of controls for all the control buttons. Within this div element of controls, we'll create 3 buttons. The first button will be start. The ID of this button will be start button, BTN short for button. Then I will set the onClick event handler equal to a JavaScript function. We will eventually create a start function. We still need to define it. Let's copy this button, paste it twice. The second button will be for stop. The ID will be stop button. The onClick attribute will be for a stop function. The text on the button will be stop. And then we have a reset button. The ID is reset button. The onClick attribute will be for a reset function. The text on the button will be reset. All right, and that is all the HTML that we need. Let's go to our CSS style sheet. I will first select the body of our document. We'll use Flexbox to display everything because I like Flexbox. Display flex. The flex direction will be a column. Then I will align items center. I'll set the background color of this application. Background-color. Pick a color. Again, I like using HSL values. I'll set the lightness to 90%. Our container is going to be a lighter color. We will select the ID of my H1. That's going to be the heading. I will set the font size to be 4 REM. The font family, I will pick Arial with a backup of sans serif. For the font color, I will set the color property to be pick a color. I'll pick black, but set the lightness to 25%. Alright, now we are going to select the container that contains everything, besides the heading. This area. We will select the ID of container. I will use flexbox within the container. Display flex. The flex direction will be a column. And align item center. Let's add a border around the container. 5 pixels solid. And I will round the corners. Border, radius. Let's do 50 pixels. And I'll add a little bit of padding. Padding, 30 pixels. And I will set the background color to be white. Background color white. We'll work on the time display next. Select the ID of display. I will set the font size to be 5 rem. For the font family, I'm going to set it to be monospace. And the font weight, I will set to be bold. I'll change the color. I'll set the lightness to 30%. I'll give a text shadow to the display, so it looks like it's somewhat 3D, like it's popping out. So text, shadow, 2 pixels and 2 pixels for the vertical and horizontal offset, and a blur of 2 pixels. Now for the color, I'm going to lower the alpha to 75% or so. That's not bad. Then I'll add a little bit of margin to the bottom. Margin, bottom, 25 pixels. Now we have to style the buttons. We will select the ID of controls, but I would like the button elements within the controls. After selecting the ID of controls, select any buttons within that element. We'll increase the font size of the buttons. Font size 1.5 rem. I will set the font weight of the buttons to be bold. I'll add a little bit of padding, 10 pixels by 20 pixels. I'll add some margin around the buttons, 5 pixels. I'll set a minimum width of the buttons to be 125 pixels. Let me scroll down. I'll remove the border, border none. Set the border radius of the buttons to be 10 pixels. Change our cursor to be a pointer when we hover over the buttons. Let's see if that works. Yes, it does. Then set the font color of the buttons to be white. Now let's color the start button. We will select the ID of start button. Set the background color. Pick a color. I'll start with something green. Pick whichever color you would like. I'll pick this shade of green. Here are the values. When we hover over the start button, we will access the hover pseudoclass of our start button. I'll decrease the lightness by 10%. Let's copy the markup that we have for the start button, paste it twice. We'll add color to the stop button and the reset button. I'll set the stop button to be red. Here are the HSL values that I picked. When I hover over this button, I'll set the lightness to be 10% darker. For the reset button, I'll set that to be blue. When we hover our cursor over the reset button, I will set the lightness to be 10% darker. Not bad. For all of the buttons, I'm going to add a transition effect. Transition, select the background color. We will create an ease transition after 0.5 seconds. We will ease. So when you hover your cursor over the buttons, there's going to be a slow transition when we hover. Okay, and that is all the CSS that we need. We will now go to the JavaScript file to add some functionality. Let's declare all the variables we'll need. We'll get the ID of the display and store a reference to it. Const display equals document.getElementById. The ID that I'm selecting is display. This ID. We will create a timer. Let timer equals null. Timer is going to hold the ID of set interval, so we can keep track of it and stop it if we need to. Then we need a start time. Let start time equal 0. Let elapsed time equal 0. Let is running. This will be a Boolean, which I will set to be false. If the stopwatch is currently running, we will flip this to be true, and flip it to be false to stop it. What are the functions that we need? We have a start, stop, and reset function. Function start, function stop, function reset. We'll add one more function of update to update the display. Function update. We'll begin with the start method. We'll enclose everything within our function within an if statement. We need to check to see if our stopwatch isn't running. If our stopwatch isn't currently running, if not running, then start the stopwatch. We need to set the start time. The start time equals, we will get the current date, date.now, minus the elapsed time, which will be 0 initially. So just to demonstrate what the start time is, I'm going to console.log my start time. So the start time is going to be in milliseconds since epoch. Epoch, basically speaking, is when your computer thinks time began. We will set our timer equal to the set interval function. We will call the update function every 10 milliseconds. So if I was to display my timer, console.log timer, this is what it is. Our timer stores a unique ID to work with this function if we ever need to stop it. We'll take the Boolean variable of isRunning, set it to be true, because our stopwatch is now running. Now we need to go to the update function to actually get it working. We need to get the current time. Const current time equals access our date. Use the now method. What is the date right now? We will calculate the elapsed time equals the current time minus our start time, whatever that was when we initially pressed the start button. So the current time minus our original start time gives us the elapsed time. And this is going to be in milliseconds. We need to convert the elapsed time into a readable format using hours, minutes, seconds, and milliseconds. We'll begin with hours. Let hours equals take our elapsed time divided by, to convert milliseconds to hours, we can follow this formula. Elapsed time divided by 1000 milliseconds times 60 seconds times 60 minutes. We don't want any decimal portions with our hours. We will enclose all of this with the floor method of math. Now we're going to do something similar with minutes. Let minutes equals take our elapsed time. we need to convert milliseconds to minutes, divided by 1,000 milliseconds in a second times 60 seconds in a minute, then modulus 60. Modulus gives you the remainder of any division. We don't want our minutes display to hit 60 or go above 60. Once we hit 60, it'll reset back to 0. Enclose this formula with math.floor to round it. Math.floor. Okay, then we have to take care of seconds. Let seconds equals take our elapsed time divided by 1,000 to convert milliseconds to seconds. Modulus 60. Enclose all of this with math.floor to round it. Now for milliseconds, let milliseconds equals take the elapsed time, which is already in milliseconds, modulus 1,000. Milliseconds is normally 4 digits. We're going to divide it by 10. We only want the first 2 digits. Divided by 10. Enclose all of this with math.floor. Math.floor. Then let's change the display. We'll access our display. Access the text content of the display. Set it equal to a template string. If you would like to display the hours, it's optional. We will add a placeholder for hours, colon, placeholder, minutes, colon, placeholder, seconds. If you would like to display the milliseconds, we can add a placeholder for that, colon, placeholder, milliseconds. Let's see what we have so far. I'm going to hit the start button, and here's what we got. So the stopwatch is running, but we should add some zeros for padding. So I'm going to refresh to stop it. We'll convert hours, minutes, seconds, and milliseconds into a string, then add some padding of zeros to it, if the number is only 1 digit, not 2. We will convert hours, minutes, seconds, and milliseconds into a string before displaying it. So let's take hours equals hours. I will typecast it as a string. Follow this with the pad start method. For the first 2 digits, add a 0. Let's do this for minutes, seconds, and milliseconds. Minutes, seconds, and milliseconds. We should have some zeros for padding to make each display 2 digits. And that does appear to work. Nice. Now we just need to get the stopwatch to actually stop. Right now there's no functionality. Going to our stop function, we need to check to see if our program is running. Is this variable is running true? If is running, if that's true, then stop the stopwatch. We will use the clear interval function. We need to pass in that unique ID for the timer. This will stop the stopwatch from running. Then we will calculate the elapsed time. Elapsed time equals the date right now, date.now method, minus the original start time. Then set is running equal to false, because the stopwatch is stopped. It's not running anymore. Now we can start the stopwatch, and we can stop it. We can start it, and we can stop it. The last thing we need to do is reset the stopwatch. We can really just copy everything that we have when we initially assign these variables. We need to clear the timer, clear interval, pass in our variable timer that contains the ID of the set interval function. The start time will be 0. The elapsed time will be 0. Is running will be false. Change the text content equal to all zeros. This is for the hours, minutes, seconds, and milliseconds. All right, let's see if everything works just fine. We can start. We can stop. We can start. We can stop. we can reset, we can start, and we can stop. All right, everybody, so that is how you can create a stopwatch program using JavaScript, HTML, and CSS. Hey, what's going on, everybody? So today I'm going to explain ES6 modules in JavaScript. A module is an external file that contains reusable code that can be imported into other JavaScript files. Let's say you write a really difficult program. Well, any part of that program you can import into a different application if you don't feel like rewriting it. Modules can contain variables, classes, functions, and more. ES6 modules were introduced as part of the ECMAScript 2015 update. Using modules, we can create some reusable code that can be used in different programs, different JavaScript files. So what we'll do in this example, we will create a new file. I'll create a module for some math utility functions. This file will be math.util.js. It's a separate JavaScript file. From our index file, we will import this module, math.util.js. But in order to do so, within our HTML file, we have to set the type attribute equal to module. We'll now treat our index file as a module. We can import and export other modules freely, but we have to be sure to include this attribute and set it equal to module. So within our math.util module, we can write some reusable code for other programs. So let's define what pi is. Pi equals 3.14159. We'll create a function to get circumference. You have to pass in a radius, though. That's going to be the parameter. Function get circumference. We need a radius. We will return 2 times pi times radius. Then we'll create a function to get area. Get area. We still need a radius. We will return pi times radius times radius. Then get volume to get the volume of a sphere. Function get volume. Again, we need a radius. We will return 4 times pi times radius times radius. I can reuse these variables and functions for any JavaScript program that I have. I can import them. In order to do so, though, we need to be sure that we prefix each variable, function, or class, or anything else, with the export keyword, so that we can import it elsewhere. So let's be sure we do that. Alright, be sure to save everything. We can close out of this module. Then from our index CSS file, I will import. Then we're going to use object destructuring. We need a set of curly braces. From the location of that module. So these files are right next to each other. Relatively speaking, they're right next to each other. I would need // the name of that file. Math, util, and this is a JavaScript file. Now, anything I would like to import, I'll place within the set of curly braces. We're going to be using object destructuring. From this JavaScript module, I would like pi, comma, separate each entity. Then I would like get circumference, get area, get volume. I can now use these variables and functions as if they were already part of my JavaScript file. For example, I'm going to console.log pi. And pi does have a value because we imported it. Let's get the circumference, but we do need to pass in a radius. This is a function that we have imported from that math.utils module. I will store the result within a variable. Const circumference equals, we'll invoke the getCircumference function from that module. I'll pass in 10. Then we're going to display the circumference. I'll use console.log. I'll use a template string, include a placeholder, display the circumference, plus a unit of measurement, like centimeters. 62.8318 centimeters. This isn't necessary, but I'm going to round this number to 2 decimal places using the toFixed method of numbers. Let's round to 2 decimal places. Let's create an area variable. Const area equals get area. I'll pass in 10 for the radius. Let's copy this line and paste it because I'm lazy. Let's display our area variable with centimeters cubed. 314.16 centimeters cubed. Then we'll create a volume variable. Const volume equals get volume. I will pass in 10. And then we will display the volume. Volume centimeters cubed. And our volume, if we pass in a radius of 10, would be 1,256.64 centimeters cubed. All right, everybody, so those are modules. They're external files that contain reusable code that can be imported into other JavaScript files. You can write variables, classes, functions, and more that can be reused in other programs. You just have to be sure to import them. And well, everybody, those are ES6 modules in JavaScript. Yo, what's going on, people? So in today's video, I gotta explain what asynchronous code is in JavaScript. Synchronous is code that executes line by line consecutively in a sequential manner. Synchronous code waits for an operation to complete. For example, if I were to use console.log, let's pretend we're performing some task. It doesn't matter what the task is. We will pretend that task 1 is complete, then we'll move on to task 2, then task 3. All this code is synchronous. We're executing this code line by line. We can't move on to task 2 until we complete task 1. There is an order of events that we need to follow. It's code that waits for an operation to complete. Now, on the other hand, asynchronous code allows multiple operations to be performed concurrently without waiting. Asynchronous code doesn't block the execution flow and allows the program to continue. Imagine that asynchronous code is kind of like a time traveler. A time traveler can move out of the flow of time, but the rest of the world continues. Time resumes normally. Asynchronous code doesn't block the execution flow. Time moves on, with or without it. Asynchronous code is typically found with input-output operations, network requests, and fetching data, anything that could take an indeterminate amount of time. So, for example, I will use the set timeout function. After 3 seconds, I will execute a function. Let's console.log, let's say task 1. We'll change these 3 lines to be task 2, task 3, task 4. I will finish task 1 after 3,000 milliseconds. Now check this out. We've already completed task 2, 3, and 4, but task 1 finished last. That's because setTimeout is one of many asynchronous functions. The rest of the program isn't going to wait around for it to complete. It runs concurrently with the rest of my code. That's why task 1 was completed at the end, and not at the beginning. There's different ways to handle asynchronous code. We're already familiar with callbacks, but there's also promises, as well as a sync and a wait. We still need to discuss these topics in the future, but we're already familiar with callbacks. If it's crucial that task 2 through 4 finishes after task 1, we can use a callback. We don't necessarily know how long this asynchronous function is going to take. What we could do in this example is create a function. Function func1 meaning function 1. I will execute this code within function 1. Then we will accept a callback as an argument. Then we'll have function func2 to do some synchronous code. Function 2 will have tasks 2 through 4. After task 1 is complete, I will invoke my callback to function 2. So with an arrow function, I have more than one line of code. I need to add a set of curly braces. After task 1, I will invoke that callback. So then, if I call function 1, I have to pass a callback to function 2. So now, function 1 is asynchronous. but I need this synchronous code to execute after task 1 is complete. And now that should work. 1, 2, 3. There it is. We have task 1, which is asynchronous, followed by task 2, task 3, and task 4. So by using callbacks, that's one way in which we can handle asynchronous code. But we still need to discuss promises, async, and await, which are future topics. Alright everybody, so that is what asynchronous code is. Synchronous code executes line by line consecutively in a sequential manner. Asynchronous code allows multiple operations to be performed concurrently without waiting. Asynchronous code doesn't block the execution flow and allows the rest of the program to continue. Asynchronous code is commonly found with input-output operations, network requests, and fetching data, usually anything that takes an indeterminate amount of time. And well everybody, that's what asynchronous code is in JavaScript. Hey people, so in today's video I'm going to explain error objects in JavaScript and how to handle them. An error is an object that is created to represent a problem that occurs. Errors occur often, usually when we accept user input or establish a connection. It's an object that's created to represent a problem. So for example, I am going to console.log the word hello. And then afterwards, I'm going to display a message to indicate that we have reached the end of the program. You have reached the end. This runs as it should, right? Let's say I misspell log as leg. Well, we encounter an uncaught type error. There's many different types of errors. Console.leg is not a function. Type errors tend to happen when we try and access something within an object that doesn't exist. One big issue that we run into is that we prematurely exit the program. It never finishes executing. We have not reached the end. Errors, when they're uncaught, interrupt the normal flow of our program. Another example of an error would be a reference error. I will console.log x, but x isn't defined. We have an uncaught reference error. X is not defined, and again it interrupts our program. We never reach the end. Errors can be generated for all sorts of issues, such as network issues, promise rejection, which we still need to talk about, and security errors. When we encounter a problem when doing one of these things, an error object will be generated, and it interrupts our program. There's a solution though, and that is to handle these errors when they occur. We can do that with try, catch, and finally blocks. With the try block, we can enclose any code that might potentially cause an error, such as if we're trying to establish a connection to something. If that connection fails, an error can occur. If we don't handle it, it's going to interrupt our program. So all of this code I will place within a try block. We will try all of this code. But we need a catch block too. The catch block has one parameter. It will catch an error object. Then let's console.log the error object to see what it is. So let's run this. We have a reference error. X is not defined. See, now we are reaching the end of the program. The program is not being interrupted. We have gracefully handled this error. Before it was uncaught, but now it's caught. For catching errors, I wouldn't recommend using console.log. Rather, I would use console.error. This will highlight any errors that occur and still handle them. It's good for debugging. We can clearly see the error. Reference error, X is not defined. And again, it doesn't interrupt our program. We still reach the end. Now, optionally, you can add a finally block. The finally block always executes regardless if an error comes up. The finally block is usually used for closing files, closing connections, or releasing resources. Usually when you open something or establish a connection, you need to close it afterwards. You don't want to leave it open. That's where the finally block comes in. Do any cleanup at the end, whether or not an error occurs. So just to test this, I'm going to console.log this always executes. I'm going to console.log x. We have a reference error. It is caught, so it doesn't interrupt anything. We're still executing the finally block, and we reach the end of our program. If we don't run into any errors, I'm going to console.log hello, there are no errors that occur. We don't end up catching anything. This always executes, the finally block, and we reach the end of our program. So any code that is considered dangerous, where it could cause an error, you'll want to surround with a try block, and then catch them. In the future, if you ever open any files or establish a connection, you'll want to finally block to close those connections, but we haven't discussed that yet. Errors can also occur when accepting user input, because we don't know what the user is going to type in. In a worst case scenario, a user could type in a malicious script. In this next example, I'm going to create a constant for a dividend and a divisor. Const dividend equals window.prompt, enter a dividend. With division, a dividend is the number that is being divided, and we need a divisor. A divisor is the number we're dividing by. Enter a divisor. Then I'm going to create a constant, result. Result equals our dividend divided by our divisor. Console.log the result. What is 1 divided by 2? 0.5. Now, mathematically speaking, we can't divide a number by 0. If you attempt to do this in JavaScript, I will divide 1 by 0. You end up with infinity. We can intentionally cause errors, then handle them with try, catch, and optionally finally blocks. So this code is considered dangerous. I'll place it within a try block. We need to catch any errors. Catch an error object if it occurs, then console.error the error object. So just to test this, instead of console.log, I'll misspell log as leg. I should probably add a message just to confirm that we have reached the end. You have reached the end. 1 divided by 0. Type error, console.leg is not a function, but we still reach the end. Our program isn't interrupted. Within a try block, in certain situations, we can intentionally cause an error. I'm going to use an if statement. If our divisor is equal to 0, then I will throw a new error object. We're calling the error constructor to construct a new error object. Within the constructor, we have one argument we can pass in, a message. What is the error going to say? You can't divide by 0. Okay, let's try this. Enter a dividend. 1, enter a divisor. I'll type in 0, then press OK. We have a caught error. You can't divide by 0. Our program isn't interrupted. We still reach the end. Let's change console.leg back to log, because I forgot to do that. What if somebody attempts to type in something that's not a number? Enter a dividend 1, enter a divisor. I'll type in the word pizza. Not a number. You have reached the end. I would like to throw a new error when somebody doesn't type in a number. What I can do is that with our prompt, I will typecast it as a number. If somebody enters in some non-numeric characters for either the dividend or the divisor, we will store within there not a number. So let's check that with an if statement. If is not a number. If our dividend is not a number, or our divisor is not a number, let's throw a new error. Throw new error. Values must be a number. I will divide 1 by the word pizza. Error. Values must be a number. We still reach the end of our program. With error objects, you can even create your own in certain situations, and then you can handle them however you want. Alright everybody, so those are error objects and how to handle them. An error is an object that is created to represent a problem that occurs. They occur often with user input or establishing some sort of connection. To handle them, you can use try, catch, and optionally finally blocks, which are mostly used for cleanup. If there's any code that can cause an error, please place it within a try block, and catch any errors that happen. And well, everybody, that is how to handle errors in JavaScript. Hey, what's going on, everybody? In today's video, we're going to create a calculator program using HTML, CSS, and JavaScript. So let's get started. All right, let's do this thing, everybody. We have a lot of buttons to create, but we'll need a container. I will create a div element. The div element will have an ID of calculator. Within this div element, we'll create an input element. The input element will have an ID of display, to display the numbers that we type in. I don't want somebody to enter in some text for the display. I would like this display to be read-only. I will add the read-only property, so we can't type in anything even though I'm trying. I will create a nested div element that has an ID of keys for all of the keys. We need to add a lot of buttons. We'll begin with the first. I will create a button element. The text on the button will be plus. I will set the onClick attribute of this button to be a JavaScript function. We still need to define this function. Eventually, we'll create a append to display function. We have one argument to pass into this JavaScript function, a character of plus. That's our first button. Let's copy this button and paste it 13 additional times, if I counted right. Okay, the second button will be 7. The character we're passing in is 7, followed by 8, 9, minus 4, 5, 6, asterisk for multiplication, 1, 2, 3, forward slash for division, then 0. And here are the new buttons. I miscounted, we need to add one more. A dot for a decimal. Now we need an equals button. We're going to arrange that a little different. Let's create a button with the text of equals. The onClick attribute of this specific button is going to be calculate. Then we need a button to clear our screen. The text on this button will be capital C for clear. The onClick attribute of this button is going to be clear display. And that is all the buttons we'll need. So let's save everything, and let's go to our CSS style sheet. I'm going to zoom back to 100%. First, let's style all these buttons. I will select all buttons. For each button, I will set the width to be 100 pixels. The height to be 100 pixels, so they're even. I would like rounded buttons. I will set the border radius property to be 50 pixels, so they're circles. Let's remove the border. Border, none. I'll change the background color of the buttons. Background-color. I'll use HSL values. I'll set the lightness to be 30%, so they're darker. For the text of the button, I will set the color to be white. For the font size, I will set that to be 3 rem. Set the font weight to be bold. Then when I hover my cursor over one of the buttons, I would like my cursor to be a pointer. Cursor, pointer. Now we have to arrange these buttons properly. Let's select the ID of keys. Keys is a div element that's containing all of the buttons. This element. All of the buttons are within. To arrange these buttons in a grid, we can set the display property to be a grid. For this calculator, I would like 4 columns. To do that, I will set the grid template columns property to be, we'll use the repeat function of CSS. I would like 4 columns. Then to arrange these buttons evenly, you can use 1FR. FR stands for fractional unit. 1FR indicates that each column should take up an even amount of space. So now we have columns of 4. If I were to set this to 3, we would have columns of 3. But I'm going to use columns of 4 because I would like all of the operators on the left-hand side. I'll set the gap to be 10 pixels. That is the gap between each of the rows. Then I'll add some padding of 25 pixels. That's padding around the keys. Let's select the ID of calculator. I'll add that to the top to keep everything organized. With our calculator, I will select a font family of Arial with a backup of sans serif. Let's pick a background color for the calculator. I will select something darker. I'll set the lightness to be 15%. I'll round the corners of the calculator. Border, radius, 15 pixels. The corners of the calculator are smooth now. Then I will set a max width of the calculator to be 500 pixels. If any elements overflow, I will set that to be hidden. This is mostly for our display, if we have a very long equation. Alright, next, let's select the display. Right now it's kind of small. We are selecting our ID of display. Let's set the width to be 100%. I'll add some padding of 20 pixels. For the text of the display, I will set the font size to be 5 rem. Let's text align left. I'll remove the border, none. And I'll change the background color. I'll just copy this property because I'm lazy. Let's increase the lightness to 20%. Then we'll select the body of our document. I will remove all margin 0. I would like the calculator to be in the middle of my window. Right now it's in the top left corner. If you would prefer it up here, you can leave it as is. I will set the display to be flex for flexbox. Justify content in the center for a horizontal alignment. For vertical alignment, we can set align items to be center, but we do need to increase the height of the body of the document, so it's 100%. I will set the height to be 100 VH for 100% of the viewport height. That should place the calculator in the middle of the body of our document, both horizontally and vertically. For the background color, I'm going to decrease the lightness slightly. For the background color, I will set the lightness to be like 95%. Okay, let's go to the bottom of our CSS style sheet. When I hover over one of these buttons, I would like to increase the lightness. So with all buttons, with the hover pseudo class, change the background color so the lightness is 40% instead of 30. Now these buttons light up when we hover our cursor over one of the buttons. Now when I click on one of the buttons, I'll increase the lightness further so it flashes. We are selecting the active pseudo class now. Let's take our background color property, increase the lightness to 50%. When we hover over a button, it lights up. When we click on it, it flashes momentarily. So with all of these operators, I would like all of these operator buttons to be a different color. I'll pick orange. We're going to give each of these buttons a new class. Let's head back to our HTML file. Beginning with the plus button, I will set the class equal to operator dash btn for button. So let's copy this class, paste it for our minus button, multiply button, divide button, and the clear button. Now we will select the class of operator btn for button. Let's change the background color. I'm going to set the background color to be orange. I've already pre-picked a color. When I hover my cursor over one of the operator buttons, I would like the color to be a lighter orange instead of gray. Let's take our operator button, access the hover pseudo class. I'll increase the lightness to 65%. Then, when I click on one of these buttons, I would like the lightness to increase further. With the operator button class, with the active pseudo class, increase the lightness to 75%. So when I click on one of the operator buttons, it's going to flash momentarily. Alright, and that is all the HTML and CSS that we need. Now we just need to add functionality. Let's go to our JavaScript file. For our JavaScript file, there's not a lot we have to write. First, we need to get the display element. So what was that ID? Display. Const display equals document.get element by ID, get the ID of display. We have three functions to create. A function for append to display, calculate, and clear display. These three functions. Function append to display. There is one parameter, input, because we were passing in a character when we call this function. Then we have a function to clear display. Then a function to calculate. We'll begin with append to display. All we're going to do is take our display, this element, access its value, append it with plus equals our input. And let's see if this works. 7. I forgot to change the font color of the display, so let's do that. Within our display element, let's set the color to be white. Okay, that's much better. 7.13 plus 5 equals. Okay, we know that that works. When I click on the clear button, I would like to clear this display. Let's access our display element, access the value property, set it equal to an empty string. 3.14159. When I hit clear, it should clear the display. Lastly, we have calculate. Let's take our display element's value property, set it equal to. Now we're going to use the eval function. The eval function takes an expression such as 1 plus 2 plus 3 and evaluates it and gives a result. It's kind of like it's its own built-in calculator, so to say. Evaluate the value within our display. Display.value. So if I add 3.14 plus 1.01, I'm given a result of 4.15. Now, for some reason, if we get an error, for example, 7 plus equals, well, we have a problem. Let's go to our console. We've encountered an uncaught syntax error because we never finished our equation. In the last lesson, we learned about error handling. This is dangerous code. It can cause an error. Let's surround this code with a try block. We will try this code and catch any errors that happen. So we need a catch block now. Catch any errors. We will change the value of the display to equal some text of error. All right, and that should work. 3.14 times equals, that results in an error. We can clear it and then start over. What's 1 plus 2 plus 3 plus 4? That would be 10. All right, everybody, so that is a calculator program you can make using JavaScript, HTML, and CSS. Impress your friends. All right, what's going on, people? So today I gotta explain what the DOM is in JavaScript. The DOM is the document object model. It's a JavaScript object that represents the page you see in the web browser, and it provides you with an API to interact with it. The web browser constructs the DOM when it loads an HTML document and structures all of the elements in a tree-like representation. Within my HTML document, we have our HTML element as the root element. The HTML element contains a head element and a body element, and many various elements can be found within each of these. They're arranged in a tree-like data structure, but we access this tree-like data structure from the document object. In past lessons, in order to select an element by its ID, we would type document dot, then follow it with a method like getElementById. And then we would select an element by its ID. Our document is an object. It contains properties and methods and other nested objects. If I was to console.log the document, well, then it's going to display my HTML document. Now, you can also use dir, meaning directory. This will list all of the properties of this object. So here's my document object and all of the different properties it contains. It's one gigantic object. For example, we have a title, the title of the web page. That would be found right here near the bottom, document. But you can change it. I will access our document as if it was an object, because it is, access the title property, change it to something else, like my website. Now if I display the title, that property has changed. It's now my website. Dynamically, after the page loads, I would like to change the background color of my document. Later on in the series, we're going to create a toggle button to toggle between light and dark mode. Just to give you an example, if I need to change my theme to be dark mode, I could access the document object, access the body, access the style, then change the background color property to some color. Let's stick with black for now. I'll use HSL. The hue will be 0, saturation will be 0%, and the lightness will be 15%. Even though we have no CSS, we're still able to dynamically change the background color. Let me give you another example. We'll create an H1 element. This H1 element will say, welcome. I will give this element an ID. ID welcome dash MSG meaning message. And I'm just going to zoom in a little. I will create a constant of username. Type in your username or your full name. I'm going to conditionally change the content of this HTML document. I will get this element by its ID, our welcome message. Const welcome message. I'm using camel case naming convention for this. So I will access my document, use the getElementById method. That ID was welcome dash message, MSG for short. I would like to update the text content of this element. I'll take my welcome message, access the text content of it, then append some text using string concatenation. I'll use the ternary operator to see if my username is strictly equal to an empty string. Is our username empty? Did somebody not type it in? Question mark. If username is empty, I will append our welcome message with guest. Otherwise, our username. My username has a name, it's not empty. It will display my name, welcome brocode. If it was empty, if somebody didn't type it in, it will display welcome guest. So that's an introduction to the document object model. The document object model is a JavaScript object that represents the page you see in the web browser, and it provides you with an API to interact with it. The web browser constructs the DOM when it loads an HTML document and structures all of the elements in a tree-like representation. By using JavaScript, we can access the DOM dynamically after the page loads and change the content, structure, and style of a web page. And well, everybody, that is an introduction to the document object model in JavaScript. Hey, it's me again. So today I gotta explain element selectors in JavaScript. Element selectors are methods used to target and manipulate HTML elements. By using these methods, they allow you to select one or more multiple HTML elements from the DOM, the document object model. These methods are built-in methods of document, the DOM. We can select elements by an ID, a class, a tag name, and then there's query selector and query selector all. These methods return something different, either an element, an HTML collection, or a node list. One method you're probably already familiar with is getElementById. So in this example, within our HTML document, we will create an h1 element. I will create a heading for my sample web page. I'm hungry, so I'm going to talk about food. My heading is going to be Food Are Us. It's like Toys R Us, but it's with food. I'm going to give this h1 element an ID of my dash heading. So going back to our JavaScript file, I can select this element by its ID. I'll store a reference to it. Const my heading equals, we're accessing the DOM with document dot get element by ID. That ID was my heading. I can access this element, this h1 element, using this reference. So let's take my heading, access its style, access its background color. So with CSS properties in JavaScript, if you're accessing them through the DOM, they have a camel case naming convention. If you're selecting these properties with CSS, they have a hyphenated naming convention. So do pay attention to that. So with the background color, I will set it to be yellow, as if we're highlighting it. You could also apply different CSS properties. Let's take my heading, access its style, access the text align property, and set it to be center. And it's now centered. Now, if I was to console.log this element of my heading, this is what we would see. It displays my HTML element, including its style, if it has style. For some reason, if this ID doesn't exist, for example, I'll misspell heading as heading with an extra G, well, this returns null. If I were to eliminate these two lines of code, you can see that. Null. GetElementById returns a single element if it finds it, or null if it doesn't. The next method is getElementsByClassName. This returns an HTML collection. It's similar to an array, but it's limited in the built-in methods that it has. So within our HTML document, I will create 3 separate div sections. This first div element will have a class of fruits. My first fruit will be apple. So let's copy this div element, paste it 2 times. I'll change the second to be orange, then banana. All right, going back to our JavaScript file, I will use this method of getElementsByClassName. This will return an HTML collection. It's similar to an array, but it's not technically the same. So const fruits, this will be the name of my HTML collection, equals document, we're accessing the DOM, get elements by class name. What is the class name that we're getting? Fruits. Let's console.log fruits, just to see what it is. What are we working with? So fruits is an HTML collection. My collection contains these 3 elements. We have 3 objects within this HTML collection. If I was to take a look at some of these properties, we should have text content. So for the first element, we have text content of apple. For the next div element, which has an index of 1, the text content is orange. We can assume that the next element has text content of banana. To change something about one of these elements, let's begin with the first element. We have an HTML collection of fruits. To select one of these elements, you'll use an index. So let's take our HTML collection of fruits at index 0. That's going to return the first element, our div element of apple. I will access its style, access its background color, set it equal to be yellow as if we're highlighting it. There we are, apple. It's highlighted. For the next element, I will increase the index to 1. That will select our orange, and then 2 would be banana. If I would like to iterate over all of these elements, I can use an enhanced for loop. We'll say let fruit of fruits. HTML collections are iterable. We can iterate them with an enhanced for loop. Let's take each fruit, access its style, access its background color, then set it to be yellow. And that should highlight all of them. Now, HTML collections don't have a built-in forEach method. HTML collections do allow for live updates, but unfortunately they have a limited amount of utility methods. If I attempt to use our HTML collection of fruits, then attempt to use a forEach method, here's what happens. We have a type error. Fruits.forEach is not a function. HTML collections don't have a forEach method. We're not able to use that. What we could do is typecast our HTML collection as an array. Let's access the class of array, then use the from method. This will return a new array of fruits. We'll typecast our HTML collection as an array. Then you could follow this with the forEach method if you so choose. For each element within our array, after typecasting it, let's take each fruit. I'll use an arrow function. What would we like to do? Let's take each fruit, access its style, access its background color, then set it to be yellow as if we're highlighting it. And that does work. getElementsByClassName will return an HTML collection of all matching elements that share this class. If you would like to use array methods with this HTML collection, you would want to typecast it to an array. Alright, now we have getElementsByTagName. Within our HTML document, we'll create 2 unordered lists. I will create an h4 heading of root vegetables. We scroll down. I will create an unordered list with a few list items. 3 should be good. For my first list item, that will be beets. Beets are a root vegetable. Carrots. And potatoes. Let's copy our unordered list and our h4 heading, paste it, change the second h4 heading to be non-root vegetables. My first list item within this other list will be broccoli, celery, and onions. I just picked 3 vegetables kind of at random. With our next method of getElementsByTagName, I can select one of these elements by their tag name. h4, unordered list, list items. Take all matches within our HTML document, stick them all within an HTML collection. I will create const h4 elements equals, we're accessing the DOM, use the getElementsByTagName method. Let's select all h4 elements. Then I will console.log my HTML collection of h4 elements. Let's see what it is. So it looks like this HTML collection has 2 elements. 2 h4 elements. The text content of the first element is root vegetables. Then we can assume that the other element is non-root vegetables. Yes, it is. Non-root vegetables. we can access individual elements of this HTML collection by an index. Let's take this reference of h4 elements, access the first index, access the style, access the background color, set it to be yellow as if we're highlighting it. And that should highlight root vegetables. The next index of 1 would be non-root vegetables. To apply CSS properties to all of the elements, I can use an enhanced for loop. For let h4 element singular of h4 elements plural. Take each h4 element, access its style, access its background color, set it to be yellow. And that will highlight all of the h4 elements. Let's create another HTML collection of all the list item elements. We'll create another reference to all list item elements. So that'll be beets, carrots, potatoes, broccoli, celery, and onions. Const li elements equals document.get elements by tag name. The tag that we're selecting is all list item elements. So using a for loop, let's iterate through them. Let li element singular of li elements plural. For each list item element, access the style, access the background color, then set it to be a different color. Let's say light green. And now all list item elements will be a light green color. And again, since these are HTML collections, not arrays, they don't have any array methods, but we can typecast them so that they do. If I wanted to change the background color of these with the forEach method of arrays, I'm going to typecast our HTML collection of h4 elements as an array. I will access the class of array, use the from method, pass our HTML collection of h4 elements as an argument. If I wanted to use the forEach loop, I can method chain. Follow this with forEach. What do we want to do for each of these elements? Take each h4 element, use an arrow function, do this. Take each h4 element, access its style, access its background color, set it to be yellow. And that does work. So let's do this with our list item elements. I'll just copy this because I'm lazy. We'll typecast our list item elements HTML collection for each list item element, take each list item element, access its style, access its background color, set it to be light green. And that does work too. That is the get elements by tag name selector. It will select all elements with a matching tag name throughout your document. It returns an HTML collection. Now we're going to talk about query selector. Query selector will return the first matching element, or null if it doesn't find any matches. I will create a const of element equals document dot query selector. Query selector will return the first match. To select an element by a class name, we'll use dot, the name of the class. These three elements have a class of fruits. Let's select that, dot fruits. If I was to take this element, access its style, access its background color, set it to be yellow, which element do you think is going to be selected? The first, apple. It's the first matching element. Query selector only returns a single element, the first match. If I selected a tag name of h4, that would select root vegetables. Even though we have two h4 elements, the first match is selected. If I selected the first list item element, that would select beets. That is the first list item element on my web page. If I changed this to UL, meaning unordered list, it would select the first unordered list. If I attempt to select something that doesn't exist, like any ordered lists, well, they don't exist. There's no matches. If I was to console.log my element, it would return null. There's no matches. So query selector selects the first matching element or null. You can select a class or a tag name. Then the last method we'll discuss is query selector all. This returns a node list. A node list is similar to an HTML collection, except it has built-in methods, similar to arrays. However, node lists are static. HTML collections are live. Since node lists are static, they do not update automatically in the DOM. HTML collections are live, they will. I'm going to select all elements that have a class of fruits. I'll create a reference to this. Const fruits equals document.querySelectorAll. We are getting a class of fruits. I can access this node list by an index number. Let's select the first element, access the style, access the background color, set it to be yellow. And that will select apple. Let's select the next element. That's orange. The next would be banana. Let's select all list item elements. I'm going to rename this though. Let's rename fruits as foods. Let's select the first element. That would be beets. The next element would be carrots, then potatoes, broccoli, celery, onions. So if I was to console.log foods, this would give me a node list with 6 elements. Node lists do have a built-in forEach method. Let's use that. We don't need to typecast it as an array. Take our node list of foods, use the built-in forEach method. What do we want to do? Take each food, use an arrow function, do this. Take each food, access its style, access its background color, set it to be yellow. This will take all list item elements, change the background color to yellow as if we're highlighting them. Alright everybody, so those are different element selectors. Get element by ID, get elements by class name, get elements by tag name, query selector, and query selector all. There is a lot of overlap where you could select any number of these to select something, but they each return something different. Personally, I like using a combination of get element by ID and query selector all, but that's just my personal preference. In conclusion, element selectors are methods used to target and manipulate HTML elements. They allow you to select one or more multiple HTML elements from the DOM. Once you select your element or elements, you can make any sort of changes that you would like. And well everybody, those are element selectors in JavaScript. Yo, what's going on people? So today I gotta explain DOM navigation in JavaScript. DOM navigation is the process of navigating through the structure of an HTML document using JavaScript. HTML elements include, but are not limited to, the following properties for DOM navigation. We can get the first child, the last child, the next sibling, the previous sibling, a parent, or all the children of an element. So for this exercise, within our HTML document, we're going to create a few unordered lists. Of course, these unordered lists are going to be for food, because I like food. The first unordered list will have an ID of fruits. Let's create a few list item elements. An apple, an orange, and a banana. We'll need a few unordered lists to work with. Let's copy this unordered list and paste it twice. The second list will be for vegetables. Pick some vegetables. I'll pick carrots, onions, potatoes. The third unordered list will be for desserts. I'll pick cake, pie, ice cream. That is good enough for now. Heading back to our JavaScript file, I will now discuss the property of first element child. Our unordered lists are elements. They each have their own children. A child element is any element found within this element. Our unordered list of fruits has 3 children, apple, orange, banana. Vegetables has 3 children, carrots, onions, potatoes. Desserts has 3 children as well, cake, pie, and ice cream. Let's say that our unordered list of fruits is a parent. Well, apple would be the firstborn, orange would be the middle child, and banana would be the lastborn, if these were actual children. So think of it that way. So I'm going to create a constant of element. I'll be using this as a reference. Document.getElementById, I will get that unordered list of fruits. I'm storing this unordered list within this element. I will create a reference for the first child equals, take our element, access the first element child. If I was to take this element, change its style, access its background color, set it to be yellow, which element is going to be highlighted? Apple. If I selected a different element, like my ID of vegetables, the first child would be carrots. Then desserts. The first element child of desserts is cake. They are the firstborn children. They're at the top within these unordered lists. If you used query selector all, I'll give you a demonstration. I will select all unordered lists. Const ul elements equals document dot query selector all. Select all unordered lists. This will return a node list. Node lists do have their own built-in forEach method. Take all ul elements, use the built-in forEach method. What do we want to do? Iterate over every unordered list element. Do this. Let's create a reference to the first child equals, take our unordered list element, access its first element child, then store it as a reference. Let's take our first child, access its style, access its background color property, set it to be yellow. That will highlight all of the first element children of all the unordered lists. So that's how you can use query selector all to select all of the first children of all matching elements. Now we're going to access last element child. With our unordered lists, if we're selecting our elements of fruits, vegetables, and desserts, this would return the last child, banana, potatoes, or ice cream, depending on what we're selecting. If these were actual children, these 3 elements are the last born. They're the youngest. I'm going to create a reference to an element equals access the DOM get element by ID. I will get my ID of fruits. I will create a reference to the last child equals, take our element, get the last element child. Take our last child element, access its style, access its background color, set it to be yellow. So that will highlight banana. If I change the selected element to vegetables, that would select potatoes. If I selected desserts, that would select ice cream. They are the last element children found within each of these elements. If I were to use query selector all to select all unordered lists, let's create const ul elements equals document dot query selector all. Select all unordered elements. This returns a node list. They have their own built-in forEach method. Take our node list of unordered elements, use the built-in forEach method. Take each unordered list element, use an arrow function to do this. I will create a reference to the last child equals, take each unordered list element, access the last element child. Take the last child during each iteration, access its style, access its background color, set it to be yellow. And that will select banana, potatoes, and ice cream. Select all unordered lists, take each of their last children, change the background color to be yellow. So that is the last element child property. In this next example, I'll demonstrate next element sibling, but we're going to make a few changes. Going back to our HTML file, we will give each of these list items a unique ID. So let's start with the first. The ID will be Apple for the first list item element. I'll copy this ID for each of these elements, and then change them in a moment. So we have apple, followed by orange, banana, carrots, onions, potatoes, cake, pie, then ice cream. If I'm selecting my unordered list of fruits, apple, orange, banana are the children. They are all siblings to each other. If I were to select apple, then get the next sibling, that would be orange. If I select carrots, the next sibling would be onions. If I selected cake, the next sibling would be pie. So let's create a constant of element equals document.get element by ID. The ID that I'm going to select is apple. I will create a reference to the next sibling equals take our element, access its next element sibling. Take our next sibling, access its style, access its background color, set it to be yellow. If I'm selecting apple, the next sibling to that would be orange. If I were to select orange, the next sibling would be banana. If I were to select banana, well, banana doesn't have a next sibling. It's the last in line. We wouldn't be selecting anything. There is no next sibling for banana. If I were to select carrots, the next sibling is onions. If I selected onions, the next sibling is potatoes. If I selected cake, the next sibling is pie. If I selected pie, the next sibling is ice cream. What if I selected fruits, vegetables, or desserts? What would be highlighted? I will select the ID of fruits. That would highlight my unordered list of fruits. These three unordered lists of fruits, vegetables, and desserts, they're all children of the body. They're all siblings to one another. It's kind of like if the list item elements of apple through ice cream are all children, the unordered lists of fruits, vegetables, and desserts are the parents, and the body is the grandparent. If I select the unordered list of fruits, the next sibling would be vegetables. By accessing the next element sibling of my unordered list of fruits, that selects my unordered list of vegetables. If I selected vegetables, then get its next sibling, that would give me this unordered list of desserts. Alright, then we have previous element sibling. If I select an element, we'll get the previous element sibling. So if I were to select orange, that would give me apple. If I selected banana, that would give me orange. If I selected onions, that would give me carrots. I will create a constant for element equals document.get element by ID. I will select orange. Const prev, meaning previous, sibling equals take our element, access the previous element sibling. If I were to take my previous sibling, access its style, access its background color, set it to be yellow, the previous sibling of orange is apple. The previous sibling of banana is orange. If I selected onions, the previous sibling is carrots. The previous sibling of potatoes is onions. The previous sibling of pie is cake. The previous sibling of ice cream is pie. If I selected the first sibling, then attempt to get the previous sibling, well, we don't select anything. The previous sibling of a first child doesn't exist. If I selected the previous sibling of my unordered list of vegetables, that would select my unordered list of fruits. If I selected the unordered list of desserts, that would give me vegetables. Now we have the parent element property. Whichever element I select will get the parent. The parent is the element that contains it. Const element equals document.get element by ID. I will select apple. Const parent equals access our element, access the parent element. Let's take our parent, access its style, access its background color, set it to be yellow. That will highlight my unordered list of fruits. If I selected orange, well, that wouldn't change. The parent is still fruits. Same thing goes with banana. If I selected carrots, well, the parent is vegetables, that unordered list. If I selected ice cream, well, the parent is desserts. So that's how to get the parent of an element. You can access the parent element property. The last property we'll discuss is children. We can return all of the children of a selected element. I will create a const element equals document.get element by ID. I will select my ID of fruits. I would like all children of this element. I'll create a reference to children equals take our element, access the children property. If I was to console.log children, this is what we're working with. By accessing the children of an element, that returns an HTML collection. This HTML collection has 3 list item elements. HTML collections don't have a built-in forEach method. I would need to typecast it as an array using the from method of arrays. Let's take all of our children, convert it to an array, then method chain the forEach method. Let's take each child from children, then do this. Take each child during each iteration, access its style, access its background color, set it to be yellow. So this will highlight all children of a selected element, apple, orange, then banana. If I selected vegetables, that would highlight carrots, onions, potatoes. If I selected desserts, that would highlight cake, pie, then ice cream. You can even access these children by an index number. Let's say you would like to highlight a middle sibling, orange, onions, or pie. Let's take our children, it's an HTML collection, access it by an index number. So let's access children at index 1 of desserts. That would highlight pie. Let's select vegetables. That would highlight onions. Then fruits would highlight orange. All right, everybody, so that is an introduction to DOM navigation. It's the process of navigating through the structure of an HTML document using JavaScript. There are several different properties that you can use to navigate through HTML elements. And well, everybody, that is an introduction to DOM navigation in JavaScript. Hey everybody, in today's video I'm going to show you how we can add and change HTML elements using JavaScript. So sit back, relax, and enjoy the show. I'll break down creating and appending elements to the DOM in 3 simple steps. We'll create the element, add any necessary attributes or properties, and then append the element to the DOM will be the final step. But before we do begin, within our HTML file, we'll create a few boxes for this exercise. These will be div elements with an inner paragraph. The first will have text of box 1. With this div element, I will give it an ID of box 1 and a class of box. Let's copy this div element, paste it 3 times for a total of 4 boxes. We'll create box 2, box 3, and box 4. I'll apply the following CSS properties. We're selecting the box class, add a border of 3 pixels solid, set a width to be 100%, and a height of 125 pixels. And we are ready to begin. Step 1, we need to create the element in order to work with it, right? I will create a constant of new h1. h1 equals, we will select our document, use the create element method, then as a string, pass in the type of the element we would like to create. We'll create an h1 element. We now have an h1 element to work with, which we're referencing as new h1. Let's add some attributes and CSS properties. Let's do one for now. I will take my new h1 element, access its text content, set it equal to I like pizza. And then we just have to append this element to the DOM. To do that, we will access our DOM with document. What element would we like to select? Let's select the body element of our document. And then we will use the append method. Pass in our HTML element as an argument. And there we go. There's our h1 element. When you append an element to a parent, this new element is the last child. You could prepend if you would like it to be the first child. So let's use the prepend method. Change append to prepend. And it's now at the beginning. Let's add an additional attribute. We will take our new h1 element, set the ID attribute equal to my h1. And let's see if that worked. I will right-click on this element, inspect it. Here's our h1 element. It's the first child because we're prepending it. This h1 element has an ID attribute set to my h1. Let's change the CSS properties of this element. I will access new h1, access its style, access its color, the font color. Let's set it to be red. But better yet, let's set the color to be tomato because I like tomatoes. I think that's a better looking shade of red. Let's also center the text. New h1, access its style, access the text align property, set it to be center. And the text is now centered. When I append this element, I would like to append it to within box 1. I will select box 1 as the parent, rather than the body. We will access our document. We need to select an element. We will select box 1. We could use document.get element by ID. The ID that I'm going to select is box 1. I will then follow this with append. Append our new h1 element. So our h1 element is now within box 1, and not outside of it like it was previously. I could append this h1 element to box 2, but I would have to select it. We will get element by ID, select box 2 to put it within box 2, box 3, and box 4. When I'm appending this element to box 1, it is the last child of box 1. If there are any child elements within this box, which there is, we have a paragraph element, that h1 element will come after, and not before. So if you would like this h1 element to be the first child, we can prepend it. I'm going to copy this because I don't want to rewrite it. We will prepend. Prepend my new h1 element, take box 1, prepend the new h1 element. So my h1 element is now at the top. It's the first child. The paragraph element comes after. Let's do this with box 2, box 3, and box 4. What if we would like to take our h1 element and sandwich it between box 1 and box 2? I could select box 2 and insert that new h1 element before it. Here's how. I will create a reference to box 2 equals document.get element by ID. We will select the ID of box 2, access our document, access the body, because box 2 is a child element of the body. Use the insert before method. There's two arguments, the new element and the current element. The new element is going to be new h1. That's what we're trying to add. The current element is the target we're selecting, box 2. Insert the new h1 element before box 2. And this is what that looks like. This h1 element is now between box 1 and box 2. Take the new h1 element, insert it before box 2. If we were to do this with box 1, well then it's going to be before box 1. Let's try this with box 3. Our h1 element is before box 3 and box 4. What if these elements don't have IDs? How do we select them then? Here's how. We will use query selector all to select everything that has the box class. I will create a constant of boxes. This will be a node list. Access our document, use query selector all. Select everything that has a box class. We will use the insert before method. Access our document, access the body, insert before. We have the new element to add and the current element. The new element is new h1. The current element is our node list of boxes. We can access a specific element from this node list with an index. If I accessed boxes at index 0, that would give me box 1. Boxes at index 1, that's referring to box 2. Box 3, and box 4. So you could use query selector to select many elements, store it within a node list, then select those specific elements with an index number. This is optional, but at any time if you need to remove an HTML element, here's how. Let's append our new h1 element. We need to select the location in which we can find that element. It's within the body of our document. Document dot body, use the remove child method. We will remove our new h1 element. And it's gone. What if this h1 element was within box 1? Alright, I will append our new h1 element to box 1. And we need to add the IDs back to these boxes because I forgot to do that. We're appending our new h1 element to box 1. When I try and remove it, it doesn't work. It's still there. We need to select box 1 and not the body of our document, because box 1 is the direct parent of our h1 element, not the body. The body in this case could be like the grandparent. Instead of selecting our body, we will get the ID of box 1, or some other element selector to get box 1. I'll use getElement by ID because it's easy. Get element by ID. The ID that I'm selecting is box 1. Remove the new h1 element that's found within it, and it's gone. If at any time you need to remove an element, select the parent of that element, then follow it with the remove child method. Pass in the element you're trying to remove as an argument. In this last example, we're going to work with ordered lists. So going to our HTML file, we will create an ordered list with a pair of OL tags. I will give this ordered list an ID of fruits. We'll add a few list items. The first list item will be for an apple. The ID will be apple. We'll create a list item element for an orange. ID will be orange. And a banana. ID, banana. I'll add a little bit of CSS styling. Going to the CSS style sheet, I will select the ID of fruits. I'll add a border of 3 pixels solid for this demonstration, and increase the font size to 2 rem. All right, and that's what we need to work with. We'll now be creating a list item element. I will create a constant of new list item equals document dot create element. What is the type of element we're trying to create? A list item element. Let's set any attributes or properties. That's step 2. Let's take our new list item, set the text content to equal coconut. We'll append this element. If I were to append this new list item to the body of my document, it's the last child of the body, We're not adding it to this ordered list. Now that we can see it, I'm going to add a few more attributes and properties. Let's take our new list item, access its ID attribute, set it to be coconut. Let's change the font weight. New list item, access the style, access the font weight, set it to be bold. And the background color, access the style, access the background color. I'll set the background color to be light green. We have our list item element. If I append it to the body, it's now the last child of the body of my document, not this ordered list found within the body. If I were to prepend it, this is what would happen. Prepend the new list item. It's now the first child. Now we'll select our ordered list of fruits. Get element by ID, fruits, append the new list item. And it's now at the end at number 4. Let's prepend to the ordered list. Get element by ID, fruits, prepend our new list item. Our coconut is now at number 1. How can we insert our coconut between apple and orange? Here's how. Since these list item elements have an ID, I could use that. Let's get the ID of orange. Const orange, get element by ID, orange. Instead of selecting the body, we're going to select the ordered list that has an ID of fruits. Document.get element by ID. The ID that I'm selecting is fruits. Select the ordered list of fruits. Insert the new list item before the orange. Our coconut is now at number 2. Let's insert the coconut before the banana. The ID was banana. Const banana. Insert the new list item before the banana. Our coconut is now at number 3. You could insert before apple too. I will get the ID of apple. Const apple. Insert the new list item before the apple. And it's back at the beginning. What if these list items don't have IDs? Let's eliminate those. We would need to use query selector to select all list items from the ordered list of fruits. So I'm going to use query selector all. Select the ID of fruits. Then select any list item descendants within this ID. This will return a node list that stores all of the current list items within this ordered list. We need to select our ordered list of fruits, not the body. Document.get element by ID. I will select our ordered list of fruits. Insert the new list item before list items at index 0. That will insert the coconut before the apple. Let's increment our index to 1. Our coconut is now before the orange. Now it's before the banana. And now it's after the banana. If I need to remove this list item, I would need to select it first. So let's append the new list item to fruits. I will get the ID of the ordered list of fruits. Remove the child of new list item. And it's now gone. Alright everybody, so that is how we can add, change, and remove HTML elements using JavaScript. Hey everybody, in today's video I gotta explain mouse events in JavaScript, so sit back, relax, and enjoy the show. The first thing I need to discuss is event listeners. An event listener listens for specific events to create interactive web pages. A few types of events we'll discuss are click events, when we click on something, mouse over is when we hover over something, and mouse out is when we're hovering over something, and then leave that element. To add an event listener, you'll use the add event listener method. Pass in an event type, including but not limited to. This could be clicking on something, hovering over something, or leaving the confines of an element, and then a callback to a function. What do you want to do when you interact with something? For example, I could use the click event and then change the color of something when I click on it. Going to our HTML file, I will create a div element for a box. The ID of this div element will be my box. The text on the box will be click me. Then for fun, I'll add an emoji because I like emojis. Let's apply some CSS styling because it's kind of small. Let's select the ID of my box, change the background color to light green or some other color of your choosing, set a width of 300 pixels, a height of 300 pixels. I'll increase the font size to something large like 4.5 rem. I'll set the font weight to be bold. I'll use flexbox, display flex. Align items in the center, and text align center. That is good enough for now. Be sure to save everything. We're going to select the ID of my box. We'll store that as a constant. Const my box equals, we'll need to select it by accessing the DOM, document.get element by ID. I will select the ID of my box, and then we can work with it easily. We'll take my box, add an event listener. That's a built-in method. myBox.add event listener. We need to pass in an event type and a callback to a function. I want to do something when I click on this box. The event type is going to be click. And now we need a callback to a function. We'll define a function to change the background color. Function change color. There's going to be one parameter, an event. Then we will pass in a callback to change color. Now, the event parameter, event is an object. It's provided to us automatically by the web browser when something happens, when an event occurs, like when I click on something. Event is an object that contains information about something that happens, that event. For this demonstration, temporarily, I'm going to console.log my event. So let's click on the box, then go to inspect, console, and here's my event. When we clicked on that box, the web browser provided us with an event object. It's a pointer event. This object contains details about what happened exactly. For example, we have the target. What did we click on? We clicked on the div element with an ID of my box, and here are all the properties and methods of that box. That's the target. We have a timestamp of when the click occurred, the type of the event, click, which matches up with the event type, and coordinates of where we clicked on the screen. Event is an object that's going to be provided to us through the web browser automatically. We don't need to explicitly pass in an event object with this callback. It's provided to us behind the scenes. I'm going to change the background color of our box when we click on it. We will access our event object that's provided to us, access the target. The target is what we clicked on. There's information about our target within the event object. Then I will take the style of the target, set the background color property to be a different color. I will set it to be red, but I prefer the shade of tomato because I like that color. Now when I click on the box, the background color changes. But why stop there? Let's also change the text content. I'll add one more statement to the change color function. Again, we will access our event, access its target, access the text content of the target to be ouch. And then I'll add an emoji. That's a good one. When I click on this box, not only does the color change, but the text too. Now, you don't necessarily need to pass in a callback. You can also pass in an anonymous function or even an arrow function. So let's copy these two lines of code. We'll reuse it later. We no longer need to define a function. Within the event listener, instead of passing in a callback, we'll pass in an anonymous function. We have one parameter, an event. That's going to be provided to us. When we click on my box, do this. Change the background color and the text. Now, we could even use an arrow function. I have a preference for arrow functions because they're concise with their syntax. With an arrow function, we have one parameter, an event. If you have a single parameter, you don't need to enclose it within a set of parentheses. We have one parameter of event, then do this. Do all this code. And that should still work. When I click on the box, the color changes, as well as the text. So when you add an event listener, you can pass in a callback, or an anonymous function, or an arrow function. It depends on what your preferences are. Personally, I like arrow functions. We have a few other mouse events to discuss. Mouse over and mouse out. Mouse over is when you hover your cursor over something. So let's take my box, add a new event listener. An element can have more than one event listener. Add event listener. We have an event and a callback as arguments. The event is going to be mouse over. For the callback, I'll use an arrow function. We have one parameter of event, arrow, do this. Let's copy these 2 lines of code. I'll change the background color to be yellow, like it's a warning, and the text content to be, don't do it. That's a good face. When I hover my cursor over this element, the background color and the text is going to change. The event that occurred is mouse over. It's when you hover your cursor over something. Mouse out is when you leave a specified element. So when I leave the box, I would like to change back the background color and the text content. We'll add an additional event listener. My box, add event listener. The event type is going to be mouse out. Then I'll write an arrow function. We're provided with an event, arrow, do this. Let's change the background color and the text content. I will revert the background color to be light green. And the text to be click me. Whatever the text content originally was. When I hover my cursor over this element, we get that mouse over event. But when I leave, we get the mouse out event. When I click on this box, we get the click event. When I leave the box, we get the mouse out event again to reset it, essentially. For the last part of this demonstration, we're going to create a button. When we click or interact with the button, then we'll change a separate element, this box. So within our HTML file, let's create a button with text of click me. I will give this button a unique ID of my button, and I'll increase the font size with CSS. We will select my button. I will increase the font size to be 3 rem, just so it's not so small. Let's select the ID of my button. Const my button equals document.getElementById my button. I'll add the event listener to my button, not my box. If I was to interact with this button with the way it is now, when I hover over the button, we've created a mouse over event, and the button changes. When I click on the button, we're changing the HTML and CSS of the button. Because the button is what has the event listener, we're selecting the target of the event to change, which is the button. That is what we interacted with. When we interact with our box, it doesn't do anything. It doesn't have any event listeners. The button does, though. We're going to replace the event target with my box. When we interact with the button, change the background color and the text content of my box. So then, when I hover over the button, the box changes. When I leave, it reverts back to normal. When I click on the button, then we've created a click event. Alright everybody, so that is an introduction to mouse-related events. You'll need to add an event listener. An event listener listens for specific events to create interactive web pages. A few events we've covered include click, mouse over, and mouse out. To add an event listener, take an element, use the built-in add event listener method, pass in an event type, and a callback, anonymous function, or an arrow function to do something. And well everybody, those are mouse-related events in JavaScript. Hey, what's going on, everybody? In today's video, I'm going to give you an introduction to key events in JavaScript. So sit back, relax, and enjoy the show. So what we've discussed in the previous topic is event listeners. An event listener can be added to an HTML element. They will listen for specific events to create interactive web pages. We'll be discussing key down and key up. There is a third type of key event called key press. However, according to the official documentation, this event isn't compatible with all web browsers, so you should avoid using key press. A key down event occurs when you press down on a key. A key up event occurs when you release a key. By adding an event listener to the DOM document, we can detect when we press down or release a key. Here's how. We will access our DOM, then add an event listener. Add event listener. We have two arguments, the event type and a callback. When we press down on a key, let's do something. Doesn't matter what key it is, any key. For this next argument, I can either pass in a callback, an anonymous function, or an arrow function. I like arrow functions, so I'm going to use an arrow function. We're provided with an event parameter. When something happens within our web browser, an event object is created. We can access it. So I'm going to console.log this event object, and we'll see the details of it. Be sure to select your web browser. I'm going to press the Q key. Then let's go to Inspect, Console, and here's that event. The web browser provided us with a keyboard event. The key pressed was Q. There's a relevant key code of 81, and there's other properties too, like, was the Alt key being held down at the time? It wasn't. Same thing with the Shift key. And the target, which is the body of our document. I'm going to output the key property of the event. We'll press a different key. I'm going to hold down the F key. I'm not releasing it, I'm holding it down. We're going to consistently fire key down events. I would like to detect when I release a key. I will use the key up event. So let's copy this, paste it. The event is going to be key up. I'll display something else. I'm going to use a template string. I will display key down equals, then I will display this event's key. Let's do this with key up too. I'll just copy this. Key up equals event.key. Let's go back to our console. I'm going to hold down the S key. Then when I release it, we'll have a key up event. Key up equals S. Oh, one more important thing. The arrow keys. We have arrow up, arrow down, arrow left, and arrow right. If you ever would like to make some sort of game, the arrow keys are also accessible. Now what we'll do on key down and key up is change an HTML element. So to make this simple, within our HTML document, I'm going to create a div element. This div element will have an ID of my box. I'll add some text, an emoji. All right, let's add a little bit of CSS. We will select my box. I will set the background color to be light blue. We haven't picked light blue yet. I will set a width of 200 pixels, a height of 200 pixels, a font size of 7.5 rem. I'll use Flexbox, display flex, justify content center, align item center. This part's important for the next exercise. We are going to set the position to relative. For relative positioning, I'll set the body of my document to have no margin. Margin 0. All right, we are ready. We are going to select the ID of my box. Const my box equals document.get element by ID. The ID that I'm going to select is my box. When I press a key down, I'm going to change the text content of my box. My box.text content equals, I'll pick a different emoji. Let's do that one. And I'll change the CSS. My box dot style dot background color equals tomato, or some other color of your choosing. So when I press down on any key, the HTML and CSS is going to change. I'm going to release that key, but we don't revert back to normal. Our HTML element stays that way. What we'll do is that when we release a key, we'll revert these changes by going back to the original. So let's take my box, change the text content to equal an emoji because I like emojis. We'll use the original one. Then I will set the background color to be light blue. Now, if I were to hold down a button, the HTML and CSS is going to change until I release that button, which I am about to now in 3, 2, 1, go. I'm going to try and press the spacebar as fast as I can. Seizure warning. Let's go! Okay, it's about time we move on. What we're going to do now is, using the arrow keys, move this element. We're going to create a const of move amount. When pressing an arrow key, how far do we want to move this element? Let's say 10 for 10 pixels. I will create a variable for x. Think of these as coordinates. I will set that to be 0, and y. Y will also be 0. X for any horizontal movement, and y for any vertical movement. Document.add event listener. When we have a key down event, I would like to do something. I'll write an arrow function. We're provided with an event. Do all this code. I only want to do something if a user uses an arrow key. So if I was to console.log my event, then access the key property, let's go to inspect, console, select your document. I would like to do something only if the key pressed is arrow up, arrow down, arrow left, or arrow right. I don't want any of the other keys. I can write this if statement. If access our event, access its key, follow this with the starts with method. Does this key start with arrow? We'll only enter this if statement if the key of the event is arrow up, arrow down, arrow left, or arrow right. Then we'll write a switch. We haven't written any switches for a while. We will examine the key of our event. With switches, we examine a value against matching cases. If we have a case of arrow up, if the key of our event matches the case of arrow up, then do this. We'll take our y coordinate, subtract our movement amount, which is 10. Y minus equals the movement amount. And then be sure to break out of the switch. Then we need a case for arrow down, y plus equals our movement amount, arrow left, x for the horizontal axis, minus equals the movement amount, and then arrow right, x plus equals the movement amount. Then outside of the switch, but within our if statement, we're going to access my box, access the style, access the top property, set it equal to a template string. We're going to take our variable of y for the y coordinate, then add pixels. Take the top property of my box, set it equal to the y coordinate. We're going to copy this and do this with the left property. Set it equal to x in pixels. Be sure to select the body of your document. We can move right with the right arrow key, down, left, and up. Or diagonal if I hit 2 keys at once. The arrow keys have a default behavior to scroll. You can see that if we go down too far, we have a scroll bar on the right-hand side. We can prevent the default behavior of a key. We just have to add this line of code. Take our event, then follow it with the prevent default method. So when my element scrolls off screen, it'll disappear. We're not going to scroll with it. To increase the distance in which this element moves, we can increase the move amount. Let's set it to be 100. Now we're moving a lot further with each key press. Hey, this is Bro from the future. There's one more thing I would like to add to this project. When pressing down on a key, let's change the text content and the background color, much like what we did with the first exercise. Then when we release a key, we'll revert the HTML and the CSS back to normal. We're combining the first exercise and the second one. And this is the result. When I move the arrow keys, this guy's gonna freak out until I let go. Pretty exciting. All right, everybody, so that is an introduction to key events in JavaScript. You're going to add an event listener to the document. When you select your document and press a key, when the key is pressed down, that will create a key down event. When you release a key, that creates a key up event. And well, everybody, that is an introduction to key events in JavaScript. Hey everybody, in today's video I'm going to show you how we can show and hide an HTML element using JavaScript. In this video, you'll need an image to work with. Once you find your image, add it to your website folder. Then we are ready to begin. We're going to create a button and an image element. Let's start with the button. The text on the button will be initially hide, to hide an element. I will give this button a unique ID of my button. I'll add a break, then we'll create an image element. This is a self-closing tag. With this image, I will set the source equal to either the relative file path or the file name. So my file is car.jpg. It's a little too big. I'll set the width attribute to be like 400 pixels. That's a decent size. I will give this image a unique ID of my image, my img, and just so we can see this button, I'm going to apply a little bit of CSS to the button. Let's select the ID of my button, take the font size. I will set it to be 2rem. That's decent enough. Alright, let's go to our JavaScript file. I'm going to create a reference to my button and my image. Let's start with the button. Const my button equals document.get element by ID. The ID that I'm selecting is my button. Let's create a reference to my image as well. My img. The ID was my img. When I click on this button, I would like to do something. We will take my button and add an event listener. Add event listener. There are two arguments, an event type and a callback to a function. The event type is going to be click. When we click on the button, we're going to do something. For the callback, we'll write an arrow function. We are provided with an event parameter by the web browser. Arrow, do this. When we click on the button, what code do we want to perform? We're going to take my image, access its style, access its display property, set it to be a string of none. So when you click on the button, it's going to hide the image. The display property is set to none. Not only that, let's change the text on the button after we hide the element. Let's take my button, change the text content equal to be show, because now I want to show the element. So hide becomes show. When we click on the button a second time, nothing happens. We would like to toggle between hiding and displaying this element. We'll write an if statement. Let's check to see if the display of my image is strictly equal to none. Is the display of my image currently none? If so, we're going to set the display to block, because it's a block level element. Take my image, access its style, access its display property, set it to be block. Then within an else statement, place these two lines of code. and we will change the text content of my button to be hide. Now, when clicking the button, we can toggle between hiding and showing this element, the image. Now let me demonstrate something. If we were to take my button, then add it after the image, here's what would happen. Let me add a break too. So by setting the display to none, we don't reserve any space for that image. My button moves up near the top of the window until I show it again. Another option, if we would like to reserve some space for the image, is to toggle the visibility, not the display property. Replace display with visibility. We're going to check if the visibility is hidden. Set the visibility equal to be hidden. If we would like to show the image, the visibility is going to be set to visible. When we toggle the visibility of this image, we at least reserve the space for it. The elements that come after aren't going to shift near the top of the window. You can use visibility or display depending on the project you're creating. Alright everybody, so that is how to show and hide HTML elements using JavaScript. So, yeah, I should probably talk about node lists today. A node list in JavaScript is a static collection of HTML elements. They can be created by using query selector all. We can select elements by an ID, a class, or an element type. Node lists are similar to an array, but they don't have a built-in map, filter, or reduce method. They do have a forEach method at least though. An important thing to note with node lists is that they won't update automatically to reflect changes to the DOM. For example, if you were to remove an element from the DOM and it's within a node list, you would also have to separately remove that element from the node list. So what we'll do in this example is create 4 buttons. They'll all have the same class. We'll have button 1 with a class of, I don't know, what's a good name? My buttons, the class. Alright, let's copy this button, paste it 3 additional times. We'll have button 2, button 3, button 4. And I'm going to add a little bit of CSS to these buttons. Let's select the class of my buttons. I'll increase the font size so you can see it. Font size for REM. Add a little bit of margin, 10 pixels. Remove the border, border none. Smooth the corners with border radius, 5 pixels. Add some padding, 10 pixels by 15 pixels. I'll change the background color to something blue. Background color blue, but I'll select HSL values. I'll turn the lightness to like 60. Okay, that's decent. And the font color will be white. Okay, that's good enough for now. One way in which we can create a node list is by using query selector all. We've talked about this in a previous video, but I'll show you a few more advanced things we can do with node lists. We can select elements by an ID, a class, or an element type. We will create a node list of let buttons equals document dot query selector all. Let's select all elements by a class. We need to use dot, then the class name, my buttons. We could select elements by an element type. If I would like to select all buttons, I would just type in button, the element type. But I would like to select only elements by this class. Now that we have our node list, I am going to console.log my node list of buttons, and we'll take a look at it. Here's my node list. It contains 4 elements. Button 1, button 2, button 3, button 4. We do have a length property, a few methods, entries, forEach, item, keys. These are all different methods. ForEach is what we're going to be using a lot. Here's how we can change the HTML and CSS properties of all elements within a node list. We can use the forEach method of a node list and iterate through all of the elements. So we will take our node list of buttons, use the built-in forEach method, then write an arrow function. We are provided with an element, arrow, do something, but I'm going to rename element as button, just so it's more easily understandable. During each iteration, we're provided with the current button. What would we like to do to that button? Well, let's change the background color, button.style.background color. I'll set it to be green. That should update the color of all the buttons, not just one of them. We're iterating through all of the buttons within this node list, change all of their background colors to be green. Let's change the text content too. Take each button, access the text content. I will set it equal to be, I don't know, an emoji or something. Let's do that. The text content on all the buttons is going to change. Maybe let's append an emoji, not replace the text content. That's better. That is how you can add and change HTML and CSS properties with a node list. Use the forEach method, then write an arrow function to do something. In a similar way, we're going to add an event listener to each button that will listen for a click. So again, we're going to take our node list of buttons, use the built-in forEach method. For each button, arrow, do this. We need to add an event listener to each button. We will take the parameter of button, add an event listener. Within our event listener, we have an event type and a callback to do something. The event type is going to be click. Instead of a callback, we'll write an arrow function. We are provided with an event, arrow, do this. Event is provided to us through the web browser when something happens. We will access the event object's target, meaning the button that we click on. That's going to be our target. Access the style, access the background color property. Let's set it to be red, or better yet, tomato, because I like tomatoes. Each button has an event listener. It will listen for click events. When we click on a button, the background color is going to change. We're going to add an event listener for mouse over and a mouse out. Let's begin with mouse over. Again, take our node list of buttons, use the forEach method. For each button, arrow, do this. Take that button, add an event listener. With event listeners, we have an event type and a callback. The event type is going to be mouse over. When we hover our cursor over something, what would we like to do? We will write an arrow function. Event, arrow, do this. Let's access the event's target. That should equal our button that we click on. Access the style, access the background color. So with the current color, I'm going to go back to my CSS. I will copy this color, paste it, but make the lightness 10% darker. Now when we hover over one of the buttons, the background color is going to change. I'll set the lightness to like 40% to make it much more apparent. There, that's better. Now when I leave one of these buttons, I need to revert that color back to the original. Really, we can just copy all of this code. Replace mouse over with mouse out. And set the background color back to the original. Each button now has a mouse over and mouse out event listener. Here's how you can add an element to a node list. I will create a new button. Const new button equals document dot create element. What element are we creating? A button. So with creating and appending HTML elements, there's 3 steps. This is step 1. We need to create that element first. Step 2 is to add any necessary attributes or CSS properties. So let's take our new button, change the text content of the button equal to be button 5. I would like to give my new button a class of my buttons. We're going to access the class list property. New button dot class list. When working with an elements class, we work with class list, not class. So the class list equals the class of my buttons. Then we have step 3. Now we have to append this element to the DOM. what is the parent element of this new button going to be? Well, in this case, it's going to be the body of my document. We're going to be adding a new button right here. The parent, the enclosing element, is the body in this case. Access our document, select the body, append, child, new button. And there's button 5. Since we added our class of myButtons, that's why it has all these CSS properties. If I were to remove this line of code, we get the default appearance for a button. I'll talk more about class lists in the next video. There's a lot you can do with them. Now, if I was to console.log my node list of buttons, here's what we have. We have 5 buttons within our DOM, but within our node list, we have 4 buttons. Button 1, 2, 3, 4. Button 5 isn't within this node list. Node lists are a static collection. They won't update automatically to reflect changes to the DOM. Even though button 5 is within the DOM, we would need to manually add it to our node list if we want to work with it. So to do that, we can just use query selector again and select all elements by the class. So let's reassign buttons. Since we're reassigning buttons, that's why I declared buttons with let instead of const, so we're able to reassign it. Because if this was a constant, we couldn't change the elements within it. So buttons equals document dot query selector all. Select all elements by a class. Class my buttons. And then again, let's console.log my node list of buttons. Inspect console, and there we go. Our node list has 5 elements. Button 1, 2, 3, 4, 5. Even if you were to add an element to the DOM, that same element isn't going to be automatically added to your node list. I would recommend using query selector all again, just to update it. Here's how to remove an element from a node list when you click on it. We'll have to give all of these buttons an event listener. They will listen for a click event. When we click on one of these elements, remove it from the DOM and the node list. Here's how. Again, we will take our node list of buttons, use the built-in forEach method. For each button within our node list, do this. Take each button, add an event listener. We are provided with an event type and a callback to a function. The event type that we're listening for is click. The callback is going to be an arrow function. We're provided with an event, arrow, do this. To remove an element from the DOM when you click on it, we will access our event object, access the target, use the built-in remove method to remove it. So let's see if this works currently. Let's remove button 2, 1, 4, 3. So those buttons are gone, but let me show you something. I'm going to console.log my node list of buttons after each click. Even if I were to remove these buttons from the DOM, they're still within the node list. Even after all the buttons are gone, our node list still has 4 buttons. So we do have to update that manually. Here's an easy way how to do that. We're going to use query selector all again. We'll reassign buttons equals document dot query selector all. Select all elements from the DOM that have a class of myButtons. Then, just to see if this works, let's console.log my node list of buttons. Now, when we click on a button, it should be removed from the DOM and the node list. When I remove all the buttons, our node list is then empty. Alright everybody, so that is an introduction to node lists. They're a static collection of HTML elements. They can be created by using query selector all. We can select elements by an ID, a class, or an element type. They're similar to an array, but there's no map, filter, or reduce methods. And do remember that node lists won't update automatically to reflect changes to the DOM. And well everybody, that is an introduction to node lists in JavaScript. Hey everybody, so in today's video I gotta explain class lists in JavaScript. Class list is an element property. It's used to interact with an element's list of classes, meaning CSS classes. By accessing the class list property of an element, we can make reusable classes for many elements across your web page. If I have a CSS class, I can dynamically add, remove, toggle, replace, or check to see if an element contains a certain class. So what we'll do in this example, in our HTML document, is create a button. The button will have text of my button. The ID of this button will be my button. We'll apply a little bit of CSS initially. Let's select the ID of my button. We'll be applying just a few properties. Let's increase the font size to 4 REM. Oh, not 43, 4. Go back. I'll add a little bit of margin of 10 pixels. Remove the border with border none. Border radius to smooth the corners. 5 pixels. And add a little bit of padding. 10 pixels by 15 pixels. That's good enough for now. We're going to create a CSS class of enabled. We won't apply it right away though. We'll apply this class to this button using JavaScript. If an element is enabled, let's change the background color to be something blue. I'm going to use HSL values though. And I will set the font color to be white. So this button doesn't have this class yet. We'll add that in dynamically using JavaScript. We'll create a reference to this button. Const my button will be the name. Then we need to select it. Document.get element by ID. The ID that I'm selecting is my button. To add a class to an element, take that element, my button, access the class list property, follow this with the add method. We will add the name of the class, enabled. And now my button is enabled. We have appended the CSS properties dynamically. So if I were to inspect this element, I'll right-click, inspect. We have added that class of enabled to the element. So my button has an ID and a class of enabled. To remove a class, again, take that element of my button, access the class list. We will use the remove method. We will remove the class of enabled. And it's gone. Let's right-click on the element, inspect. So our class list is empty. We have added and then removed that class of enabled. We're going to create a new class now of hover. When we hover over an element, apply these CSS properties. It's kind of like we're using the hover pseudo class, but we're using it a little bit different. We can add or remove this class dynamically at will. If we apply this class, let's set a box shadow to give the element a 3D pop effect. For a horizontal and vertical offset, let's set those to be 0 each. Let's add 10 pixels for the blur effect. And I will set the color to be, I don't know, let's set it to be black, but set the alpha down to like 20%. And then when I hover, I would also like to set the font weight of that element to be bold. Let's add the hover class. So the appearance of this button changed. I would like to apply this class of hover only when I hover my cursor over the element. We'll add a mouse over event listener. We will take my button, add event listener. We have an event type and a callback to a function. The event type will be mouse over. When we mouse over this element, we are provided with an element object. Event arrow do this. We will access our event object's target, meaning the button, take our class list, and add the class of hover. And let's see if this works. If I hover my cursor over the button, we apply the hover class. Now when I leave the button, I would like to remove it. Really, we can just copy the code for the event listener, paste it, replace mouse over with mouse out. Then we will remove that class. So now we can apply that class and then remove it with mouse over and mouse out. There's also toggle. If we toggle a class, we'll remove it if that class is present, add that class if it's not. So let's replace add with toggle. Do this for both mouse over and mouse out. And that should work the same. When we hover our cursor over the button, we will toggle the class of hover. If we have a mouse out event, we will toggle it again to remove it. Now we're going to use the replace method to replace one class with another. We'll create a new class of disabled. We'll be replacing the enabled class with the disabled class when we click on the button. So with the background color of the disabled class, let's set the background color to be gray. Again, I like using HSL for the colors. I'll set the lightness to be like 60%. I'm trying to get a faded appearance. And for the color, let's pick a light shade of gray using HSL values. I'll set the lightness to be 80%. Going back to our JavaScript file, let's add the class of enabled. My button, access the class list, use the add method, we will add the class of enabled. Then we'll add an event listener to the button. We will take my button, add an event listener. We have an event and a callback. The event is going to be click. I would like to do something when we click on the button. We will receive an event, arrow, do this. Take our events, target, access the class list. We will use the replace method. Replace the old class with the new class. Replace the enabled class with the disabled class. There's two arguments. The old class and the new class. Replace the old class with the new class. Then, when we click on this button, we'll replace the enabled class with the disabled class. Then we have the contains method. If an element contains a class, this will return true, and if it doesn't, it returns false. So within our event listener, let's add an if statement and an else statement. We'll check to see if our events target access the class list. We will use the contains method. If we click on the button and the class contains disabled, what do we want to do? Does the class list contain disabled? Let's change the text content. Take our events, target, access the text, content. I'll append an emoji. What's a good one? That one. Else replace enabled with disabled. Let's click on the button. We'll replace the enabled class with the disabled class. Our button is now disabled. If I were to inspect this element, the class is now disabled. If I were to click on this button again, well, our class contains disabled. That was true. So we end up doing this code, where we append the text content of the button. Now, the nice thing about using class lists, HTML elements have a class list property. We can reuse CSS classes amongst many HTML elements. We'll create an H1 element now. The text of this element will be hello. I will give this element a unique ID of my H1. I'll increase the font size so we can see it. Select the ID of my H1. I'll increase the font size. Let's try 5 REM. Let's create a reference to my H1. Const my H1 equals document dot get element by ID. The ID that I'm selecting is my H1. We'll add the enabled class to my H1 dot class list dot add, not ass, add enabled. And there we go. We have added these CSS properties to this element. And because I'm lazy, I'm going to copy all of this code where we add an event listener to my H1. So let's replace my button with my H1. Now, when we click on this H1 element, we can disable it. We'll replace the enabled class with the disabled class. And if you don't believe me, let's take a look. The class of my H1 is now disabled. If I were to click on this element again, well, the class list contains disabled, so we execute this if statement, where we change the text content of that target. Now here's a challenge round. We're going to create 4 buttons, and store all of those buttons within a node list. So let's create a button, with the text of the first button being button 1. I will give this button a class of my buttons. Let's copy this button, paste it 3 times. Button 1, button 2, button 3, button 4. Let's remove the CSS from my h1, select the class of my buttons. Keep these 3 classes of enabled, hover, and disabled. Okay, let's eliminate all this code. We'll create a node list to contain all these buttons. We can use const if we don't plan on adding or removing buttons, or let if we do. Let buttons equals document dot query selector all. Select all elements that have a class of my buttons. We'll apply our enabled class to all the buttons. So we will take our node list of buttons, use the forEach method. For each button within our node list, do this. Take each button, access each button's class list property. I will add a class of enabled. And we have applied that class to all the buttons. If you need to remove a class, you can do the same, but replace add with remove. Now, when we hover our cursor over one of these buttons, we will toggle the hover class. We need to iterate through our node list of buttons. Take buttons, use the built-in forEach method. For each button within our node list, do this. Take each button, add an event listener. The event listener has an event type and a callback to a function. The event type will be mouse over when we hover our cursor over it. We will be provided with an event argument. Arrow, do this. Access the event object, access the target, meaning the button that we hover over, access the class list property. We will toggle the hover class. So when we hover our cursor over one of these elements, we will apply the hover class. Now when our cursor leaves one of these elements, we would like to toggle that class again. Let's copy everything we have here, paste it, replace mouse over with mouse out. When we leave one of these elements, toggle the hover class again to remove that class. Now when we click on one of the buttons, we're going to replace the enabled class with the disabled class. Take our node list of buttons, use the forEach method. With each button, arrow, do this. Take each button, add an event listener. We need to select the event type and a callback to a function. The event type is going to be click. The parameter is event, arrow, do this. When we click on one of these buttons, we'll replace the enabled class with the disabled class. Take our event object, access its target, access the class list property. We will replace the old class with the new class. Replace the enabled class with the disabled class. And let's see if this works. When I click on a button, we'll replace the enabled class with the disabled class. The last thing we'll do is that when we click on a button that's disabled, we'll change the text content. We'll have to use the contains method. So within our event listener, I'll add an if statement. If access our event, access its target, access the class list property, use the contains method. Does the class list contain the class of disabled? If it does, we'll access our event, access the target of that event, change the text content of that element. I'll append an emoji. That one. I like that emoji. If the class list of that element isn't disabled, it doesn't contain the class of disabled, we'll execute an else statement where we disable it by replacing the enabled class with the disabled class. We have 3 event listeners: mouse over, mouse out, and click. We're utilizing all 3 of these custom classes: enabled, hover, and disabled. We can hover over these elements, then we'll have mouse over and mouse out events. Then when I click on one of these buttons, we can apply that disabled class. Within our click event listener, we have an if statement. If we click on an element that's already disabled, append the text content. Alright everybody, so that is the class list property. It's used to interact with an element's list of classes. They're CSS classes. They allow you to make reusable classes for many elements across your web page. And well everybody, that is the class list property in JavaScript. Hey, what's going on everybody? In today's video, we're going to create a game of rock, paper, scissors using JavaScript. So sit back, relax, and enjoy the show. Alright, let's do this thing. We're going to create an H1 heading with text of rock, paper, scissors for a title. We'll create 3 buttons. The first one will be for rock. You can add some text of rock. But you know what? I like using emojis. I'm going to use an emoji instead. I would like an emoji of a fist. And I'm going to zoom in until we add some CSS. Let's create a button for paper. That'll work. And scissors. Maybe a peace sign. With each of these buttons, I will set the onClick event handler equal to a JavaScript function. We'll name the function playGame. Now, with these functions, we're going to pass in an argument. The first will be a string of rock. Now, if you use double quotes, HTML is going to be confused where this event handler ends. Our argument is going to be a string, but it's going to be within single quotes, because we're already using double quotes. Let's copy this attribute, because I don't feel like typing it again. The second argument will be for a string of paper, and then scissors. Let's enclose our buttons within a div element. This div element will have an ID of choices. Let's cut our buttons and paste them within the div element. Outside of the div element, we'll create another div element. We will display the player's choice. Player, :space. The ID of this div element will be player display. This will display the word rock, paper, or scissors, depending on which button we pick. Let's do this for computer. Text will be computer. ID, computer display. We should display a result. Who won? The ID will be result display. Just for some temporary text, I'm going to add it's a tie. When we style this with CSS, I would like to be able to see the updates. We'll get rid of this pretty soon. Eventually, we'll add in a score tracker, but we'll do that after our game is at least working. Okay, let's head to our CSS style sheet. I'm going to zoom back to 100%. Let's select the body of our document. I will set the font family to be Arial with a backup of sans serif. Let's set the font weight to be bold throughout this application. I will set any margin to be 0 around the body. Use flexbox to display the elements. Display flex. The flex direction will be a column. And align items center. Let's select our H1 element. I need to increase the font size. Font size 3.5 rem. For a color, pick a color. For me, I'll set the lightness to 20%. Now we're going to select our div element of choices. Actually, let's make this a class. Class choices. Select the class of choices. add margin bottom of 30 pixels. Within this development, we need to select all the buttons. We will select the class of choices, select all buttons within this class. We'll increase the font size to 7.5 rem. These buttons need to be big. I will set a minimum width of 160 pixels. Add a little bit of margin between each button. 0 pixels on the top and bottom, 10 pixels on the sides. For the buttons, I would like rounded corners. I would like these buttons to be a circle. I can set the border radius to something massive, like 250 pixels. That will give us some rounded buttons. And pick a background color. Background color. I want something blue. I've already pre-picked a color, so I'm going to use this. Now, when I hover my cursor over one of the buttons, I would like my cursor to change into a pointer. And that does work. Let's also add a transition effect. Let's change the background color to ease after half a second. Let's access the hover pseudo class of all the buttons of choices. Take the background color. I'll set the lightness to be 20% lighter. Each button is going to light up when you hover your cursor over the button. Then we'll work on the displays next. We're going to select the player display and the computer display. These are IDs. Player display and computer display. Let's set the font size to be at 2.5 rem. And for the result display, where it says it's a tie, that's the ID of result display. Set the font size to be 5 rem, and I'll add some margin to the top and bottom. 30 pixels to the top and bottom, 0 on the sides. Okay, that is good enough for now. So we no longer need this placeholder for the result display. Let's add some functionality. We have a lot of constants to declare. Const choices. Choices will be an array of strings. We'll have rock, paper, and scissors. We need to get the player display and the computer display, so we can update them. Const player display equals document.get element by ID. The ID that I'm selecting is player display. Then we have computer display. Computer display. And a result display. This one, it's empty currently. Const result display equals document.getElement by ID result display. We'll factor in scoring later. We need a function of play game that accepts one argument, the player's choice. Function play game. We have one parameter, player choice. When we play a new game, we have to pick a choice for the computer between rock, paper, or scissors. What we could do is generate a random number between 0 and 2. Rock is index 0, paper is index 1, scissors is index 2. We'll create a constant within play game of computer choice. I'm declaring it within the function so we can update it every time we play a new game. Equals, take our array of choices at index. For the index, we'll generate that random number using the random method of math. Math.random method times 3. Then we need to round it because it's not going to be a whole number. Math.floor to round it down. So the computer's choice will be a random index between 0 through 2, which will give us randomly either rock, paper, or scissors. Hey, this is Bro from the future. One thing that would be good for us to do is along the way, use console.log just to be sure that what we've been writing has been working. So within our computer's choice, let's console.log whatever that is. So if this does work, after clicking one of these buttons, the computer is either going to pick rock, paper, or scissors. The computer picked scissors just now. Scissors, scissors. It really likes scissors, apparently. So yeah, the player's choice is being populated with the string of rock, paper, or scissors. I just wanted to confirm that. And we need a result. What are we going to display to the screen? Result will be an empty string for now. First, let's check to see if the player's choice is equal to the computer's choice. That means it's a tie. If player's choice is strictly equal to the computer's choice, maybe we both pick rock. Well, then we'll take our result to be displayed and set it equal to be, it's a tie. Else, somebody is going to win. Let's add an else statement. We can use a switch. We can examine a value against matching cases. We'll examine the player's choice. Does the player's choice match the case of rock? Do these two values match? If so, we'll use the ternary operator. We'll check the condition of if our computer's choice is strictly equal to scissors. If so, question mark, that's the ternary operator. If we pick rock and the computer picks scissors, we will return you win. Otherwise, if this condition is false, well, that means the computer picked paper. If our choices already don't match, and we picked rock, that means they either picked scissors or paper. If they didn't pick scissors, that means they picked paper. So they win. That means we lose. You lose. Whatever string is returned, we're going to assign it to result. Result equals whatever is returned. Either you win or you lose. Then we should add a break after this case. Alright, let's copy this case and everything within it. Let's paste it. If the player's choice matches the case of paper, and the computer's choice is strictly equal to rock, that means, if that's true, you win, else you lose. Let's copy this case and everything within it. Case scissors. If the computer's choice equals paper, then you win, otherwise you lose. After we move beyond the if-else statements, we need to update the text on the screen. So we will take the player's display, set the text content to equal a template string of player, :space, add a placeholder, the player's choice. Did we pick rock, paper, or scissors? Then let's do this with the computer's choice. Select the text content of the computer display. The text will be computer. We will display the variable of computer choice, the one that was picked randomly, and take our result display, which has no text content currently, set it equal to be result. Okay, let's see what we have currently. Let's pick rock, it's a tie, paper, you win, scissors, you lose. What we'll work on next, depending on the result that's displayed, if we win, I would like the text to be green. If we lose, I want the text to be red. Going to our CSS style sheet, we're going to add 3 classes. Green text, red text, pick a font color. Pick something green. And for the red text, pick a red font color. If we win or lose, we're going to add one of these classes to the class list of our result display. So going back to our JavaScript file, after we display the result. Now we're going to add a switch. We're going to examine our result. We will add a case of you win. If our value matches this case, let's take our result display, access the class list, use the add method, add the class of green text, then break. Let's copy this case, paste it. We will add a case for you lose. Add the class of red text if we lose. Let's see what we have currently. If we win, you get green text. If you lose, you get red text. But now if it's a tie, we have red text. With each new game, we should reset the color back to the original. So before updating the color and displaying it, let's take our result display, access the class list, use the remove method, remove any class of green text and red text. Let's see if this works. You lose, it's a tie, that's black. You lose, you win. The colors seem to be working. All right, now let's add a scoring mechanism. We'll have to head back to our HTML file. After our result display, we're going to create a div element. The first div element will have a class of score display. The text for the score display will be player score :space. Then we'll add a span element within with text of 0. I will give the span element a unique ID of player score display. The reason I'm putting this number within a span element, I'm going to style this number different from the rest of the div element, the player score. Okay, let's copy this div element and paste it. We need another for computer. Computer score. The ID of the span element will be computer score display. Going back to our CSS style sheet, we'll add the following. After our result display, we will select the class of score display. Increase the font size. Font size will be 2 rem. For the actual numbers, I'm going to change the color. With the CSS property where the font color is green, I'll add an additional selector. Let's select the ID of player score display. I would also like that to be that shade of green. And for the red text, let's select the ID of computer score display. So the computer score, that number will be red. Okay, now we just need to add functionality to the scoring mechanism. So back to the top, we're going to select the ID of player score display. Const player score display equals document.getElementById player score display. And we need the same thing for the computer. Computer score display. And we need a score value, a number, so we can work with it. Let player score equal 0. Let computer score equal 0. Going to the bottom of this function, within our switch, within our case of you win, we're going to increment our player score plus plus. Then take our player score display and update it. Access the text content, set it equal to whatever the player score is. Then let's do this with our computer. Computer score plus plus. That's if we lose. And computer score display equals the computer score. And that should be everything. Let's see if this program works. You lose, you win, it's a tie. You win, you lose. The player score is 4, the computer score is 2. Alright everybody, so that is a game of rock, paper, scissors you can make using JavaScript. Hey, what's going on everybody? So in today's video, I'm going to show you how we can create an image slider program using JavaScript. You will need some images to work with. I would recommend finding 3 or more somewhat related images to whatever you would like to create an image slider for. Once you find your images, put them within your website folder, and we are ready to begin. Okay, let's do this thing everybody. So we will create a development to contain everything. This development will have a class of slider. Within this development, we will create another development. This development will have a class of slides to contain our images. Within this inner development, we will create 3 image elements. The first image will have a class of slide. With this image element, I will set the source attribute to be a relative or absolute file path. Let's begin with image 1, whatever you currently have. I'll copy the name of this image, including the extension. So my image has a name of image1.jpg. And for some reason, if this image can't display, I'll add some alternative text with the alt attribute. Let's say image number 1. And there's my image. I will copy this image element, paste it twice, or once for every image that you have. Then I have image 2 and image 3. Let me change those. We have image 2 and image 3. So you should have 3 or more images, depending on what pictures you're using and how many. Then we're going to add some arrow buttons. For the time being, that will be down at the bottom. So we will create a button element. Now you could use a left angle bracket. Let me zoom in. But I think there's a better option. There's a Unicode character for a left pointing angle bracket, which looks like this. We will use the Unicode character of ampersand hashtag 10094. I think that looks better, but you do you. Alright, then let's create a right angle bracket with another button. The number is 10095. So that will create a button with an arrow that points to the right. For the previous button, the left one, I will assign a class of prev, meaning previous. And the next button will have a class of next. When we click on these buttons, we'll call a JavaScript function. We need to set the onClick event handler equal to a JavaScript function. For the previous button, we'll call a function of prev slide, meaning previous. And for the next button, we will call a function of next slide to go to the next slide. Okay, and that is all the HTML that we need for now. Let's go to our CSS style sheet. We will select our class of slider that contains everything. Class, slider, we're going to use relative positioning. These elements will move relative to their normal position using relative. So we have position relative. I will set a width of 100%, as well as margin auto to center everything horizontally. Now, just in case if our images are really big, I will set the overflow property to be hidden. So take our class of slider, select all the images. With these images, I will set their width to be 100%, and for now, I will set the display property to be none. We don't want to display all the images right away, so they should disappear. Let's add a little bit of functionality before continuing. Let's go to our JavaScript file. I'm going to create a node list of all the images within our class of slides. So I will create a constant of slides, which will be a node list, equals document.query selector all. We will select all elements within the class of slides that are images, image elements. We will also declare an index of the current slide. Let slide index. So this will be 0 initially, to start at the first slide. We'll be using the setInterval function. SetInterval will return an ID that we can work with. So we will declare a variable to hold to that. Let interval ID. For now, I'll set it to be null, meaning no value. Okay, let's declare our functions. We will have a function to initialize our slider. This will populate our web browser with the first image when we call this function. Then we need a function for show slide. There will be one parameter, an index. An index of the next slide we would like to go to. A function for the previous slide, prev slide, and a function for next slide, function next slide. Within our function of initialize slider, we will take our node list of slides at index of our current slide index, which will be 0 initially. I will access the class list and add a class of display slide, which we still need to work with. And then we will call this function right away. Okay, we need to build this class still, display slide. We will select all image elements that have a class within their class list of display slide. If an image has this class, we will set their display property to display as a block. We should get our first image. If you would like, although it's not necessary, we could display this image after all of the DOM content loads by using an event listener. Here's how. If you would prefer to wait for all the DOM content to load, we can take our document, add an event listener. We will wait for the event of DOM content loaded. Once all of the DOM content loads, pass in a callback to initialize slider. So this would work too, and I would say it's the preferred way. Rather than just calling this function initially, wait for all the DOM content to load, then display our first image by calling this function. Within the initialize slider function, we will use the set interval function. We will call the next slide function after a given amount of seconds. Let's say after 5 seconds, I would like to go to the next slide and display the next image, whatever is next within our node list. In order for us to work with this interval, this function is going to return an interval ID, so we can clear it later if we need to. We will take our interval ID, set it equal to the set interval function. So I'm going to console.log my interval ID just to see what it is. So let's save and run everything. Go to console. So this interval has an ID of 1. If I need to clear this set interval function, I can access it by its ID, which is currently 1. And we can get rid of this line. To avoid displaying an image if we don't have one, we can wrap these 2 lines of code within an if statement. We will check if our node list of slides, its length property, is greater than 0. If we do have slides, then display it and use the set interval function. If there's no slides, no images, then don't do this. Okay, then we're going to go to the next slide function. We're going to increment slide index by 1, slide index ++. And then we will call the show slide function, pass in our slide index after incrementing it. And that is all we need for next slide. Then we have the show slide function. Within our show slide function, we will access our node list of slides. Use the forEach method to iterate through all of them. I would like to take each slide, arrow, do this. Take each slide, access its class list, then remove a class from the class list. We will remove the class of display slide. If it's time to move to the next slide, we don't want to display the current slide anymore. We'll remove display slide so that it's no longer displaying as a block. Remove these properties. Then outside of this forEach method, we will add display slide to the next slide. Then we will take our slides at index of slide index. Access the class list of the next slide. Then we will add a new class. Add the class of display slide so that it displays as a block. And let's see if this works. After 5 seconds, we should move to the next slide. And that does in fact work. Let's wait again for the next slide. And that has worked too. we need to reset our slide index because right now we're going out of bounds. We only have 3 slides in this example. Within our showSlide function, we'll add an if statement and an else if statement. If we reach the end of our slides, we need to reset the slide index and set it back to be 0. If our index that's passed in is greater than or equal to our node list of slides length property, if we reach the end, we need to take our slide index and reset it to be 0. Now, if we go backwards with the previous button, if our index is less than 0, we will take the slide index, set it equal to our slide's length property minus 1 to set it to the end. If we're on the first slide and we hit the previous button, that will bring us to the last slide. These images should loop. Let's see if that does work. So we're on our green car and we should go to our blue car next. And that does work. Our initialize slider function is done. If we click on the next button, we should be able to go to the next slide right away. Now we have to work on the previous button and add some functionality to that. Within the previous slide function, we will take our slide index and decrement it with minus minus. Then call the showSlide function, pass in the current index. Now we should be able to move forward and back. Now, if we hit the previous button because we want to look at an image, the timer is still going. We'll still go to the next slide. If we would like to take some time to admire one of these images, we can clear the setInterval function by using its interval ID. So if somebody were to hit the previous button, let's clear the timer. We will use the clear interval function. We will pass in that interval ID. Our setInterval function is still going to move the slides forward, but if I were to hit the previous button, that interval is going to stop. We are done with all of our JavaScript functionality. We're going to apply some CSS styling to the buttons, and even add a transition animation to the next image. We will style our buttons next. Within our class of slider, select all buttons. I will set the position property to be absolute. Positions an element relative to its parent, meaning the slider element. With absolute positioning, I will set the top property to be 50%. These buttons will then be positioned on the y-axis at 50%, meaning the middle. Then I will use the transform property. I will translate them on the y-axis by minus 50%. Translate y is a function. We're moving these buttons up by 50% of the element's height. That will put this button right in the middle. Take 50% of the height of the button, move it up by that amount. I'll increase the font size. Font size, 25 pixels, or better yet, let's do like 2 rem. Okay, now for the background color, I'll set it to be black, but I'm going to lower the alpha on it, so it's transparent. I'll set the alpha to be 50%. And for the font color, I'll set that to be white. Okay, you can see our 2 buttons are overlapping currently. I'm going to remove the border around the buttons, border none, and change our cursor to be a pointer if we hover over one of the buttons. So these buttons each have a class, previous and next. Let's select the previous class. I will set the left property to be 0, to left align it. And with the next class, that's the next button, I will set the right property to be 0, to align it to the right. I'm also going to add a little bit of padding too around the buttons. Let's add some padding here. Padding, 10 pixels by 15 pixels. That looks pretty good. We are going to add an animation. At keyframes, we need an animation name. We will name this animation fade for a fade effect. From this property of opacity, I can't spell today, 0.5, meaning 50%, to this property, opacity 1 for 100%. When a new image is displayed, the opacity is going to be 50%, so it's transparent. Then, after the animation is complete, set it to be 1 for 100%. Now we just have to utilize this animation of fade. All images that have the display slide class, we will set their animation name when that image is displayed to be fade. How long do we want this animation to take? We will set the animation duration to be about 1.5 seconds. Okay, let's see if this works. We should get a fade animation when each new slide appears. We can move forward, and we can move back. All right, everybody, so that is an image slider that you can create using JavaScript, HTML, and CSS. Hey everybody, in today's video I got to introduce to you the wonderful world of callback hell. Callback hell is a situation in JavaScript where callbacks are nested within other callbacks, to the degree where the code is difficult to read. If you nest too many callbacks within other callbacks, your code starts to form a pyramid, and it's really difficult to work with. Callback hell is an old pattern to handle asynchronous functions in JavaScript. Nowadays, we have promises as well as async and await to avoid callback hell, which we'll discuss pretty soon. To help us avoid callback hell, we should be familiar with what it is. I'm going to create 4 tasks. These will be functions. Function, task 1. These will be synchronous functions. We don't need to use callbacks for synchronous functions. Then we'll change these to be asynchronous functions. Within task 1, we will console.log task 1 complete. Okay, let's copy task 1, paste it 3 times for a total of 4 tasks. We'll have task 2, task 3, and task 4. In order from the top down, we will execute task 1, followed by task 2, task 3, and task 4. When all 4 tasks are complete, we will console.log all tasks complete. These functions work synchronously. They're all in order. Task 1 is complete, then 2, 3, then 4. Then we get the final message of all tasks complete. But what if these were asynchronous functions? They're not going to follow this order from the top down. So to make these functions asynchronous, one thing we could do, we can enclose this code within the setTimeout function. setTimeout. setTimeout takes 2 arguments, a callback and a time in milliseconds in which to complete this code. For the callback, this could be a callback, an anonymous function, or an arrow function. I'll write an arrow function. Parameters, arrow, do this. Say the task is complete after 2000 milliseconds. Let's do this with the other tasks too. So task 2 will be complete after 1 second, 1000 milliseconds. Task 3 will be complete after 3000 milliseconds. Now task 4 will be complete after 1500 milliseconds. Okay, let's try this again. I need these tasks to be completed in order, starting from 1 all the way to 4. It says that the tasks are already complete. Then the tasks are completed in this order: task 2, task 4, task 1, and task 3. So that's the problem with asynchronous code. Asynchronous functions can complete at any time. The rest of our program doesn't wait around for them to finish. If I absolutely need these tasks to complete in order, starting with 1, then 2, 3, 4, each of these functions can accept a callback, so we need to set up that parameter. After we say that that task is complete, we will execute the callback to the next function. So let's do this with the rest of the tasks. If we need these tasks to complete in order, starting with 1, we would take 1, and there's one parameter, a callback. We'll pass in a callback to task 2. We can pass in a callback, an anonymous function, or an arrow function. I like arrow functions though. Parameters, arrow, do this. What are we going to do when task 1 is complete? We'll call task 2. Task 2 also accepts a callback. Again, this can be a callback, an anonymous function, or an arrow function. This will be an arrow function. Parameters, arrow, do this. What do we want to do when task 2 is complete? Call task 3. Task 3 also accepts a callback. We'll use an arrow function. Parameters, arrow, do this. Now when task 3 is complete, guess what we're going to do? Call task 4. Task 4 accepts a callback. We'll do this. Parameters, arrow. Then I would like to console.log all tasks complete. All tasks complete. This should work now. Task 1 complete, task 2 complete, task 3 complete, task 4 complete. All tasks complete. So what we've done is use callback hell. It's where you're nesting callbacks inside of other callbacks. If you have a lot of tasks to complete in order, it can become very unmanageable. Hey, this is Bro from the future. One thing that I wanted to mention is that 4 levels of callbacks isn't too unreasonable, but when you add additional levels on top of that, that's when you're starting to approach the levels of callback hell, where the code can become unmanageable and really difficult to read. What I've written in this video isn't too unreasonable, but hopefully you can see how we've come to start that pyramid pattern. That is all. Alright everybody, so that is callback hell. It's a situation in JavaScript where callbacks are nested within other callbacks, where the code is difficult to read. It's an old pattern to handle asynchronous functions. In some upcoming videos, we'll be discussing promises as well as async and await to avoid callback hell. And well everybody, that is callback hell and why you should avoid it in JavaScript. What's going on everybody? So in today's video I gotta talk about promises in JavaScript. A promise is an object that manages asynchronous operations, such as querying a database, fetching a file, gathering resources. Those you could consider asynchronous operations. They can take an indeterminate amount of time. You can wrap a promise object around some asynchronous code. The promise object promises to return a value. That promise object will be pending, then either that promise will be resolved if the task completed successfully, or rejected if it failed for some reason. Maybe the promise couldn't fetch that file. Resolved if it did. A promise is an object. We'll create a new promise object with new promise, then pass in a function. Usually you see this as an arrow function. There's 2 parameters, resolve and reject. Arrow, then do some asynchronous code. So in this demonstration, we're going to be doing some chores. If you live with your parents, maybe your mom asked you to do these chores, or with a roommate, these are the tasks you need to do, or your significant other wants you to do these tasks. Anyways, we have some chores to do. We have to walk the dog, clean the kitchen, and take out the trash. I'll create functions for each of these chores. First, we'll start by using callbacks. Then I'll demonstrate the use of promises and how they're helpful. So let's create a function to walk dog. To make this asynchronous, I'm going to add a set timeout function. This takes a callback and an amount of time in milliseconds to complete this code. Let's say walking the dog takes 1,500 milliseconds. What code would we like to perform? Let's write an arrow function to keep it simple. Parameters, arrow, do this. Let's console.log, after completing this chore, you walk the dog. Okay, that'll be the first function. Let's create a function to clean the kitchen. Function clean kitchen. This will take a long time. 2,500 milliseconds, let's say. When we complete this task, we will print, you clean the kitchen. And a third function, take out trash. You take out the trash. Taking out the trash, it's really quick. It takes half a second, 500 milliseconds. If I need to do these chores in order, I would need to use some callbacks. After walking the dog, we will call a callback to clean kitchen. After we clean the kitchen, we will take out the trash. We need to modify these functions so that they accept some callbacks. After our code is complete, we will invoke the callback. Call the callback. So let's add that parameter to each of these functions. Now, if we want to call all these functions in order, we would have to start using callback hell, which we learned about in the last video. So first, I would like to walk the dog. I will call that function, pass in a callback, but we'll use an arrow function. Then we will clean the kitchen, pass in a callback. I'll use an arrow function, take out trash, and we'll pass in a callback to do this when we complete all the chores. Console.log, you finished all the chores. Okay, let's see if this works. You walk the dog, you clean the kitchen, you take out the trash, you finished all the chores. If we have a lot of callbacks to work with, we'll end up going to callback hell. You don't want to go to callback hell. So what we'll use instead are promises. With all of this asynchronous code, we'll wrap it within a promise. By using a promise, we don't need callbacks. Instead of using callbacks, we'll use method chaining. We'll method chain our promises. Here's how. How we'll modify these functions is that at the end of each function, we will return an object. Return a new promise. Return a new promise object. And follow this formula. We have two parameters, resolve and reject. Resolve, reject. Arrow, do this asynchronous code within an arrow function. Take all of the asynchronous code, cut it, place it within the promise. Our promise promises to return a value. It's either going to be resolved or rejected. We're going to modify this function. We don't need to work with callbacks anymore. We can get rid of those. Get rid of the parameter and the portion of the code where we call the callback. If we would like to display a message when the promise resolves, when it finishes successfully, we will instead call the resolve parameter. It's a function. This message is the value, the argument that we're passing in. After you finish walking the dog, here's your completion message when the promise resolves. Let's modify the rest of the functions so that they use promises. We will return a new promise, two parameters, resolve, reject. Arrow, do this asynchronous code. Let's cut our current asynchronous code, paste it, remove the callback parameter, we don't need it anymore, and we don't need to call the callback. When this promise resolves, pass along this message. You clean the kitchen. Let's do this with take out trash. We will return a new promise. Two parameters, resolve, reject. Arrow, do this. Cut the asynchronous code, paste it within the promise, remove the callback, and where we call the callback, when we resolve this promise, pass along this message. We no longer need to use callback hell. Instead, we're going to use method chaining. First, we're going to walk the dog, clean the kitchen, and then take out the trash in that order. We will call the walk dog function. And then we're going to method chain. Follow this with the then method. Walk the dog, then what is what we're saying. The walk dog function does provide a value parameter, this message. We can use that message for something. That's going to be stored within value. That's going to be the parameter that's provided to us. Take the value, let's print it. Console.log my value. So when I run this program, we should only be walking the dog. You walk the dog, and nothing else. Looks like I misspelled resolve as resolves. There. After walking the dog, I would like to clean the kitchen. So I need to call that function next. Within our arrow function, we'll write more than one statement. We need to enclose this within a set of curly braces. Print our value, and then do this function. Return, clean, kitchen, and then call it. We'll add another then method. Then, take the value provided by clean kitchen. That will be this one. Take that value, arrow, console.log that value. You walk the dog. You clean the kitchen. Then we'll take out the trash at the end. We'll add another statement to this then method. We will return take out trash. Invoke this method. Then we will take the value provided to us when it resolves, this value, do this code, console.log, that value. You walk the dog, you clean the kitchen, you take out the trash. So after taking out the trash, that's our last chore. Let's add another line of code. After displaying you take out the trash, let's console.log you finished all the chores. You walk the dog, you clean the kitchen, you take out the trash. You finished all the chores. By method chaining then methods, it's a lot easier to write than nesting callbacks. Now, sometimes with asynchronous functions, depending on the task may fail. Let's say we're trying to locate a resource, a file. If we can't locate that file, and we're using promises, we don't want to resolve that promise, because we couldn't locate that file. Instead, we want to reject. That's what happens when an asynchronous function fails to do something when inside a promise. So let's change our functions around. Within setTimeout, let's create a variable. Const dog walked. Did we accomplish this? This will be true or false. We'll use an if statement. If dog walked. Then we will resolve it if we walked the dog. Else, we will reject. We'll pass in a different value. You didn't walk the dog. Okay, let's do this with the other functions. Let's create a constant of kitchen cleaned equals true. If our kitchen is cleaned, if that is true, we will resolve this promise. You clean the kitchen. Else, let's reject. Pass along this message. You didn't clean the kitchen. And lastly, take out trash. Const trash taken out. Let's set that to be true. If the trash is taken out, resolve the promise. Else, we will reject. You didn't take out the trash. If a promise might reject, there's one more method we need to add to the end of this chain. We need to add a catch method to catch any errors. This will catch any rejects. This is similar to error handling. We'll be provided with one value, an error. Arrow, do this. Let's console.log, or even console.error, the message provided to us with reject. That's what the error is going to be. We'll successfully walk the dog, that will be true, and cleaning the kitchen will be true. But taking the trash out will be false. We weren't able to complete this chore. These are the results. You walk the dog. You clean the kitchen. You didn't take out the trash. How dare you? We'll keep on completing these tasks until we fail at one of them. So if walking the dog was false, that was our first task. This first promise was rejected. We don't even attempt to resolve these other promises. Alright everybody, so those are promises. They're an object that manages asynchronous operations. You can wrap a promise object around some asynchronous code. These promise objects promise to return a value. They will be pending until they complete. Then they'll either be resolved if that task completed successfully, or rejected if it failed for some reason. And well everybody, those are promises in JavaScript. Hey everybody, so today I got to talk about async and await in JavaScript. Async and await are two keywords. By using these two keywords together, they allow you to write asynchronous code in a synchronous manner. Async makes a function return a promise. Await makes an async function wait for a promise. We'll discuss async first. In this sample program from the last topic, we have some chores to do. We have to walk the dog, clean the kitchen, and take out the trash. Each of these functions returns a promise. a promise that can either resolve or reject, based on the code that's written. If the dog is walked, if that's true, resolve. If it's false, reject. A function can be declared with async. A function declared with async will return a promise. However, that promise that's returned doesn't resolve or reject. In a way, you could say it's an empty promise. If I were to run this code, this is what happens. Uncaught reference error. Resolve is not defined. If an asynchronous function returns a promise that either needs to resolve or reject, adding async to it really doesn't benefit us. Async works together with await. By using these two keywords together, when calling all of these asynchronous functions in order, we don't need to method chain then statements. There's a more synchronous manner in which we can write the same code, but we'll need to contain it all within an async function. Async function will create a function to do chores. Then we will need to call this function somewhere. Let's do so right here. First, we need to walk the dog. Walk the dog returns a promise. That's where the await keyword comes in. Await makes an async function wait for a promise before continuing. We're going to create a constant of walk dog result equals, use the await keyword, await walk dog. Then we will console.log the walk dog result. You walk the dog. Now let's do this with clean kitchen. We're going to be writing this code in a synchronous manner, line by line, linearly. We will create a constant for clean kitchen result equals await the next promise, await clean kitchen. Then console.log clean kitchen result. Let me close this. You walk the dog. You clean the kitchen. And last, we have take out trash. Const take out trash result equals await take out the trash. Then console.log the result. You walk the dog. You clean the kitchen. You take out the trash. Let's add one more line when we finish everything. One more line of code. You finished all the chores. You walk the dog. You clean the kitchen. You take out the trash. You finished all the chores. Let me show you what happens if we attempt to use await within a function not declared with async. Uncaught syntax error. Await is only valid in async functions. That's why await depends on async. Await makes an async function wait for a promise before continuing. Now, if your promises can reject, let's say that dog walked is false. Uncaught, in promise, you didn't walk the dog. We'll surround all of this code within a try block, then catch any errors. Catch one parameter of error. We can console.log or console.error the error. You didn't walk the dog. All right, everybody, so that is async and await. Async makes a function return a promise. Await makes an async function wait for a promise. By using these two keywords together, we can write asynchronous code in a synchronous manner. And well, everybody, that is async and await in JavaScript. What's up, everybody? So today I got to talk about JSON files using JavaScript. JSON means JavaScript Object Notation. It's a data interchange format. Most of the time, it's used for exchanging data between a server and a web application. They can have a few different formats. Usually, you'll see a JSON file as an object made up of key value pairs. Or you may see them as an array of values, or some combination of both. You can have an object where one of the values is an array, or you could have an array of objects, like this. Just to understand the format, we'll create a new JSON file. Let's go to our website folder, create a new file. We'll create an array of names. The file extension is JSON. We'll begin by writing an array with a set of straight brackets. Let's add a few names. just some first names. SpongeBob, Patrick, Squidward, Sandy. This is a valid JSON format. Let's create a new JSON file just for a single person. This will be an object. New file, person.json. This time, we will create a single object. This object will have key value pairs. We will have a name key and a value of SpongeBob. Each key value pair is going to be comma separated. SpongeBob will have an age key of 30 and a boolean of is employed. Is SpongeBob currently employed? That will be true. This is also a valid format. Our JSON file contains one object, an object made up of key value pairs. Objects can even have arrays as one of their values. We will create an array of hobbies. What does SpongeBob like to do? This will be an array. Jellyfishing, karate, and cooking. Let's create one more JSON file. We will create a JSON file for people. This will be an array of objects. People.json. We're going to create an array of objects. Within this array, we'll create one object. What key value pairs should this object have? We'll just reuse what we have for SpongeBob, excluding the array to keep it simple. Okay, that will be the first object. Let's create another object. We need another set of curly braces. The second object will have a name property of Patrick. Age 34. Is employed will be false. The next object, this will be for Squidward. Age 50. Is employed true. He works at the Krusty Krab. One last object. Name Sandy. Age 27. Is employed false. Sandy is self-employed. Alright, we have an array of objects. Each object can have its own unique key value pairs. So let's close out of these JSON files, but we'll hold on to them. So JSON formats, they're one long string to represent that object or array. Using the stringify method of JSON, we can convert a JavaScript object or an array into a JSON string. So let's copy what we have for names. I will create a constant of names equals that array. We'll convert it to a JSON string. Const JSON string equals access JSON. JSON is a built-in object that's provided to us to work with JSON files. We will use the stringify method, then pass in our array or our object. Currently, if I were to console.log my names before stringifying it, here's the result. We have an array of strings to work with. After using the stringify method on names, we'll be given one long string to represent this array. If I was to use this on an object, let's copy what we have for person. I will create a const of person. This will be an object. I'll just paste what I have for SpongeBob. First, let's console.log person. Here's my person object. Then let's stringify it and display the JSON string. JSON files work with one long string that represents an object or an array. Let's stringify our people. It's an array of objects. Const people equals paste what we have. Let me show you what happens when I console.log people before stringifying it. We have an array of objects. Each object has its own key value pairs. Then if I was to stringify it, here's the result. One extremely long string. Now we'll use parse. Parse converts a JSON string to a JavaScript object. So let me reformat these. To convert these objects or arrays into a string, we can surround them with a pair of backticks. So let's rename these. Let's say JSON names, JSON person, then JSON people. These objects and arrays are all in a JSON format. To convert them to their original form, we can use the parse method of JSON. I will create a constant of parsed data equals JSON.parse. Pass in our data of JSON names, and then let's console.log. Let me show you JSON names first before parsing it. We have a string representation of an array, but after parsing it, it becomes a JavaScript array. Let's do this with our string representation of an object, JSON person. Normally it looks like this. And then after parsing it, we have a JavaScript object. And then JSON people, it's an array of objects. Then we'll parse it. And here's the result, an array of objects. Now I'm going to show you how we can fetch a JSON file. We'll talk about fetch more in the next topic. Fetch is a function. As an argument, we can pass in a relative or absolute file path, or a URL. We'll discuss that in the next topic. I would like to get my JSON file of, let's go with person. So I will list the relative file path. These files are right next to each other. I just need to type person.json. Fetch returns a promise. We will follow this with the then method. Then do this. We'll be provided with a response object. Take our response, arrow, do this. We will take our response object, convert it to a JSON format using the JSON method. Then let's display what we have currently. Then take the value, arrow, console.log that value. Let's see what we have. Yep, there's SpongeBob. We have successfully fetched a JSON file. Let's do this with our array of names. We have an array of strings of first names and people, people.json. We have an array of objects, one object for each person. If you would like to iterate through all the objects, let's rename value as values. We'll use the built-in forEach method of arrays, values.forEach. Take each value, arrow, do this, console.log each value. Now we're iterating through and printing each object. If you would like some of the specific properties, like name, follow the value with name. SpongeBob, Patrick, Squidward, Sandy. Or age, or is employed. Oh, and another thing that I'm forgetting. Be sure to add a catch method to catch any errors, just in case we can't fetch this JSON file for some reason. Console.log or console.error, the error message. We'll talk about fetch more in the next topic. Alright everybody, so those are JSON files. JSON means JavaScript Object Notation. It's a data interchange format. It's mostly used for exchanging data between a server and a web application. JSON files are usually objects, or an array, or some combination of both. To convert a JSON object to a string, you can use the stringify method. To convert a JSON string to an object, you can use the parse method. To fetch a JSON file, you can use the fetch function, which we'll talk about next, and get more in depth with. And well everybody, those are JSON files using JavaScript. What's going on everybody? So in today's video, I'm going to show you how we can fetch data from an API using JavaScript. And at the end of this video, we're going to create a project where we can fetch some images of Pokemon, depending on what Pokemon you type in. So sit back, relax, and enjoy the show. Alright people, so we got to talk about fetch. Fetch in JavaScript is a function. It's used for making HTTP requests to fetch resources, including, but not limited to, JSON-styled data, images, files, resources of that nature. The fetch function simplifies asynchronous data fetching. It's used for interacting with APIs to retrieve and send data asynchronously over the web. Fetch has two arguments, a URL of the resource and an object of options. I won't be talking about options in this video. That's more advanced JavaScript. one of which you may see is a method property. The default is get to get a resource. You can use post to send some data, put to replace some data, and delete to delete some data. So the default is get, but we don't need to explicitly state that. We'll just be focusing on getting data with only a URL. To fetch something, we have to use the fetch function and pass in a URL. What I thought we could do for this video is fetch some Pokemon data from the Pokemon API. If you want to follow along, you can go to this URL. I would like to fetch some data on Pikachu, because everybody knows about Pikachu. And here's some of the data on Pikachu. This resource is one gigantic object. Pikachu has a name, an ID number, a type, Pikachu's an electric type, their stats such as his attack power, HP, there's even image sprites, which we'll work with later. We will copy this URL and paste it within the fetch function. We will pass in a string representation of this URL. The fetch function is promise-based. It's either going to resolve or reject. So we should add a then and a catch method to catch any errors. Error, arrow, do this. Let's console the error if there's an error. Once the promise resolves, we'll be provided with an object, a response object. Take our response object, arrow, do this. For the time being, let's console.log our response just to see what it is exactly. So here's our response object. The body contains the data we're looking for Pikachu. This response object has a status code of 200. That means it's okay. Here's where you may see that status code of 404 if you can't locate a resource. It has an OK property. If fetching this resource was okay, this is going to be true. If not, it's false. There's also a URL here too. Now our next step is to convert it to a readable format. There's a few different methods. There's array buffer, blob, text, and JSON. These are all methods. We're interested in the JSON method in this example. So our next step is to take our response object, convert it to JSON using the JSON method. This is also promise-based. Once this promise resolves, let's follow this with a then method. Then take the data, our JSON data that's going to be returned to us, arrow, do this. Let's console.log my data just to see what it is. So after fetching data on Pikachu, convert the response object to a JSON format. And here's my data for Pikachu. We have a name, an ID, Pikachu stats, such as his HP and attack, and weight, and many more things. With this JSON data, you can access one of the properties. I would like just Pikachu's name, data.name, Pikachu, data.weight. How much does Pikachu weigh? 60 units of something. Whatever unit of measurement they use in Kanto. What is Pikachu's ID? 25. Near the end of this video, we're going to fetch the sprites of the Pokemon. Now, for some reason, if we try and access a Pokemon that doesn't exist, as of the filming of this video, SpongeBob is still not a Pokemon. We get a status code of 404, meaning we could not find this resource. SpongeBob is not a Pokemon, unfortunately. So even if we can't locate a resource, our promise is still going to resolve. It's not going to reject. We need to check to see if our response is not okay. Let me demonstrate. I will console.log my response object. Here's my response object. It is not okay. Your response will be okay if the status is within the 200 range. Since we have a status of 404, we couldn't locate this resource. OK is false. We're going to throw an error if our property of OK is false. Within our first then method, we'll write a few statements. We need a set of angle brackets. Before continuing, let's check to see if our response accessed the OK property, then use the not logical operator. If our response is not OK. If it's false, we're going to throw a new error and then catch it using the catch method. We can write a custom message. Let's say something like, could not fetch resource. If our resource is okay, we won't execute this code. Otherwise, we will return our response object in a JSON format. Let's try and retrieve Pokemon data on SpongeBob. Okay, we have an error, but we have caught this error using the catch method. Error, could not fetch resource. Then let's get data on Pikachu again. And there's Pikachu and his ID number. If you would prefer to use async and await, here's how. Let's delete all this. We will create an async function so that we can use await within it. I will declare a function to fetch data, no parameters, do all this. We will create a try and catch block. Try and catch. Catch has one parameter, an error. If we receive an error, let's console that error, the error. Within our try block, we will create a constant of response. The fetch function is going to return an object, a response object. We will await our promise that's returned by fetch. Then we need to get that URL again. Let's get data on a different Pokemon. Another Pokemon that I like is Typhlosion. Honestly, I think Typhlosion is my favorite Pokemon. Alright, here's the stats for Typhlosion. I'm going to copy this URL, pass it to the fetch function as a string. Once the promise for fetch resolves, we have to see if the response is okay. We'll use an if statement. If our response object is the okay property not okay. If our response is not okay, if we can't locate this resource, then we will throw a new error. Let's say could not fetch resource. If our response is okay, we will create a constant for our data. Equals await, take our response, and convert it to JSON. This also returns a promise. That's why we're using await. Then we will console.log our data. And then we have to call the fetch data function because I forgot to do that. Call fetch data. And here's the stats for Typhlosion. Name, Typhlosion. ID, 157. Typhlosion is a fire type. That's how to use async and await to fetch a resource. Now that we know what we're doing, we're going to create a text box and a button to search a Pokemon and pull up a sprite of that Pokemon and display it. So going to our HTML file, we will create an input element with the type attribute of text because it's a text box. I will set the ID of this input element to be Pokemon name. It's a little small right now. We haven't applied any CSS. I will add a placeholder of enter Pokemon name. Then we need a button. I will create a button element with text of fetch Pokemon. I will set the onClick event handler equal to a JavaScript function. Let's call that function a fetch data. Then I will add a break. After fetching some Pokemon data, we have an image to work with. I will set the source currently to be an empty string. I will display some alternative text if we can't display the image of Pokemon sprite. And I will give this element an ID of Pokemon sprite. To not display the image currently, we can access the style, access the display property, and set it to be none. Then if we do want to display it, we can set display to be a block. Let's go to our JavaScript file. Within our try block, we will create a constant of Pokemon name equals document.getElementById The ID that I'm selecting is Pokemon name. Access the value of this input element. Now, if somebody types in uppercase characters, I'll take the value, make all the letters lowercase. I will method chain the to lowercase method. To lowercase method. With our fetch function, we're going to use a template string with a pair of backticks. For the Pokemon's name, we will use a placeholder and pass in our Pokemon name variable. So now when I type in a Pokemon's name, like Bulbasaur, we should get data on that Pokemon, if it exists. So let's go to Inspect, Console, and here's data on Bulbasaur. Bulbasaur's ID is 1. Bulbasaur is a grass type. And I think he's a poison type too, if I'm not mistaken. This JSON data also has sprites, images of each Pokemon. We're going to fetch the front default. So we don't need console.log anymore. We'll create a constant of Pokemon sprite to get that image. Equals, take our data, access the sprites property, get the front default sprite. Then we will get our image element, this one that has an ID of Pokemon sprite. Const image element equals document.get element by ID. The ID that I'm getting is Pokemon sprite. We will change the CSS of this element, take our image element, access its source attribute. Right now it's currently empty. Our source is an empty string. Set the source equal to our Pokemon sprite. This is a constant. Then we will take our image element, access the style attribute, access the display property, and set it equal to be a block, because right now it's none. Now when I type in a Pokemon's name, like Charizard, and fetch that Pokemon, we get the image of that Pokemon. It is a little small, however, it is a sprite. Sprites tend to be very small. Or we can get Mewtwo. Or whatever other Pokemon you can think of. I think there's like over 1,000 now. Where's Typhlosion? There's Typhlosion. Alright everybody, so that is how to fetch data from an API. You gotta use the fetch function. It's used for making HTTP requests to fetch resources. You can fetch JSON-style data, images, files. The fetch function simplifies asynchronous data fetching. It's used for interacting with APIs to retrieve and send data asynchronously over the web. And well everybody, that is how to fetch data from an API using JavaScript. Hey everybody, so in today's video we're going to create a weather app that fetches data from an API. You can look up any city and get the weather. If that sounds good to you, then sit back, relax, and enjoy the show. If you would like to follow along, you will need your own API key. The API that we'll be using is openweathermap.org. You do need to sign up for an account though, it is free. To sign up for an account, you can go to sign in. If you're currently not registered, you can create an account for free. Once you're signed in, you'll need an API key. Go to My API Keys. It may take you some time to get an API key generated for you. Mine took about 15 minutes. And once you get it, make sure it's active. We will need that API key about 20 minutes into this topic. Hopefully for you by then, it'll be generated. Okay, let's do this everybody. We will begin by creating a form element. The form element will have a class of weather form. Our form element is going to have an input element and a button. Within this input element, we'll type in the name of the city we would like to retrieve the weather data for. So the type of this input element is going to be text, for some text. The class will be city input, so a user can type in the city. And we'll add a placeholder. Let me zoom in a little so you can see it. The placeholder will equal enter city. Then we'll need a button. let's create a button element with text of get weather. The type of this button will be submit. It's the submit button for our form. After retrieving the weather data, we'll display the weather data in a card format, like a Pokemon or Yu-Gi-Oh card. So we will create a div element with a class of card. But before applying some CSS, we should at least add some placeholder elements so we can style them and see the changes. For the time being, let's create an H1 element. We will be deleting these elements later, so don't get too attached. I will set the class of this element to be city display. We'll add a sample city. Let's say Miami, or pick a city of your choosing. Then I will create a paragraph element. The class will be temp display, meaning temperature. Let's say the temperature is 90 degrees Fahrenheit, or pick something in Celsius. If you're on Windows, to add a degree symbol, you can hold Alt, then type 0176. Miami is going to be 90 degrees Fahrenheit. Then we'll create a paragraph element for the humidity. Class equals humidity display. For the text, let's say humidity, colon space, then a percentage, 75%. Then we need a description of the weather. This will be another paragraph element. The class will equal description display. Desk meaning description. For the description, let's say clear skies. I'll also display an emoji, depending on what the weather is. The class will be weather emoji. I'll use a sun. For some reason, if we can't display the weather data, such as if we can't locate a city, let's add the following paragraph. The class of this element will be error display. We'll add the text of please enter a city. That is all the HTML that we need for now. We're going to apply some CSS styling next. So now let's head to our CSS style sheet. We are going to select the body of our document. Select a font family. I will pick Arial with a backup of sans serif. I'll change the background color of the body. Background color, pick a color. I'm going to use HSL values. I will set the lightness to be 95%. So it's a light gray color. I will set all margin around the body to be 0. Then I'll use Flexbox to display the elements. Display flex. The flex direction will be a column to arrange all the elements in a column. Then align item center to horizontally align all the elements. Align item center. Now we'll select the class of weather form. That'll be this form that has an input element and a button. All we'll do is add a little bit of margin around the entire form. 20 pixels. Then we'll select our city input. That's going to be the text box. Class of city input. I will add some padding of 10 pixels. Let me zoom out to 100%. Increase the font size to 2 rem. Set the font weight to be bold. I'll add a border. 2 pixel solid. And pick a color. But I'll lower the alpha, so it's transparent, to 30%. There's our border currently. Border radius around the corners. Let's do 10 pixels. Add some margin of 10 pixels. That'll separate this element from the button. And set a width of 300 pixels. Okay, let's style the button next. Okay, we are going to select all buttons that have an attribute where the type equals submit. So that's going to be for our submit button that says get weather. Let me scroll down. Okay, I'm going to add some padding around the button. 10 pixels by 20 pixels. I'll set the font weight to be bold. I'll increase the font size to be 2 rem. Pick a background color for the button. I'll pick something green. But I'll use HSL values. I've already pre-picked a color. Let's go with 122, 39%, and 50%. That's a good shade of green. I will set the color to be white for the font color. Remove the border, border none. And border radius 5 pixels to round the corners. Then when we hover our cursor over the button, I would like it to be a pointer. And that does work. When we hover our cursor over the button, we'll use the hover pseudo class to change the background color. So let's take our button, where the type attribute is submit, access the hover pseudo class, take our background color, make it a little bit darker. I'll bring down the lightness by 10%, so it's at 40%. So that does in fact work. Okay, then we're going to select our card class that contains all the weather data. So we will select the class of card. For the background, we're going to do something a little bit different. We're going to use a linear gradient. Instead of selecting the background color, we will select the background. I will use the linear gradient function. There's 3 arguments. Think of a linear gradient as a slow transition between 2 colors. We need an angle in degrees. We'll say 180 degrees for now. Then a color. Let's pick something blue and orange. I'm going to pick some colors that look a little bit better. So for blue, let's set the hue to be 210, 100% for the saturation, and the lightness will be 75%. That's a good shade of blue. And for orange, we'll use another HSL value. For the hue, I'll say 40%. The saturation will be 100%. And the lightness will be 75%. So I'm hoping with this linear gradient, the background color looks kind of like a sunrise or a sunset. Once we have our background, I will add some padding of 50 pixels. I'll add a box shadow to this card. We'll add a vertical and horizontal offset of 2 pixels each, and a blur effect where the radius is 5 pixels. Then we'll pick a color. I'm just going to lower the alpha to 50%. Not bad. This gives our card a 3D pop effect. I will set a minimum width of this card to be 300 pixels. Then we have to align everything within it. I'll use Flexbox because I like Flexbox. Display flex. Flex direction will be a column. And align items center to horizontally align the items. There we go. Then we'll select all H1 elements. That's going to be our city name. Select all H1 elements. Increase the font size to be 3.5 rem. I'll remove any margin from the top. Margin top will be 0. And add margin to the bottom of 25 pixels. Then we'll select all paragraphs. That's going to be everything underneath our city. Select all paragraphs. Increase the font size to 1.5 rem. There's a lot of natural margin between the paragraphs. Let's set all margin to be 0 to see what it looks like. Okay, let's add a little bit of margin. 5 pixels on the top and bottom, 0 margin on the sides. That's a lot better. We'll select the city display and the temperature display. We're going to be selecting 2 classes. City display, comma, our temp display. Take these 2 classes, apply the following properties. You know what, for our font size, let's set that to be 3.5 rem. We can honestly remove that from each one. For the font weight, I will set that to be bold. For the color, I'll make the color a little transparent. I'll set the alpha down to 75%. So that our city and our temperature, they're both going to be transparent. Then I'll add some margin to the bottom. Margin bottom, 25 pixels. Okay, let's select our humidity display. Class, humidity, display. Set the font weight to be bold and add some margin to the bottom of 25 pixels. Then we'll select our description display, which we shortened to desk display. For the font style, I will set it to be italic, and the font weight will be bold. I'll increase the font size to 2 rem. Then we'll select our weather emoji. So class, weather, emoji. Remove all margin around the emoji, margin 0. Then we'll increase the font size of the emoji. The size will be 7.5 rem. So it's kind of big. Then if for some reason we display an error, we'll display this text. So this class is error display. I'll set the font size to be 2.5 rem. The font weight will be bold. I'll set the color to be something transparent. I'll lower the alpha to 75%. Okay, that is all the CSS that we need. Let's go back to our HTML file. We can delete everything within the card class. We just wanted to see what it would look like with the elements populated. With our card element, I will set the style attribute to be, take the display property, set it to be none. We don't want to display the card at all until we get the weather data, until it's returned to us. Our HTML is done, our CSS is done, then we're ready to add some JavaScript functionality. We'll declare our constants that we need. Const weather form equals document dot. Now, since we're not working with IDs, we can't get element by ID. We're working with classes. We can use query selector or query selector all. So I'm going to use query selector. This will return the first element in this class. We only have one element with this class. Class weather form. We'll store a reference to it. Const city input equals document dot query selector. We are selecting the class of city input. That's going to be this text box. Const card. Our card is what contains all the weather data. Document dot query selector. Select the class of card and give me the first element. Now we'll need that API key. Const API key equals. Now here's my API key. Please don't try and use this one specifically. I will be deactivating it at the end of this video. Hopefully by now you should have that API key given to you. First, we'll take our weather form. We'll add an event listener. This is our form. The text element and the submit button. When we click on this button, the event type is going to be submit. After we attempt to submit this form, we'll do the following code. We'll have one parameter, an event, that's going to be provided to us. Arrow, do this. We'll fill this in later. We'll declare our functions that we need. We will need an async function to get weather data. There will be one parameter, a city, that's going to be passed in. Then we'll need a function to display weather info. There will be one parameter, data. The data will be in a JSON-like format. We'll create a function to get weather emoji based on what the weather is. there will be one parameter, a weather ID. Then we'll create a function to display to the screen any errors, if there are any. Function display error. There will be one parameter, a message to be displayed to the window. Within our event listener, once we have a submit event, once we click the button, forms do have a default behavior where they'll refresh the page. We would like to prevent that. So let's take our event, use the prevent default method to prevent the default behavior for a form. We don't want to refresh the page. Then we'll have to get the city, the value within this text box. Const city equals, take the city input, access the value, store it within this variable. It should be a string. We'll use an if statement. If city. If there's a value within here, this will be true. We can use it within an if statement. If there is a city, do this. Else, we'll call the display error function. Else, we will display an error. We will pass along the message to please enter a city. Let's fill in the display error function. We want to be sure that it works before continuing. The display error function is at the bottom. We'll be provided with a message to display. We will create a constant of error display equals document. Now we'll create an element. Create element. We will create a paragraph. Then we'll need to change the text content of this element. Error display, access the text content, set it equal to be our message. Then we're going to add the class of error display. We would like these CSS properties. Take our error display element, access the class list, then we will add a class. We will add the CSS class of error display. Then we will take our card element, which normally displays the weather data, take our card, reset the text content if there is something there. We'll set it to be an empty string. So normally with our card, the display is set to none. We'll set the display to be a block, or even flex. Access our card, access the style, access the display, and I will set the display to be flex to display it. We will take our card, we will append a child element, append child. We will append this paragraph of error display to the card. Now, if I were to not type in anything and just press get weather, we get this error message. Please enter a city. To our card, I'm just going to round the corners to make it look better. Border radius, let's do 10 pixels. That's better. Okay, moving on. If we do have a city, if there's text within here, we will try some code because it might cause some errors. We will catch any errors that happen. We have one parameter of error. If there's an error, we can console.log or console.error the error. Then let's call our display error function. We'll pass along the error and display it. Now we need to get the weather data. Within our try block, we will create a constant of weather data equals, now we need to await get weather data function and pass in our city. So with await, we can only use await within an async function. Since we're within an arrow function, we could declare this arrow function as an async function. So let's precede our event parameter with async so that we can use await. We're going to wait for this function to return the weather data. Once we receive our weather data, we will call the display weather info function and pass along that data, the weather data. Okay, this function is complete. Once you've typed everything in, I'm going to close this function. And we can close our display error function too. Now, once we want to get our weather data after we have a city, now we actually need to fetch the weather data. we'll have to create a URL. We'll create a constant of API URL. This is what we'll pass to the fetch function. We will use a template string. Be sure to use a pair of backticks. We'll need to get the following URL. At this web page, we need to find the API call where we can pass in a city name. We can copy this within our template string. We'll paste it. We'll replace the city name with the placeholder and use our city variable. For the API key, we'll use a placeholder. Pass in the API key. This is what we'll pass to the fetch function. We will create a response, const response, equals await. We can use await because we're within an async function. We will fetch our API URL. Once we have a response, let's check our response. Let's console.log our response just to see what it is. Okay, I will type in the city of Miami, get weather. Our data should be within console.log. Here's our response. It has a status of 200, and it's okay. We need to check to see if our response is not okay. What if we couldn't retrieve the data? I'll make up some gibberish city. Let's go to inspect, console. We have a response. Status 404. The response is not okay. We'll write an if statement. If our response is not okay, we will throw a new error and pass along this message. Could not fetch weather data. Else, if our response is okay, we will return the response. And we will await our response, convert it to a JSON format using the JSON method. So at the end of this function, return an object that's in a JSON-like format. This data is going to be returned to our event listener. After we get our weather data, we need to display it. We'll work on the display weather info function next. This one. Let's console.log the data we receive. I will type in Miami. So it looks like that worked. We have a name of Miami for the city. We have the weather, which is an array. It's an array of objects. We have coordinates, clouds, pretty much anything you can think of regarding the weather. Let's get the name. Within main, there is temperature. The temperature will be in Kelvin. We need to convert it. I'll get the humidity. Within weather, it's an array of objects. We will get the description, overcast clouds, and this ID. Eventually, we'll use the ID to return an emoji. There's different weather codes. I'll explain that later. So we're going to use some object destructuring. Const, use object destructuring with a set of curly brackets. We will access the name property and create a variable of city. City will be Miami in this case. Then we will access main. Main is a property that contains an array. Take main, use object destructuring again. Now we're within a nested object. I would like the temp and the humidity. Then let's select our weather. So weather, it's an array of objects. We'll have to use array destructuring followed by object destructuring. Give me the description and the ID. We have to set this all equal to data to use destructuring. And let me organize this to make it look nice. Our data is one gigantic object that has nested objects and nested arrays. So after destructuring, we'll have these variables: the city, the temperature, the humidity, a description of the weather, and an ID for the weather code. Now we can use these like variables. So with our card, currently we're not displaying it. Now I would like to display it. We are going to take our card, set the text content to be an empty string. If there's already some text here, we would like to reset it, such as if there was an error message. Take our card, access its style, set the display property to be flex for flexbox. Just to be sure that this is working, I'm going to get the weather without entering a city. After we do type in a city, it should reset. That's good. That's what we wanted. Or if we make up some gibberish, we have that error. Could not fetch weather data. But then if we type in something legitimate and get the weather, it'll reset. That's what we would like. Okay, now we have to create the elements. The elements that we previously deleted from the div element. We need to recreate those. We will create a constant for city display to display the city. Document.create element. Our city display was an H1 element. Let's copy this line of code and paste it a few times. 4 additional times. We have city display, temp display for the temperature. That was a paragraph element. Humidity display. Humidity display. That was also a paragraph element. A description display, which we shortened to desk display. That was also a paragraph. And a weather emoji. Weather emoji. And that was also a paragraph. Okay, now we need to change the text content of each of these elements, but they're empty, so to say. Let's take the text content of our city display dot text content property equals our city variable that we destructured. Okay, let's see if that works. I'll type in a city, get weather. Oh, and then we need to append it. Take our card, append child. We will append the city display element. Let's try that again. Type in Miami, get the weather. That should display Miami. Let's try Dallas, Texas. Dallas. Oh, and before displaying it, we need to add the class list, the CSS class for the city display. After adding the text content, we will take our city display, access its class list, add the class, the CSS class of city display. So then, when we type in a city, we should have that CSS styling. All right, now we have to add the temperature, following the same format. We will take our temp display, access the text content equals, I'll use a template string with a pair of backticks. I'll add a placeholder, pass in our temperature, add a degree symbol. You can hold Alt, then type 0176 for a degree symbol. Now this is normally in Kelvin. Actually, I don't think Kelvin uses the degree symbol, but we'll be changing that momentarily. Take our temperature display, access its class list, add the following class. Add the CSS class of temp display. Then we have to append the element to the card element. Take our card, we will append a child element of temperature display. So now we should see the temperature, but it's going to be in Kelvin. We have the city and the temperature. For the temperature, if you would like Celsius, let's use degrees Celsius. You have to subtract from the temperature 273.15. Okay, but now we should probably round it. So let's enclose this equation within a set of parentheses, follow this with the to fixed method of numbers to round it to 1 decimal place. 15.6 degrees Celsius. If you would like a Fahrenheit temperature, this is the formula. Take our temp in Kelvin minus 273.15. We will multiply this by 9 divided by 5, plus 32. So let's enclose this all within a set of parentheses. So now we should get that temperature, but in Fahrenheit. Oh, and then add F to the end. 60 degrees Fahrenheit. Then we'll get the humidity. So take our humidity display element that we created, access the text content, set it equal to be a template string using a pair of backticks. Let's add the word humidity, :space, add a placeholder, display our humidity variable. We'll add the class list of humidity display, access its class list, add the following class of humidity display. Then we have to append the element to the card element. Card.append child, append our humidity display. So we should get the humidity. Miami, 60 degrees Fahrenheit, humidity 81. Let's add %. 81%. Yep, that does work. Then we'll add the description. A description of the weather. Take the element of description display, access the text content equals the description. Then add the CSS class to the class list for this element. Description display, access the class list, add the following class of description display. Then add the element. Card.append child, we will append our description display. Let's type in Miami, get the weather. Currently in Miami, there's overcast clouds. Now we have to get an emoji based on the weather. With our element of weather emoji, we will access the text content equals, we will call the get weather emoji function, but we have to pass in a weather ID. So we will pass in the ID variable that we receive from data. Once we get our weather emoji, we'll work on that momentarily. We'll take our element of weather emoji, access the class list, add the following CSS class of weather emoji. Then append it to the card. Card.append child, we will append our weather emoji. All right, now before we can test it, we need to fill in the get weather emoji function. So with this Open Weather AI, there are different group codes. So our weather ID is going to be either within the 200 range, meaning a thunderstorm, the 300 range means drizzle, 500 is rain, 600 is snow, 700 is atmosphere, such as mist, smoke, or even a tornado. 800 exactly is a clear sky. Anything greater than 800 means clouds. So our weather ID is going to be one of these codes. So we're going to use a switch. We will examine the Boolean value of true. Does the value of true match one of these cases? We'll have a case for group 200. If our weather ID that we pass in is greater than or equal to 200, and the weather ID is less than 300. That means there's a thunderstorm. We will return an emoji, a thunderstorm emoji. Thunderstorm. I don't like the look of that one. That's better. Okay, group 300 is a drizzle. So let's copy this case because I don't feel like retyping it. If our weather ID is greater than or equal to 300 and less than 400, that means we have a drizzle. We'll just add an emoji of a raining cloud. So group 500 is also rain, but it's a heavier rain. So let's copy this case, paste it. If our weather ID is greater than or equal to 500 and less than 600, we'll return rain as well. Group 600 is snow. If our weather ID is greater than or equal to 600 and less than 700, we will return a snowflake, meaning snow. Then we have group 700. If our weather ID is greater than or equal to 700 and less than 800, we'll return some fog emoji. 800 exactly means a clear sky. We can display the sun. If our weather ID is strictly equal to 800 exactly, we'll return a sun emoji. Anything within the 800 range means clouds. So if our weather ID is greater than or equal to 801, 800 means clear sky. So with this group code, it only goes up to 809. If our weather ID is less than 810, return a cloud. Then let's add a default in case we get a weird weather code. Default, return, I don't know, a question mark. We get some unknown weather phenomena. UFOs or something, I don't know. Okay, and I think that should be everything. Let's close out of this, close out of these functions. And now if I were to type in Miami and get the weather, in Miami it is 60.3 degrees Fahrenheit, humidity 81%. There's overcast clouds, and we get a cloud emoji because it's cloudy. Let's try Dallas. We have a clear sky, 45 degrees Fahrenheit, humidity 63%, clear sky, and we get a sun emoji. All right, everybody, so that is a weather app that you can make using JavaScript, HTML, and CSS.